Yeah, hi everyone. Welcome to PrepFusion. So a much awaited video. People were asking the content on analog electronics. So first, let's see that who should be watching this particular video. So if you are someone, sir, I am having zero knowledge of analog electronics. I never studied analog electronics in my life. Can I study? Yes, you can study. Yes, simple answer is yes. I am starting right from the zero. Just by some basic concept of network analysis. From there I am starting. If you have just studied basics of network in your life, then also you will be able to understand this particular video. Okay, so zero knowledge on analog. Can I watch it? Yes, you can watch it. You can study it. You should study the complete 9 hours, and after that you will feel very much confident in analog electronics. Okay, now sir, I have already studied analog, but I am struggling in analog. Will it be helpful for me? Surely it will be helpful. What all topics we are covering? We are covering OpAmp in open loop and negative feedback. We are covering. We are studying MOS amplifier. Then we are studying about OpAmp in positive feedback. That means we are studying about Smith triggers, non-inverting, inverting, and A-stable multivibrator, monostable multivibrator as well. Like basically, we are going to study about multivibrators, right? And then we will see some gate questions as well. So there is very high chances that you are struggling in these topics, right? In negative feedback, that is fine for everyone, but a lot of people struggle in positive feedback. They struggle in multivibrators. They struggle in MOS amplifier as well. So there it will help you. And after that, what you can do is that you can watch this particular video, or before watching this video, you can watch this particular video. Here I have picked up 10 analog electronics PYQs from 2021 to 2025. From EC, electrical and instrumentation, I have picked 10 analog electronics PYQs, which are very good. And a complete different approach without formula, without using a single formula, we have solved those problems. So here, after watching this video, you will feel very much confident in analog. If you are someone who has already studied analog, if you are someone who is having zero knowledge, just watch this video. If you are someone who has already studied, then first go here, then come back to this particular video. Okay, so first go and watch this particular video. Here you will feel like that, yes sir, I am learning something new. Now I am more comfortable. Now I am more confident in analog electronics. But if you are someone who is starting afresh, no knowledge of analog electronics, start from here. Understandable? So how one should be watching this video, is that clear to you? What is my expectation? Comments. You guys will be commenting down that, sir, this is what I felt after watching this particular video. I used to feel that analog is this subject, that subject, but sir, it is purely based on basics. Okay, you will realize that after watching this particular video, after watching 1 hour, 2 hour, or 3 hour, if you feel like that, sir, yes, something productive we are learning for the first time in analog, comment down. Okay, so this is not a comprehensive course, crash course it is, but at any point you will not feel like that, sir, it is like a crash course. You will feel like that, sir, it is like a comprehensive course only. Okay, so watch this video and after that comment down, and likes also we will expect. So likes, I am expecting that I will be getting 500 likes. This is the target I am putting. I am not putting the target of views, but let's set up the target of 500 likes. Okay, well and good. Yeah, so let's get started with the video. Timestamp would also be there. Let's get started with the open loop. OpAmp in open loop. What is the meaning of OpAmp? So we will start right from the basics. Okay, yeah, let's get started with the video. Thank you. And yeah, one more thing, sir, what about the notes? So notes I will upload in Telegram. Okay, notes I will upload in Telegram. And what is the name I should give? The name I should give is analog one shot. Okay, analog one shot. This is the name I am going to give. Analog one shot. So notes I am going to upload in the Telegram. Printable notes I will upload. That means you can get the printout. So printable notes I will upload. Well and good. Okay, so yeah, that's it. Let's get started with the video. Yeah, hi everyone, welcome to PrepFusion. So now we are going to study about OpAmps, operational amplifier, which is a topic of analog electronics, and usually it is asked for 4 to 6 marks in the examination. Sir, in my life I never studied analog electronics. Can I study from this particular video? Yes, you can study. Sir, I have never studied network analysis. Can I study? No. At least basics of network should be clear. Okay, basics of network should be clear. Not the complete network analysis, but basics should be clear. Like if I ask you what is the potential V2, you should be able to tell. These basics should be clear. Although I will try to clear the basics again, but still it should be clear to you. Then you can proceed in this particular video. So we will get started. We will slowly move to OpAmp. It's not that, sir, directly let's start OpAmp. We will slowly move so that you feel more comfortable. So first, before that, you will answer me some basic questions of network analysis. Very basic questions. Basic questions of network analysis. So let me know what will be your V2 in terms of V1. So sir, I am starting from here. The potential of this node is V1. When I go to this particular node, from V1 to I am going to this particular node. What will be the potential? So that would be V1. Then when you are here, look back. There is a negative sign, -2. So potential of this node is V1 minus 2. Now go from here to here. So already I was having potential V1 minus 2. Now look back. What is the sign? Plus sign is there. Like you know about the battery, no? This is negative, this is positive, right? So look back. What is the sign? Positive sign is there. So V1 minus 2 plus 3. What that would be? V1 plus 1. Now from here to here again you go. So sir, already I was having V1 plus 1. V1 plus 1. Just look back. What is the sign? Positive sign is there. So it will become V1 plus 2. V1 plus 1 I was already having. Then plus 1 added again V1 plus 2. Now again jump and look back. So what was the potential you are having? V1 plus 2. Now look back. What is the sign? Negative sign minus 3. So what you are getting? V1 minus 1. Now again jump and look back. So V1 minus 1 you are already having, and when I looked back, plus 2. So what you are getting? V1 plus 1. So what is the potential here? V1 plus 1. That's it. So V2 is equals to V1 plus 1. So jump, look back. Jump and look back. Started with V1, jumped, look back, minus 2. Jumped, look back, plus 3. Jumped, look back, plus 1. Jumped, look back, minus 3. Jumped, look back, plus 2. So plus 2, this is 3 plus 4 plus 2, 6 minus 3 minus 2. So 6 minus 2 plus 1. So V1 plus 1. So V2 is becoming V1. V2 is V1 plus 1. Say yes or no. So similarly here what will be V2? Someone would say that sir I can apply the nodal analysis or whatever it is. I can put in this manner that V2 minus V1 divided by R would be equals to I. So V2 would be equals to V1 plus IR. Or what you can do is that in the direction of current, how the potential will be dropped? The current is flowing from right to left. So potential will be also dropped in this manner only. Now what will be that drop? That drop will be IR. Now again do the same thing. This potential is V1. From here to here I am going. Jump, look back. So already I was having V1 potential. When I jumped and looked back, what sign I was seeing? Plus sign. So V1 plus what is the potential? Potential is IR. V1 plus IR. That's it. So this is how you should be able to write down. In the direction of current, the potential will be positive. So current is flowing from right to left. So potential will also be there from right to left. V1 plus IR. That's it. Now again new question. What will be the current here? Sir, this potential is 0. Ground means 0 potential. So this potential is also 0. 2 minus 0 divided by 1. How much current would be flowing? 2 ampere current would be flowing. Now here 2 ampere current is flowing. Now this current is having two paths. One path is this, other path is ground. Where it will go? To the least resistance path, right? So in the ground, how much current would go? 2 ampere current would go. And here 0 ampere current would flow. Why is that so? Because this potential is 0, this potential is 0. 0 minus 0 divided by 1 milliohm. What is the answer? 0 ampere current only. No matter whatever the value of this resistance is, always here there will be 0 ampere current. Say yes or no. All the current will be going in the ground. Understandable? Right? Find out the potential of V0 in terms of V1. Or V1 in terms of V0, whatever you want to find, you can find that. Just let me know one thing. If here the current is I, then what will be the current here? That will also be I. Right? Both are in series, no? I. Current is I. Right? So what you can write down? Sir, V0 is equals to I into RF plus R. And what will be your V1? Sir, V1 will be, current is flowing in this direction, so drop would be like this. So this potential is 0, 0, jump and look back. 0 plus jump and look back, IR. So V1 is simply IR. So if I find out V0 by V1, what I am getting? RF plus R upon R. Say yes or no. So V0 is coming out to be 1 plus RF by R into V1. Or what you could have simply done, what you could have done, if both are in series, then you can apply the concept of potential division. Have you studied this concept? Potential division. So what will be V1? If both RF and R are in series, so across RF plus R, there is V0 potential, and across R, there is V1 potential. So directly you can write down what will be my V1. From here you can directly write down V1 would be nothing but R upon R plus RF into V naught. This also you could have directly write down. This is this is known as concept of potential division. You might have studied in this manner. This is your V1, this is your V naught. This is resistance R1, this is resistance R2. So what will be V1? V1 will be nothing but R2 into V naught upon R1 plus R2. R2 into V naught upon R1 plus R2. Like basically, V naught is there across R1 plus R2, but V1 is there across R2 only. So V1 will get the portion of R2 only, V naught will get the portion of R1 plus R2. So this is the relation you can get. So this is known as concept of potential division. If you don't know the concept of potential division, it is fine, but at least understand this particular scenario. Is that understandable to you? All good? All fine? Let's go to the next one. Now you need to put V naught in terms of V1, V2 and V3. Just write down simple equation, nothing else. I want you to write down the nodal analysis. Can you apply the nodal at V naught? If this node is V naught, if this node is V naught, then there is no resistance, no resistance, no resistance. That means this node will also be V naught, right? So let's apply nodal at V naught. So from this V naught, how many branches are going? This branch is going. From here, this current is also going. This current also can also go, and this is also an outward current. So V naught minus V1 divided by R1. This is the outward current. V naught, this node is also V naught, this node is also V naught, and this node is also V naught. So V naught minus V1 divided by R1, outward current, plus V naught minus V2 divided by R2. Say yes or no? V naught minus V2 divided by R2, this is the current, plus V naught minus V3, V naught minus V3 divided by R3, plus there is another current. What is that? Zero current. That is equals to 0. This is known as KCL. We are simply applying KCL. V naught minus V2 divided by R2, V naught minus V1 divided by R1, V naught minus V3 divided by R3, plus zero current is also there, that is equals to 0. Now let's just say R1 equals to R2 equals to R3. R1 equals to R2 equals to R3, that is equals to R. So what you will be getting? V naught will come out to be, this will become R. So R will go there. Simple mathematics you can do, right? So this will become 3 V naught, that would be equals to V1 plus V2 plus V3 divided by 3. So this will be your V naught. Understandable? Okay, if all the resistance are equal, then this will be your V naught. Now this is the scenario. You need to apply the nodal here. I am saying that this potential is 0 volt. What I am saying? I am saying that this particular potential is 0 volt. This particular potential is 0 volt. So apply nodal at 0 volt. Can you apply the nodal at 0 volt? Yes, sir. Outward current. This would be the outward current. This would also be outward current. This would also be outward current. So addition of all outward current would be equals to 0. So 0 minus V1 divided by R, plus 0 minus V2 divided by R, plus 0 minus V naught divided by R, plus this is also outward current, which is 0 only, equals to 0. Addition of all the outward current would be equals to 0. 0 minus V1 divided by R, plus 0 minus V2 divided by R, plus 0 minus V naught divided by R, plus 0 ampere would be equals to 0. What you are getting? From here, what you are getting is that V naught is coming out to be minus V1 plus V2. Yes or no? This is 0, so no meaning of this. Then R can go simply here. That will also be gone. And now this V naught goes here. So V naught is simply coming out to be minus V1 plus V2. This is the V naught that you are getting. Okay. Now this is the circuit. Again, this is 0 volt. Apply the nodal. Outward current. Outward current. Now there is another outward current, which is this. Do you know this current? No. But let's try applying the nodal. 0 minus V1 divided by R, plus 0 minus V2 divided by R. Let's just say I don't know this current. This current is I. Okay. So plus I equals to 0. Now what is this I current? If this node is 0 potential, then this node is also 0 potential only. So what will be the current here? This node is 0, so this node is also 0. So what will be the current here? 0 minus V naught divided by R, which will be minus V naught by R. Are you able to understand this point? If this node is 0, this node is 0, this node is also 0, 0 minus V naught divided by R, this is the current. So in upward direction, there is minus V naught by R current flowing. Now this minus V naught by R current is flowing. So from here, how much current would be going? This current is 0, no? This current is minus V naught by R. This current is 0. So what this I has to be? This I has to be nothing but minus V naught by R only. Actually, this circuit and this circuit both are same. What I did, I just put this wire ahead, nothing else. What I did, I just pulled this wire ahead. Just pull this wire ahead. What you will get? This scenario you will get. A lot of people get confused that sir, this current is 0, so what will be like, what will be this current? I don't know. I am applying nodal at 0, 0 minus V1 divided by R plus 0 minus V2 divided by R plus this current I. Now what is this current I? Sir, I don't even know. So that current I is nothing but the current in this branch only, because here you are saying that sir, 0 ampere current is flowing. So 0 minus V0 divided by R. 0 minus, so simply put here, minus V1 by R minus V2 by R minus V0 by R. That would be equals to 0. So V0 is coming out to be minus V1 plus V2. Again, the same scenario is there. Just wire is pulled, nothing else. Well and good. Job done. So this is the basics of network that we wanted to see. Now let's study something. We are going to study amplifiers. Okay. So can you write down the potential V0 here? What will be the potential V0? Here current is I. So here also there will be I current only. Why is that so? Because both are in series. If both are in series, I can apply the concept of potential division. So what will be V0? V0 will be nothing but V0 is there across 2R, but Vi is there across R plus 2R. So R plus 2R into V. So what is V0? V0 is nothing but 2 by 3 V. This is your V0, which is 2 by 3 V. Now what I do is that I put all of this into a box. Whatever the circuitry is there, no? So I have put all of this into a box. Now what I am saying is that there is a box, there is this particular box. No matter whatever the kind of input you apply to this particular box, your output will be always 2 by 3 times of the input that you apply. If you apply 3 volt, output will be, output will be 2 by 3 into 3, that will be 2 volt. If you apply 6 volt, what will be the output? 2 by 3 into 6, that will be 4 volt. So this is the scenario that I have made up. That here, this is known as gain. The gain is 2 by 3. Whatever the input that you are applying, that will be multiplied with 2 by 3, you will be getting the output. Can you call it amplifier? Actually, we should call it attenuator. Like I am applying 3 volt, I am getting 2 volt. I am applying 6 volt, I am getting 4 volt. What is the meaning of amplifier? That voice should be amplified, input should be amplified. When you are applying 3 volt, you should get 5 volt, 6 volt, 7 volt, 8 volt. But this is not happening, no? Your input is getting reduced. Let's just say I am saying hello. You expected that, sir, on loudspeaker it will be heard in a very loud voice. But actually what really happened? Whatever my actual voice was there, it was heard in a even lesser manner. I said hello, but it was heard as hello. You expected it to be much louder, but it did not happen. So although it is not known as amplifier, this is attenuator, but you consider that it is amplifier only. Using a resistor, you can never make an amplifier, right? For making an amplifier, you use 3 terminal devices, that is known as MOSFET. So we will study that in this video only, but as of now, you consider that this is an amplifier only, which is having a gain of A. Okay, so let's study about amplifier. Amplifier will have a particular gain A. If I am applying voltage V in, my output V0 is A into V in. Now this A is known as, I am calling this as voltage gain. Why voltage gain? Because whatever the scenario that you have studied here, that you have studied with respect to voltage, right? Your voltage is being amplified. Your voltage is being amplified, and this is known as voltage amplifier as well. So I am calling it as a voltage amplifier as well. OpAmp is actually a voltage amplifier only. It can work as a current amplifier, but it is actually a voltage amplifier. It can work as any kind of amplifier, but OpAmp will also be a voltage amplifier only. So this is a voltage amplifier which is amplifying the applied input voltage, that is V0 equals to A into V. So can I draw the graph between V0 and V? So V0 equals to A into V, so the graph should go somewhat like this. Simple mathematics, linear graph should be there. In that manner, it will keep on going. Say yes or no? Right? V0 is Y. A could be some any value. Let us say it is 2. V in is X. Y equals to 2X graph. This would go like this, no? So this graph we have made. But no matter whichever the IC you design, whatever the circuitry you design, the circuitry would always work between some supply voltages. Okay? whatever the amplifier we design, it will always work between some supply voltage. Like it will have a maximum supply, let's just say it is having maximum supply of 5 volt, and it will have some minimum supply as well. Let's just say it is having minimum supply of minus 5 volt. So all the circuit, like all the IC that you see, any circuit you see a fan or laptop, whatever you see, they always work under a certain supply. It will have a maximum supply, it will have a minimum supply. So in this particular IC, in this particular box, no potential can go above 5 volt, no potential can go below minus 5 volt. What I am saying, in this particular box, at any node, no potential can go above 5 volt or below minus 5 volt. Let's just say I am saying that this particular amplifier is having voltages, supply voltage of plus 5 and minus 5, plus 5 volt and minus 5 volt. Now I applied some input. Because of that input, my output, mathematically my output was coming 6 volt. So mathematically it can happen, but in reality it will never happen. Your output will be saturated. Are you able to understand this point? That means your output can never go above 6 volt. If you feel like that it will be 6 volt, but actually it will be saturated at 5 volt only. I applied some input, sir. Mathematically it was going to minus 7 volt, but actually it will never reach minus 7 volt. It will be saturated at minus 5 volt only. So any IC you see, any integrated circuit you see, any circuitry you see, that will always work under some supply. It will have a maximum supply, it will have a minimum supply. No node can go above that particular supply, no node can go below that particular supply as well. That means this linear graph that I have made, actually this is not the correct graph. The output can never keep on increasing. After a certain voltage, it will be saturated. After a certain voltage, it will be saturated. So that saturation voltage will be the supply voltage. So output can never go below minus 5. It can never go above plus 5. Is that understandable to you or not? What will be that value of input? I don't care about it. Okay, what will be that value of input here? I don't care about it, but I can say one thing, that output can never keep on increasing. So this is your amplifier. Now what this amplifier is doing? Sir, you apply a particular voltage, it will be amplified. But what we did now, we designed a operational amplifier. Now operational amplifier was amplifying the difference of two voltage. What it does? It amplifies difference of two voltages. Here what was the scenario? Only one voltage is being amplified, but this operational amplifier will amplify the difference of two voltages. Okay, so what we do, this is how it will look: plus, minus. What is the meaning of this plus minus? I will tell you. And this is your output V0. Here there was only one input. Here difference of input it will be amplifying. Let's just say it is having a gain of A. So what will be your output? Here what was the output? Output was A into V. Here output will be A into. At plus what is the potential? V1. At minus what is the potential? V2. But it is at minus, no? So there is a negative sign. Is that understandable to you? So this is your OpAmp. This is known as OpAmp. V0 is A into V1 minus V2. This is also a voltage gain only. We are talking about voltage here. We are talking about voltage here. Output is also a voltage. So this is also a voltage gain. Okay. Voltage gain. This is also a voltage gain. So it is having a voltage gain of A. So what will be the output? A into, at plus what is the potential? V1. At minus what is the potential? V2. Now this plus minus can be interchangeable as well. Like it's not that, sir, on the upper side you will put plus always. Nah, I can put like this as well. Let's just say this is 3 volt, and let's just say this is 2 volt. This is your V0, and this gain is, let's just say 10. So what will be your V0? Can you let me know? So that would be 10 into positive potential 2 volt minus negative potential 3 volt. What will be the answer? Minus 10 volt. Is that understandable to you? 10 into 2 minus 3. That's it. This will be your V0. Now this positive potential, it is known as non-inverting terminal. Non-inverting terminal. Okay. What it is known as? Non-inverting terminal. Just the naming, it is not very tough. Inverting means invert. Invert means negative. So it is plus, so that's why it is known as non-inverting terminal. So what will be the name of this? The name of this will be inverting terminal. Invert means negative, inverting terminal. Okay. Now I told you one thing here. Any amplifier will have a certain supply. So just like any kind of amplifier, this is also amplifier only, so this will also have some supply. That supply is, this is how it is shown, plus Vset minus Vset. So usually when we design any IC, so we show the highest supply here and lowest supply downward. But it is not necessary. In the examination, you may see that, sir, here minus Vset is written, here plus Vset is written. It might happen that, sir, here plus 5 is written, here minus 5 is written. And it is not necessary that, let's just say it is 6 volt. So it has to be minus 6 volt only. It could be anything. Are you able to understand this point? It could be 3 volt as well. It could be minus 3 volt. It could be 0 volt as well. It could be plus 2 volt as well. But this is the maximum supply, this is the least supply. Is that understandable to you? Okay. So just like any other IC, it will also have some saturation voltage. Now let's just assume that this saturation voltage is 5 volt. What does that mean? That means the output can maximum go up to 5 volt and minimum it can go up to minus 5 volt. But it is not necessary that it has to be symmetric. That's why if this is plus 5, this has to be minus 5. No. In most of the cases, this will be the scenario, but it is not necessary. If this is plus 5, this could be plus 3 as well. If this is plus 5, this could be plus 2.5 as well. If this is plus 5, it could be 0 as well. It is just that this will be higher, this will be lower. That's it. But in most of the scenarios, they will be symmetric. So this is plus 5, this is minus 5. Is it necessary? Is it necessary to show this upward or downward? No. Nothing is necessary. Negative sign could be shown upward, positive sign could be shown downward. This could be shown upward, this could be shown downward. Is that OpAmp clear to you? So it is amplifying the difference of two voltages, V0 equals to A into V1 minus V2. Is that understandable to you? Okay. It will also have some saturation voltage. Saturation means the output can never go above plus Vset, it can never go below minus Vset. It will also have a voltage gain, which is the voltage gain here is A. Now we are taking an example that my saturation voltage is plus minus 5 volt and my gain is 1000. So what will be your output V0? So can you write down the output V0? Yes, sir. Output V0 will be A into V1 minus V2. V1 is the positive terminal potential and V2 is the negative terminal potential. So what is the gain A? Gain A is 1000 into V1 minus V2. 2 milli minus 1 milli. What is the meaning of milli? Milli means 10 to the power minus 3. So what you will be getting? 10 to the power 2 into 10 to the power minus 3 1 and minus 10 to the power minus 3. So it will be 10 to the power minus 3 only. That means 1 volt. So V0 is coming out to be 1 volt. Is there any problem? No problem is there. Why is that so? Because this guy is saying that the potential can never be above plus 5. Is it above plus 5? No. It can never be below minus 5. Is it below minus 5? No. There is no issue. This output is correct. What about this one? What will be V0 here? 1000 into V1 minus V2, because this is the positive terminal potential and this is the negative terminal potential. So V0 will come out to be 2.5. Is there any issue? No. It is between minus 5 to 5 only. What if this is the scenario? V0 1000 into V1 minus V2. 7 milli minus 2 milli. What that would be? 5 milli. What is the answer you are getting? 5 volt. Is there any issue? No. The point is that output cannot be above plus 5. It can be equals to plus 5. Yes, there is no issue here. What about this scenario? V0 is 1000 into 7 milli minus 1 milli. What that would be? 6 millivolt. What is the output you are getting? 6 volt. There is an issue. Output we are getting is plus 6 volt. So actually this will never be the output. When you apply the input here, you will not see the output is coming out to be 6 volt. Because output can never be above plus 5 volt. It can never be below minus 5 volt. So actual output will be plus 5 volt only. Is that understandable to you? Okay, so this is the correct answer. In the examination, simply they will give you this particular setup. They will put the value of V1 as well, V2 as well, and they will ask you what is the output voltage. They will mention the saturation voltage as well. You will solve in this particular manner. Your answer would come out to be 6 volt, but that would be wrong. Answer will be 5 volt. Because output can never go above plus 5 volt. So always notice these saturation voltage. They are very, very, very important. Whenever the equation of OpAmp is coming, our first eyes will go to the saturation voltage. Okay, well and good. Now what about this 1000 into, now V1 is lesser, okay, this V1 is less, this V2 is more, so 1 milli minus 6 milli, 1 milli minus 6 milli, what is our output? Minus 5 volt. There is there any issue? No issue there, absolutely no issue, because output can be minus 5 volt. Here in this scenario, is there an issue? 1000 into 1 milli minus 3 milli, what that would be? Minus 2 volt. Is there any issue? No issue, output can be minus 2 volt. But what about this one? 1000 into 1 milli minus 7 milli, what is the output you are getting? Minus 6 volt. Is that correct? No, because output can never go below minus 5 volt. That means output has to be minus 5 volt only. Okay, so that's the correct answer. Is that understandable to you? So can you draw the graph between V0 and V1 minus V2? Can you draw this graph? That sir, for some times it will provide a gain of A only. Constant gain it will provide, but after that it will saturate. It's not that sir V0 will keep on rising up. No, V0 will not keep on rising up. It will not keep on going down. It will have to saturate between two voltages. What are these voltages? Sir, the name of these voltages were minus V set and plus V set. Yes or no? So till this particular point, it was providing a gain of A. Here you can see that it was providing a gain of 1000. But here the gain of 1000 is there? No. Actually, you applied the difference voltage to be 6 volt. Difference voltage was 6 millivolt. Difference voltage 7 millivolt minus 1 millivolt, 6 millivolt. So if it was providing a gain of 1000, then your output should have been 6 volt. But actually it is plus 5 volt. So it is not providing a gain of A here. Okay, so concept of gain is gone here. Are you able to understand this point? Concept of gain is gone. So what you will simply say, output is saturated. Output is saturated at 5 volt. Or you can say output is saturated at plus Vset. Or it could be saturated at minus Vset as well. But till this point, when V1 minus V2 is, let's just say when V1 minus V2 is 1 millivolt, it was providing a gain of 1000. When it was 2.5 millivolt, it was providing a gain of 1000. When it was 5 millivolt, it was also providing a gain of 1000. But here it was not providing a gain of 1000. Understandable? Now try solving this particular question. How will the output waveform look like? What will be your V0? V0 will be simply A into positive terminal potential, that is V, negative terminal potential, that is 0. So V0 will be simply A, which is 1000, into V. So your V0 will be simply, this should be multiplied with 1000, right? This waveform, which is a sinusoid waveform, this should be multiplied with 1000. So you would say that sir, V0 would be simply 1000 into, what is the input voltage? That is 10 millivolt sin omega t. So V0 will be simply, sir, this is 10 to the power minus 3. So answer would be, sir, 10 sin omega t. Is that correct? Is that answer correct? No, absolutely wrong. Why is that so? Because what 10 sin omega t would say? That sir, maximum value could be plus 10 and minimum value could be minus 10. But will it happen? No. Maximum value could be plus 5, minimum value could be minus 5. So yes, output will try to follow this 10 sin omega t. The graph will try to go like this, but just as the output is becoming above 5, just as the output is becoming above 5, what will happen is that output will be saturated. Then it can decrease in this manner. It will keep on decreasing. It will keep on decreasing. Now, just as it will try to go below minus 5, what will happen is that output will be saturated. Then again, the same cycle will keep on repeating. It can never go above plus 5. It can never go below minus 5. Is that understandable to you? So this will be plus 5 volt and this will be minus 5 volt. Can you let me know this angle? What will be this angle? Like what will be the, if I draw the graph with respect to omega t. So I am drawing the output graph with respect to omega t. So what will be this angle? Can anyone tell? 5/6. Why is that so? when you will get output to be plus 5 volt for the first time, input is increasing. Let's just say input is 1 millivolt. So what will be the output? 1 volt, no issue. When input is 2 millivolt, what is the output? 2 volt, no issue. Like when input is 1 millivolt multiply with 1000, output is 1 volt. When input is 2 millivolt multiply with 1000, output is plus 2 volt. 3 millivolt multiply with 1000 plus 3 volt. 5 millivolt, output is 5 volt. 6 millivolt, output is 6 volt? No, 5 volt only. That means when the input has reached to 5 millivolt or when the input has reached to minus 5 millivolt, after that output will be, till this point it will be rising, output will be rising, and after that it will be saturated. Then it will be again decaying, again saturated. In this manner the waveform is going. Say yes or no? So let's not make it bad. But did you understand this point? That at 5 millivolt it is being saturated. So if this is 10 millivolt, 5 millivolt, that means sin 30 is 1 by 2. So this has to be 30 degrees, that means pi by 6. This has to be pi minus pi by 6, that means 5 pi by 6. This point has to be 5 pi by 6. Okay, although it is not important, just telling that just basics of signal is revised. Well and good, understandable, right? Now the same question is there, but now I am saying that gain A is very large, or you can say that it is tending to infinity. Very large gain is there. So what will happen? How the output waveform would look like? So let's just say just as Vin is going above 0, let's just say Vin is 0.01 millivolt. This is your Vin, just above 0. What will happen? It will be multiplied with very large value. Let's just say it is 10 to the power 16 or 10 to the power 6 only. Let's take 10 to the power 6. 10 to the power 6 is being multiplied with 0.01 millivolt. What you will get? 0.01 millivolt would be written as 10 to the power minus 5. So you will get 10 volt. Is it possible? No. That means output will be saturated at plus 5 volt. Are you able to understand this point? I am assuming that A is 10 to the power 6. A is very large. Actually, it is infinity. So if it is very large, then a very minute value multiplied with very large value, it will become very large. So output will become very large. But it is not possible. Output can go maximum up to plus 5 volt. So no matter whatever the value of input is there, always output will be plus 5 volt for positive value of input. What about the negative value of input? Let's just say input was minus 0.01 millivolt. The input was minus 0.01 millivolt. If it is multiplied with 10 to the power 6, what is the output you are expecting? Minus 10 volt. Will you get it? No. Why is that so? Because output can go maximum till minus 5 volt only. Right? It can maximum go up to minus 5 volt only. So in place of getting minus 10 volt, what you will get? Minus 5 volt. So did you understand this point? That for positive value of input, you will get plus 5 volt output. And for negative value of input, you are getting minus 5 volt output. Is that understandable to you? So what we are getting? Plus 5 volt, minus 5 volt, plus 5 volt, minus 5 volt, and so on. This is the scenario. Okay, plus 5 volt, minus 5 volt. Okay, plus 5 volt and minus 5 volt. Did you understand how did we make this particular waveform? That sir, if the input is just above 0, then very large value it is being multiplied, so output will be saturated at positive potential. When it is just below 0, very large value is being multiplied, output will be saturated at negative potential. Output is saturated at negative potential. So this kind of output you will be getting. Okay, so this is your output. So this is known as OpAmp as a comparator. We are using it as a comparator. We are comparing Vin with 0 potential. So it is known as OpAmp as comparator. Okay, what it is known as comparator. OpAmp as comparator. So this was also comparator only. This is also known as comparator. OpAmp as a comparator. Okay. Now you will answer me one thing. Okay, I want to test your mathematics. This is mathematics only. V0 equals to A into V1 minus V2. Can I write down V1 minus V2 in this manner, which is V0 by A? Simply I took A here. Yes. Now if I say that A is tending to infinity, I am saying that A is tending to infinity. So can I say V1 minus V2 equals to 0? So this value is infinity. So you can say it that V1 minus V2 will be equals to 0. No. What about this V0? Who knows this V0 is also going to infinity? Who knows this V0 is also very large? What I mean to say is that limit x tending to 0. Right? This is the scenario. So this will be sine 0. Okay, this will not be infinity. Yeah, let's take this 1 by x divided by x. So when x is tending to 0, we need to tend it to infinity actually, no? So we need to tend it to infinity. So x is tending to infinity. What scenario I should take? That value also tend to infinity, e to the power x. Okay. Now when x tends to infinity, so this guy will also go to infinity only, no? Like when x tends to infinity, you would say that sir, e to the power x, x tending to infinity. So simply I can put it 0. That would be wrong, right? Because who knows that this guy is also going to infinity? This guy could also be very large. So you are simply saying that sir, a is tending to infinity. You did not comment about V0. If you say that sir, V0 is a certain value, let's just say V0 is some 1 volt. Now 1 volt divided by infinity, then you can say that yes sir, I can put it equals to 0. So V1 minus V2 would be equals to 0 if a is tending to infinity, only when you are able to comment about V0. Is that understandable to you? So let's hold on to this particular point. We will come back to this point again, but let's understand the concept of feedback. Why I discuss this particular point here, you will be able to understand, but let's understand the concept of feedback first. So what is the meaning of open loop? Open loop means whatever the amplifier that we studied, applied V in voltage, you are getting A V in as the output. This is the meaning of open loop. Now what is the meaning of feedback? Feedback means based on the output that we have received, something should be changing towards the input side. So what will happen is that whatever the output that we have received, that is V0, some portion of the output will go back towards the input side. Some portion of the output will go back towards the input side, being multiplied with some factor, that is beta. This beta could be anything. Let's just say beta is 1 by 2. So output is being fed back towards the input side. Output is being fed back towards the input side. Now what is given? Negative feedback is given, no? So it will be subtracted with the input. What will happen is that it will be subtracted with the input. How will I show it? This is how I need to show it. This cross sign doesn't mean it is multiplication. That means this is, let me show it first, then you will be able to understand. So this was your applied input V in, right? So whatever the output that you got, that was multiplied with some factor. Okay, this is known as feedback factor. Beta is known as feedback factor. So this output was multiplied with some feedback factor. So what it became? V0 is being, this arrow sign should be there. V0 is being multiplied with beta. It will become beta V0. Now beta V0 will reach here. Now this beta V0 will be subtracted from the input. So V in is coming like this, and this will be your beta V0. So from V in, beta V0 will be subtracted. So here what will be the potential? Here potential will be V in minus beta V0. So initially this amplifier A was getting V in voltage, but now this amplifier A is getting V in minus beta V0 voltage. Let's just say like there is some hot water and you put your hand there. In the hot water you have put your hand. Then your brain will get a signal that you are feeling hot air. That means you need to put your hands out. So that's the feedback that you are getting, no? Based on the output. This was the output, like hot water was the output. You put your hand there, you go to know that, yes, my hands are burning. That means I need to put my hands out. So you are getting a feedback. So similarly here as well. This is like a feedback loop. There was some V0. It is being fed back towards the input side. Now what will happen here? Let's just say because of somehow, let's just say this output V0 got increased. Somehow this output V0 got increased. So if this V0 gets increased, beta into V0, beta will be a positive value, okay? Let's just say it is 1 by 2. So if this gets increased, then this will also be increased. Yes or no? If V0 is increasing, then beta V0 will also increase. That means this particular thing will also increase. Nothing is happening to Vin. Vin is something that user is applying. Input is applied by the user. Somehow output got increased. Then this will also increase. Then this will also increase. Now if beta V0 is getting increased, that means it is being subtracted from Vin. So something that is being subtracted, that is increasing. 3 minus 1, that is equals to 2. 3 minus 2, that what that would be? That would be equals to 1. That means this total quantity, that would decrease, no? V0 increase, this value will increase, this value will also increase. From Vin it is being subtracted, so this value will decrease. Now some decreased value multiply with a constant value. This gain A, it could be 2, 3, 4, 5, 6, whatever it is. So decreased value multiply with a constant value, that will also decrease only. Is that understandable to you? If this Vin increases, then this will increase. If this Vin decreases, then this will also decrease. This is pretty obvious, no? So similar thing is happening here. If V0 increases, somehow if V0 increases, let's just say this was my V0. This was my V0, but somehow it got increased. So what really happened? This node increased, this node also increased, this node also increased, so this node got decreased. If this node is getting decreased, that means output will decrease only. So just as the output tries to go very high, what is the notice it is getting? That go back. You cannot keep on going higher. Is that understandable to you? In negative feedback, that's why the name is negative feedback, no? Output tries to increase very higher. Then it got a message that come down. Now what if output try to decrease? Now this was the scenario that we have seen for output increasing. But what if somehow this was the output, this was the output, this was the output, this was the output we were getting, but somehow output thought that I should decrease. So somehow output got decreased. If this node decreases, that means this node will also decrease. Beta into V node, this node will also decrease. That means this will also decrease. Something that is being subtracted, that is decreasing. From 2 to 1 you are going. Beta V node is decreasing. That means something that is being subtracted, that is decreasing. That means this value will increase. If this value increases, that means this V node will also increase. Say yes or no? If this value increases, then simply multiply with a constant factor, so this value will also increase. So when output thought that I should decrease, but what really happened? It got a feedback that you need to increase. Now when it try to increase, it cannot keep on increasing. It will have to decrease. When it try to decrease, it will not keep on decreasing, it will again increase. When it try to increase, it will again decrease. When it try to decrease, it will again increase. So isn't the output stable? Like it tried to go very high, it got a message that come down. When it tried to go down, it got a message that go up. Down, go up. Go up, go down. Go up, go down. That means output will be stable. So in negative feedback, your output will always be stable. Is that conclusion clear to you or not? So this was your negative feedback. So in negative feedback, this guy is stable. Is that understandable to you? What about positive feedback now? You can do the analysis on your own. The same setup, ditto same setup. It's just that now the input will be added. What will happen? Input will be added. Sorry, the feedback fact, like whatever the feedback that you are getting, V0 multiply with beta V0. This will be added with the input. That's it. So this will be added with the input. This value beta was there. This is your V in plus. This is your V0. This is beta V0. Right? So what you will get here? Here I was getting V in minus beta V0. Here what I will get? V in plus beta V0. Right? So if this increases, what will happen? This node will increase. Right? If this node increases, that means here it will increase. If this is increasing, that means it is being added only. V in plus beta V0. Something that is being added, that is increasing. So this node will increase. If this node increases, then this node will increase more. Then again this increases, then again this will increase. Again this increases, then again this will increase. If this increases, again this will increase. Then again multiply, again it will increase. So let's just say this was your output. But somehow it thought that I should increase. If there is a positive feedback, it will keep on increasing. Like I am teaching you this particular concept. If you give me positive feedback, then what will happen? I will bring more concept. But if you give me negative feedback, then what will happen? I will be at my stable output, like stable thing, that I will not bring more concepts. Is that understandable to you? So positive feedback means output will keep on increasing. If it try to increase, it will keep on increasing. But what if it try to decrease? What if it try to decrease? If this decreases, this will decrease. That means this node will decrease. Something that is being added, that is decreasing. Decreasing multiply with a constant value, this will decrease more. More decreases, this will decrease. More, this will decrease. More, this will decrease. More, that means it will decrease more. So this was your output first. It thought that I should decrease. Then it will get a message that decrease more. Decrease more. Keep on decreasing, keep on decreasing, keep on decreasing. So let me know one thing. Here output will be stable or unstable. When output try to increase, it went to very high value. When output try to decrease, it went to very low value. So output is going towards instability. So here your output is unstable. So in positive feedback, your output is unstable. But in our negative feedback, output is stable. Is that understandable to you or not? Well and good. Okay. Now let's come to this particular concept. If I am saying that if A is tending to infinity, and I am saying that V naught by A is 0, because A tends to infinity, so V naught by infinity, that would be equals to 0. Only when V naught is stable. Stable means a certain output would be there. It's not that it is very high or it is very low. It's not that it is going to plus infinity or minus infinity. If I say that V naught is stable, then I can say that, sir, it will be equals to 0. But if I say that this is unstable, this is unstable, then I cannot put it equals to 0. Right? So what does that mean? If I say V1 minus V2 equals to 0, or I can say V1 equals to V2, that can happen only in negative feedback. Only in negative feedback. And this is known as concept of a virtual short. Why virtual short? Because this was our OpAmp, no? What was our OpAmp? This was our OpAmp. This was our OpAmp. This is plus, minus. Here the potential was V1. Here the potential was V2. This was V1. This was V2. Okay. So now what really happened is these two potential has become equal. If there is a negative feedback involved, we will check the negative feedback. But if this particular circuitry is in negative feedback, then you would say that V1 equals to V2. That means they are virtually shorted. Short means same potential, no? If this potential is V1, what will be this potential? This will also be V1 only. No? So they are virtually shorted. So this is known as virtual short. This concept is known as concept of a virtual short. Okay. This is nothing but a virtual short. Right. Now someone will have a doubt. Like, I don't know, I don't think anyone will have a doubt, but I am just putting it in your brain. That, sir, in case of a positive feedback, you have said that output will keep on decaying. Output will try to go to plus infinity. But sir, in case of OpAmp, we know that output can never go to plus infinity. It will be saturated at plus V set. So eventually, sir, in case of OpAmp, this will be a fixed value only, no? Like, in case of OpAmp, either it would be plus 5 or minus 5. No matter whatever the feedback is there. If there is a negative feedback, sir, then sir, this could be 1 volt, 2 volt. If there is a positive feedback, sir, this has to be plus 5 or minus 5. Because in positive feedback, output will keep on decreasing or increasing. So eventually, sir, it will be a constant value only. Now, constant divided by infinity, sir, it has to be equal to 0. That means virtual short should be valid even in case of positive feedback. Are you able to understand this point? Like, this is in this whole gate industry, no one can answer this question which I asked. Okay, although I have already made a video. Like this explanation that I have given, that why this virtual short is valid in negative feedback. This is the explanation have been given in textbook as well, in some interview as well. If the interviewer is asking you this particular explanation, then you will give this explanation. 99% of the interviewer will be satisfied as well. But there is only one lecture of IIT Delhi where the actual concept of virtual short has been explained, and this was asked to me in my TI interview. Okay, for my analog profile interview, this question was asked to me. At that time, I gave this explanation. Then he asked me this same thing only, that when it comes to positive feedback, output would be saturated. You are saying that, sir, it will be applicable in negative feedback, because in positive feedback, output can keep on increasing. But actually, it will never happen. No, output will be saturated. So let's just say V set voltage is +5. So +5 divided by infinity, what that would be? 0. So in positive feedback as well, virtual short is valid. What's the issue there? There is some issue. It will take 50 minutes of time, and it will take a good amount of concentration as well. I have uploaded that video on YouTube. If you want to check it out, you can just search amazing concept of virtual short, PrepFusion Himanshu Agrawal. Amazing concept of virtual short. This is the video, I guess. So there I have explained it. But for that, you need to have a good knowledge of Smith trigger as well, and a lot of things. Like you need to have a good knowledge of OpAmp, then you will be able to understand that. Okay. So that's actually a very good concept that was explained by only, I forgot the name of professor. So that was there in his playlist of IIT Delhi. Okay. From there, when I was asked this particular question in the interview, then I was not able to answer. Then I checked some NPTEL playlist, and there I found the explanation. Okay. So don't have this doubt as of now, but I'm just putting it in your brain, and there is no chance that you are going to get this kind of answer from any GATE educator. Forget about GATE educator. Even in the textbook as well, this is the explanation that has been written. But that is wrong. This explanation is wrong, because again, there is a genuine doubt that, sir, output can never keep on increasing, or it can never keep on decreasing. It will be saturated at a point. That means fixed value divided by infinity. So even in case of positive feedback, virtual short should be valid. But no, only in the case of negative feedback, virtual short is valid. Okay. So only in case of negative feedback, virtual short is valid. Is that understandable to you? Right? So when your virtual short will be valid, first condition is that gain has to be infinity. Like we started from here, no? Gain has to be infinity. So gain has to be infinity. Secondly, there has to be negative feedback. Third, output should not be saturated. If output is saturated, that means output actually tried to go to higher value, no? If output is saturated, that means output actually tried to go to higher value. That means V0 actually try to become unstable. Right? V0 actually try to become unstable. So if your output is saturated, then you cannot apply virtual short. Just remember it. That if my output is saturated, then I cannot apply virtual short. So output should not be saturated. Gain has to be infinity. There has to be negative feedback as well, and output should not be saturated. These are the three conditions for the virtual short to be valid. No other condition is there. First condition, gain has to be infinity. Second condition, negative feedback. Third, output should not be saturated. These three conditions are there for the virtual short to be valid. Sir, how this condition came? That came from a very good concept that I was talking about. Okay, which concept? That, sir, if V0 is saturated, then also I can say that, sir, plus V set divided by infinity, that should be equal to 0. So why this condition is there? So for that, you will have to wait. Okay, you will have to wait a lot. In comprehensive course, you will be able to understand that. Not as of now. Okay, this is not the comprehensive course, no? So just remember three conditions. Gain has to be infinity, very easy to remember. Negative feedback, very easy to remember. Output should not be saturated. That means your output should not be plus minus V set. That's it. Well and good. Now let's see one more thing about OpAmp. Very simple thing it is, that V0 is A into, this time I'm calling it V plus, V minus, because this is the positive potential, this is the negative potential, so that's why I'm calling it V plus and V minus. So just let me know one thing, that if V plus increases, then what will happen? If this guy increases, V0 will increase. Right? From 2 to 3 volt it has become. So V0 will increase. And if V minus increases, then what will happen? V0 will decrease. Very simple thing, no? If this guy increases, if this value increases, V minus increases. So something that is being subtracted, that is increasing. That means this value will decrease. Very simple thing. Very, very straightforward thing. Right? Now there is something called ideal OpAmp. Now this ideal OpAmp is having some properties. First property is that this gain will be infinity. Ideal OpAmp will have infinite gain. The other property is that the input current of the ideal OpAmp, the current that is getting into this plus, the current that is getting into this minus that will be equals to 0. This current would be equals to 0. Is that understandable to you? Gain will be infinity. If ideal op amp is written, gain will be infinity, and this current, input current that is going, that would be 0. Along with that, other properties are also there which is not important for you. That Rin would be infinity, input resistance would be infinity, output resistance would be 0, bandwidth will be infinity, and the slew rate will also be infinity. These are not important for you. These are not important. Only two properties are important. That gain should be infinity and the current that is going inside, that is 0. Sir, why we studied this particular thing? You will understand. Have some patience. Why we are studying the ideal op amp? You will understand. Have some patience. So what is the meaning of ideal op amp? That this gain is infinity. Gain is very large. And the input current, current that is getting into this positive terminal, current that is getting into this negative terminal, that is 0. Understandable? Well and good. Okay. And here also we understood one thing, that if this positive potential increases, output will increase. If this negative potential increases, then output will increase. Sorry, output will decrease. If this negative potential increases, output will decrease. Well and good. Okay. Now let's identify the type of feedback. First, let me know one thing. I'm asking you a simple question. Have some patience and answer this. If there is I current flowing here, then what is the current here? What will be the current? Sir, if this current is I, then this current will also be I. Sir, this current will also be I. Now, sir, this current I is having two paths. Either it can go here or it can go here as well. But you know that, sir, current inside here, that is 0 ampere only, no? The current going inside, that is 0 ampere. That means this current, this complete current I is flowing here as well. Is that understandable to you? So if I need to write down this V1 potential, can you write down this V1 potential in terms of V0? So this V1 potential in terms of V0 would be nothing but, because both of them are having the same current, that means RF and R has become in series. So V0 is exposed to RF plus R, but V1 is exposed to only R. So V1 will be R upon R plus RF into V0. Say yes or no. Why I did so? Because now I want to check the type of feedback. If V0 increases, then what will happen here? What about V1? If V0 increases, then V1 will also increase. Because this is a constant value, no? R upon R plus RF. This will be a constant value. So if V0 increases, then this value will also increase. Now, in case of op-amp, you know that if non-inverting terminal increases, if this negative terminal increases, then V0 eventually decreases. So what you checked here is that, sir, I tried to increase my V0. Sir, I tried to increase my V0. Because of this increase in V0, this potential also got increased. This V1 also got increased. Now, if this V1 got increased, then what really happened? Eventually, V0 is decreasing. So when I try to increase it, it is eventually decreases. What does that mean? What kind of feedback it is? Negative feedback. Say yes or no. Let's see this scenario. If V0 increases, what will happen to this node? Again, the same scenario is there, no? Again, R upon R, RF plus R, this particular thing you can do. So if this node increases, then this node will also increase. In case of op-amp, if this positive terminal increases, then output will increase only. So if this node increases, positive terminal increases, output will increase only. So when I try to increase the output further got increased. Now again it will increase, What does that mean? What kind of feedback it is? Positive feedback. So mostly in 99% of the cases, what you need to see, that sir, from the output, if something is coming back to input, yes, it is coming back. From the output, something is coming back to input, yes, it is coming back. That means there is a feedback. Sir, this is connected to positive terminal, then there is 99% chances are there that it will be positive feedback only. From output, something is coming back to input. From output, something is coming back. Yes, something is coming back. Like if this was the scenario, was there any feedback? No. But from the output, something is coming back. That means, yes, now there is a feedback. From the output, something is coming back. Yes, now there is a feedback. So there is a feedback. The feedback is coming connected to positive terminal. That means there will be positive feedback. Feedback is connected to negative terminal. That means there will be negative feedback in 99% of the cases, not in the 100% of the cases. Okay. What about this one? Output is coming back to input. Output is coming back to input as well. Sir, it is coming in positive direction as well. It is coming in negative direction as well. Sir, both feedback are present. But one will be dominating, no? Let's just say this potential is V1 and this potential is V2. So can you let me know if I say that this current is I2? From here, I2 current is flowing. This current is I2. This current is also I2. This current is also I2. Now you know one thing, that current that is getting into positive terminal, this current is 0. That means this current is also 0. So this current is I2, 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 I2. This current is also I2. The current that is getting inside, that is 0. So what will be this current? This current will also be I2 only. That means from here to here, the same I2 current is flowing. What I am saying is that from here to here, the same I2 current is flowing. This I2 current started. That means this 2R and R that has come in series. So again, can you say what will be V2? Sir, V2 will be nothing but V0 into R upon R plus 2R, that is 3R. So V2 will be V0 by 3. Did you understand this point? And what will be V1? If this current is I, then you know that this current is I1. Then you know that, sir, inside there will not be any current. I1, 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 this current will also be I1. So again, they have come in series. So what will be V1? R upon R plus R, that will be 2R into V0. So V0 by 2. Now if I say V0 increases, then surely, sir, V1 will also increase, V2 will also increase. But who is increasing more? Let us say initially V0 was 5 volt. From 5 to I have made it to 5.1. So this will become 5.1 by 2. And this will become 5.1 by 3. So who increased more? This guy increased more, no? This is V0 by 2. This is 0.5 V0. This particular thing is 0.33 V0. And this is 0.5 V0. If V0 increases, sir, surely this will also increase. And this will also increase. But this will increase more. This will increase lesser. So this potential is increasing lesser. But negative potential is increasing more. That means negative potential increases more and positive potential increases lesser. What does that mean? That means there is a negative feedback involved. So which feedback is there? Negative feedback is there. Is that understandable to you? Output increases, this node also increases, this node also increases, but who is increasing more? This particular node is increasing more. That's why output is actually decreasing. Like when this increases, this node also increases, this node also increases. He will say that, sir, I will increase the output, and he will say that I will decrease the output. Who is more dominating? Negative terminal guy. What I mean to say is that when V0 increases, this guy also increases, this guy also increases. He is saying that I will decrease the output. He is saying that I will increase the output. So who I will listen to? The guy who is more dominating. So this is more dominating, no? So eventually output will decrease. So that means there is a negative feedback. In this scenario, you let me know what will be the scenario. So this is V1. This is V2. So what is V1? Again, they will be in series. So that would be V0 by 2. Or you can write it down 0.5 V0. And what will be V2? So that would be 2 by 3 V0. This will be written as 0.66 V0. So if output increases, then this node will also increase and this node will also increase. But who will increase more? V2 will increase more. So he will say that, sir, I will try to increase the output. He will say that, sir, I will try to decrease the output. Who you will listen to? Who you will listen to? You will listen to this guy because he is dominating, right? So which feedback it is? This is positive feedback, right? So if both feedback are present, always check the dominating one. Okay. Now, although it is not important, but I'm just telling that, sir, some portion of output is coming back to input, right? Some portion of output is coming back to input. So surely there is a negative, surely there is a feedback present. So input is coming back to negative terminal, right? So that's why, sir, there is a negative feedback. 99% of the students and a lot of educator will also say the same thing, that yes, there is a negative feedback involved. But look at it carefully. Voltage amplifier with a gain of -2. If this node increases, what will happen to this node? Gain of minus 2 is there, no? If this is V naught, this node is minus 2 V naught. So this is increasing but in the negative direction. So if this node increases, then this node actually decreases. If this node decreases, then this node is also decreasing. Now, negative terminal is actually decreasing. Your V naught was A into V plus minus V minus. So this potential is decreasing. The something that is being subtracted, that is decreasing. What does that mean? Output will increase. Something that is being subtracted, that is decreasing. That means output will increase. So when I try to increase the output, this node increases, then this node would decrease. Then this node would decrease. So eventually this node will increase. So which feedback it is? Positive feedback. In your examination, always like 99.99% chances are there that if your output is coming back to input, you just see that negative is there, that means it will be a negative feedback. But always you need to be aware that who knows, sir, something else may also happen. In this case, if this V node was increasing, this particular node was decreasing. If this node is decreasing, output is eventually increasing. So there is a positive feedback, even though the feedback is coming to the non-inverting terminal. Even though the feedback is coming to this non-inverting terminal. So even if the feedback is coming here, still you can sense that output is actually increasing. That means there is a positive feedback. So it's like, this is not a guarantee that, sir, if the output is coming back to non-inverting terminal, sorry, if output is coming back to inverting terminal, that means it will be negative feedback, and if it is coming like this, then it will be positive feedback. So just by looking here, you can never say. You always have to check. But in your examination, this particular thing will be satisfied, that if feedback is coming like this, negative feedback is coming like this, positive feedback. Okay, I have to take some break. I will take some break and then I will come back. We will talk about ideal op-amp in negative feedback. Mostly now problem solving is left. Okay, I will just talk about this particular concept and then we will see the problem solving only. You will be able to solve all the gate PYQs. Okay, so let me take a break and then I will come back. Yeah, welcome back. So now we are going to study about op-amp in negative feedback. Okay, so now all the configuration that we are going to see, those configuration will be op-amp being in negative feedback. Along with that, I will take the gain to be infinity as well. In some of the example, I will take a finite gain as well, but as of now we are taking gain to be infinity. Then can I apply the virtual short? You can apply, but along with that there is another condition, that sir, output should not be saturated. Output should not be saturated. Output not saturated. So if this is the condition, then sir, there is something called concept of virtual short that you can apply. That means your positive potential, your non-inverting terminal potential would be equal to your inverting terminal potential. So these two potentials would be equal. Along with that, sir, you already know that input current is always zero. In case of op-amp, in case of ideal op-amp, input current is always zero. So this current is always zero. This current is also always zero. Now I am asking you a simple question. Find out the V naught value. Find out V naught value. That's it. In terms of V. So someone will say that, sir, yes, I can apply the concept of virtual short. So whatever the potential that you are getting at positive terminal, the same potential you will be getting here. Same potential I will be getting here. So what is this potential? This potential is 0 volt. So this potential will also be 0 volt. Now if this potential is 0 volt, can I show it somewhat like this? That, sir, let's show it by ground. Now if this is 0 volt, this is V. So how much current would be flowing here? V in by R. This much current is flowing. Say yes or no. How much current is flowing? V in by R. Now here also there will be V in by R current. Now where this V in by R current would go? This V in by R current would go into the ground. Because current would always see the least resistance path. And this is the least resistance path. So all the current should be flowing into the ground. But actually this will not happen. Why is that so? Because this is known as virtual short. Virtual short means that potential of this node is 0 volt, but you cannot call it ground. Is that understandable to you? So this is just 0 volt. It is not ground. Are you able to understand this point or not? It is not a battery of ground. Like, let us say if this was 5 volt here, so here only the potential will be 5 volt. It will not be a battery of 5 volt. Are you able to understand this point? That's why the word virtual is there. Concept of virtual short. Where did we see it? Yeah, concept of virtual short. They are virtually shorted. So actually if this is the ground, Actually, if this is the ground, that doesn't mean that this is also ground. This is zero potential. That's it. Okay. So this is nothing but zero potential. Now multiple ways are there to solve this particular scenario. So let's solve it one by one. So first, what I can do, I can apply nodal. I am applying nodal at 0 volt. I am applying nodal at 0 volt. So what I can see? So 0 minus V in by R. I am writing down the outward current. This is the outward current. This is also outward current. So 0 minus V in by R plus 0 minus V naught by RF plus, what is the inward current here? Like from this 0 volt, there are 3 branches. 0 minus V in by R, 0 minus V naught by RF, and this 0 ampere current. That would be equals to 0. So from here, what do you see? Sir, V in by R is coming out to be, this is also negative. The scenario is minus V in by R minus V naught by RF. That is coming out to be 0. So from here, V naught is coming out to be minus RF by R into V. So that's the scenario. Now you can find out V naught by V in as well. So this is known as voltage gain. Voltage gain V naught by V in is coming out to be minus RF by R. This is the voltage gain that you are getting. Minus RF by R. Is that understandable to you? Other ways are also there. What all are the other ways? Multiple ways are there, no? So let's see the other way. With respect to current also we can see. How we will see with respect to current? So sir, this is 0 volt. This is also 0 volt. I already know it. So let's just remove this part. This current is also 0 ampere. That also I know. So let's not show it here. If this is 0 volt, sir, this will also be 0 volt. That I know. Now if this is V in, this is 0 volt. So how much current would be flowing here? Sir, V in by R current would be flowing here. Do you agree to this point? How much current would be flowing? V in by R current would be flowing. Now if this current is V in by R, how much current is going inside the OpAmp? 0 ampere. So this V in by R current would be completely going here. Say yes or no. So in this resistor, how much current is flowing? V in by R. Did you understand this point? From sir here, V in by R current was flowing. Inside the OpAmp, there will be 0 current. That means this complete current will be flowing through this resistance. Right? So in this resistance, in this direction, from left to right, V in by R current is flowing. So can you let me know what will be this drop? From left to right. From left to right. So that drop will be current V in by R into resistance RF. Now I know that sir, this potential is 0. So what will be potential here? Sir, 0 and take a jump and then look back. 0, take a jump and then look back. What you are getting? 0, looking back, negative sign. That's it. So what is the V naught you are getting? V naught I am getting is minus V in into RF by R. Sir, V in by R current was there, sir. This was flowing through this resistance as well. Now across this resistance, sir, this will be the drop. If this potential is 0, then 0, jump, look back. Negative sign is there. So 0 minus V in by RF. Sorry, 0 minus V in by R into RF. This will be the voltage drop I will be getting. That is equals to V naught only. So what is the value of V naught by V in I am getting? V naught by V in I am getting is minus RF by R. There you go. So can you remember this configuration for me? What is the configuration? Sir, there is simple OpAmp. Okay, there is simple OpAmp. Minus plus. This plus is grounded. Then there is resistance R. Then there is a feedback resistance RF. Negative feedback is there. Where is input applied? Input is applied here. This is your RF. This is your R. What is the value you are getting? V naught by V. That is coming out to be minus RF by R. If you are not able to remember, it is fine. But this is a standard circuit. What it is known as? It is known as inverting amplifier. What this setup is known as? It is known as inverting amplifier. Why inverting amplifier? Because what you can see is that, let us say if input is positive, this is a scenario, no? V naught equals to minus RF by R into V in. RF will be a constant value, R will be a constant value. Positive constant value will be. If input is positive, then output will be negative. That means if input increases, then output will actually decrease. Because there is a negative sign, no? Right? There is a negative sign here. If input increases, output will decrease. If input decreases, output will increase. So that's why it is known as inverting amplifier. Right? It is inverting the input. There is a phase shift of 180 degree. What is the meaning of 180 degree phase shift? 180 degree phase shift means there is a negative sign. Right? So that's why it is known as inverting amplifier. Standard circuit it is. If you don't remember the result, any way you can derive it in the examination. very easily by the current as well, by the nodal as well. In any way you can derive it. Let's see another amplifier which is known as non-inverting amplifier. Why it is known as non-inverting amplifier? We will see that. Can you find out V naught for me? Same way, ditto same way. Sir, if this potential is V in, so this potential will also be V in. Can I apply nodal at V in? Yes, sir. Outward current, and outward current. So what will be this outward current? Sir, V in by R. What will be this outward current? Sir, this potential is V in. This potential is V naught. So this outward current would be V in minus V naught divided by RF. What is this current? This current is 0, equals to 0. So when I solve it, what I am getting? This is V in into 1 plus R, 1 plus RF, and this goes here, V naught by RF. Right? So V naught you are getting as 1 plus RF by R. This RF goes here, this RF goes here. So RF divided by RF, that would become 1. RF divided by R, that would become RF by R into V. So this is the V naught value that you are getting. So V naught is 1 plus RF by R into V. This is the V naught value that we are getting. Other way is also there. What is the other way? By the current you can solve. How we will solve? By current. So this was the nodal we have applied. Now what I will do is that I will add up a page, or shall I show it here only? Let's add up a page. Let's add up a page here, and yeah, so let's solve it by current. How will I show it by current? So if this potential is V in, this potential is also V in. Now if this potential is V in, here there is a ground, that means what will be this current? From V in to ground, that current would be V in by R. Now here there is V in by R current, here there is 0 ampere current, here there is 0 ampere current. That means this V in by R current would be coming from here only. Say yes or no? So in this particular resistance, how much current is flowing? V in by R. The current is flowing from right to left. Right to left. So how will be the drop? Drop will also be from right to left only. So drop will be in this direction. What will be that drop? Sir, current which is V in by R into resistance which is RF. Now can you write down V node potential? Yes, sir. This node is V in. From V in to I will take a jump here. Look back. What is the sign? Positive sign. So V in plus V in into RF divided by R. So what is the V naught we are getting? V in plus V in into RF by R. So V naught is coming out to be, V in you can take common, 1 plus RF by R into V in. So V naught by V in is nothing but 1 plus RF by R. Now RF will be a constant value, R will be a constant value. So what do you see here? Is there any negative sign? No. That's why it is known as non-inverting amplifier. So this is the gain of non-inverting amplifier, which is 1 plus RF by R. So what is that two setup we have studied? Two setup we have studied. Again I will add a page, and two kind of setup we have studied here. This was the first one. What was the first one? Let me draw the diagram. Just a second. Like sitting on a writing pad and teaching is actually a difficult task. Better we can teach it standing, but I don't have digital board. Okay, like sitting and then teaching, that's actually a very difficult task. Actually, you have to just be concise in a very small space. So two standard setup we have got, right? This is one setup, then another setup would also be there. Plus minus. This was your RF. RF I am calling because of feedback. R feedback. R. This node was grounded. This was our V. So I will simply copy it and then paste it here. Now here there was only one change. What was that change? That sir, this particular node became ground and this particular node became V. So this node is V in, this node is ground. Now this node is V naught, this node is also V naught. Understandable? right? So here what the gain came out to be, so this node was 0, this node was 0. So here V node by V in came out to be minus RF by R. And sir, here this was V in, this V in went here, this current was flowing, then because of the drop, V node by V in came out to be 1 plus RF by R. So what this is known as? Inverting amplifier. Okay. And what this is known as? Non-inverting amplifier. Another thing you can notice here, what you can notice? The input that is applied, that is connected to a resistance, which is connected to a, oh, sorry guys, big blunder. Here I need to make a negative feedback, no? Yeah. So input is connected to a resistor, which is connected to a negative terminal, which is connected to non-inverting terminal. Not non-inverting, inverting terminal. Sorry guys, I always get confused between inverting and non-inverting. This is non-inverting, this is inverting. So input is connected to a resistor, and this resistor is connected to a inverting terminal, inverting amplifier. And here input is connected to non-inverting terminal, non-inverting amplifier. Input is connected to a resistor, resistor is connected to a inverting terminal, inverting amplifier. Input is connected to non-inverting terminal, non-inverting amplifier. The actual reasoning is that here you are getting negative sign, here you are not getting the negative sign. That's why it is known as inverting, and this is known as non-inverting. Standard circuit is there, standard. Okay. Let's solve this question which has come in GATE examination. You need to write down V naught in terms of V1 and V2. So how will you write it down? Sir, I know one thing. Negative feedback is there. If this potential is V2, this potential will also be V2. What I can do, I can apply nodal at V2. That's it. Can I apply nodal? Yes, sir. This current I will see. This current also I will see. This current I already know, that is 0. So V2 minus V1 by R plus V2 minus V naught by RF would be equals to plus 0. This is which is another current, that would be equals to 0. So what you are getting? V2 into 1 plus R plus RF, right? Because V2 by R, V2 by RF minus V1 by R. That is coming out to be V naught by RF. Did you understand this point? Minus V1 by R, V2 by R, V2 by RF. So V2 I have taken common, and then V naught by RF. Now this RF goes here. So what will happen? V naught will come out to be, this RF goes here. So you will multiply by RF. What you will get? V2 into RF by RF. That would become 1 plus RF by R, RF by R minus V1 into this RF also goes here, RF by R. Simple calculation, nothing else. Okay, very simple calculation. V naught is V2 into 1 plus RF by R minus V1 into RF by R. That's it. Very simple calculation. Right? Just this RF goes here. So if RF goes here, so what will happen is that this RF will be multiplied. RF by RF will become 1. RF by R it will become, or this will also become RF by R. So this is the answer we are getting. This is your V naught. There is another way. This is the final answer. This will be mentioned in the options as well. This is your correct answer. But there is another way of solving this particular problem. What is that way? You can apply superposition theorem. No? The same setup I am taking, and now I will apply superposition theorem. So superposition theorem we will apply. What is the meaning of superposition theorem? That at a time only one voltage source you will consider. Okay, at a time only one voltage source you will consider. So as of now V2 is shorted. If V2 is shorted, I am calling my output to be V01. So what will be your V01? Can you let me know? What will be the V01? Sir, V01 will simply be, sir, this is a standard setup. V1 is connected to resistor which is connected to inverting terminal. Sir, what was the answer? Minus RF by R into V1. This is your V01. Then when we apply superposition theorem, what we do next? Next we will consider only V2. Next what we are going to do? We are going to consider only V2. So when I am going to consider only V2, what will happen then? Sir, only consider V2. This is gone. Sir, again standard setup, V2 is connected to positive terminal. What kind of amplifier it is? Let's just say this output is V02. So what kind of amplifier it is? It is your non-inverting amplifier. This was inverting amplifier, this is non-inverting amplifier. So V02 would be 1 plus RF by R. 1 plus RF by R into V2. What will be your final output? You have applied superposition theorem, that means V01 plus V02. That is simply coming out to be minus Rf by R into V1 plus 1 plus Rf by R into V2. There you go. Okay, so if you have enough practice, although you will not have enough practice because you are studying in the last only, it is already February. If you have enough practice, you will see this circuit and you will be able to write down this particular step. You will see that, sir, only V1 considering this will be gone minus R by R into V1. Only considering V2, this will be gone 1 plus R by R into V1. So this step you will directly writing down in the examination if you have enough practice. No need to worry. We don't have enough practice. We are targeting 2 marks. We will simply solve it by nodal analysis. Simple network analysis, right? This is the practice of OpAmp. But again, you will not build up much practice here because you are studying it in the last, right? So no need to worry about practice and all these kind of things. You can any day get the correct answer. You can any day get 2 marks. If you need to solve it in a quicker manner, then this is how you could have solved it. Okay. Let's go to this question. What we will do here. Is there any point of this resistance? No. Why is that so? What is the current here? 0 ampere, right? So how much will be current here? That will also be 0 ampere. So if this node is V in, this node will also be V in. Here there is 0 ampere current. That means here there will be 0 voltage drop. So what will be this node? This node will also be V in only. If this node is V in, then what will be this drop? This node will also be V in. Because negative feedback is there. So if this is V in, this node will also be V in. Now if this node is V in, then this node is also V in. Now this node is V in, this node is V in. So how much will be current here? How much will be the current here? 0 ampere. Right? V in minus V in divided by R, 0 ampere current. Now this current is 0 ampere, this current is also 0 ampere. What does that mean? How much current will be here? That will also be 0 ampere. So this current will also be 0 ampere. So if this current is 0 ampere, then how much will be drop here? 0 volt will be the drop. Now if this node is V in, then what will be this node? This node will be V in minus 0 volt. That would be V in only. So what is your V node? V node is coming out to be V in. That's it. So what is the voltage gain? V node by V. That is nothing but 1. Did you understand this point? There is no use of these resistance. If this is V in, this will also be V in. This V in goes here. If this is V in, this is V in, 0 ampere current is there. If this is 0 ampere current, this is already 0 ampere current. So here also there will be 0 ampere current. If there is 0 ampere current, that means here there will be 0 voltage drop. If this voltage drop is 0, then simply, or what you can do is that you can apply nodal. Let's apply nodal at V in. So V in, if this node is V in, this node is also V in, this node is also V in, this node is also V in. So V in minus V in divided by R plus V in minus V naught. V in minus V naught divided by R, outward current, plus outward current, that is 0, equals to 0. So V in minus V in, this will also become 0. What you are getting? V in minus V naught divided by R equals to 0. From here what you are getting? V in equals to V naught. There you go. That means V naught by V in equals to 1. Very simple thing. Very simple. It is simply based on network analysis, nothing else. Right? Negative feedback OpAmp, simple network analysis. Again, find out V naught in terms of V1 and V2. Again, it is a gate PYQ only. It is asked in gate examination. Like I am showing V1 like this. In the gate examination, what they can do? They can show V1 like this as well. Simply they will make a battery. I hope it is clear to you. This much thing is clear to you. I hope. What they would do, they will simply make it a battery like this. That this is your V1. Right? Or here, if this is V2, then simply they will make a battery like this. This is V2. Right? Why is that so? Previously I showed V1 here. If this potential is 0, take a jump and look back. What will be this potential? V1 only. If this potential is 0, take a jump and look back. What will be this potential? V2 only. So previously I showed by them node. This is V2, this is V1. They can show by the battery as well. So if this potential is 0, this potential will be V2. This potential is 0, this potential will be V1. If this potential is 0, this potential will also be 0. What you need to do? Apply nodal analysis at 0. What will be this current? 0 ampere. Right? Simply apply the nodal at 0. What that would be? So 0 minus V1 by R plus 0 minus this current I have written 0 minus V1 by R. Now I will write down this current. What that would be? 0 minus V2 by R plus 0 minus V naught. This node is 0, this node is V naught. So 0 minus this current I am writing down. 0 minus V naught by RF plus this is 0 ampere current. That would be equals to 0. That's it. So what you are getting? V naught by Rf is equals to minus sign is outward, minus 1 by R. This V naught by Rf has gone here. So this has become plus V naught by Rf. This minus 1 by R is outward, V1 plus V2. So what you are getting? V naught is minus Rf by R into V1 plus V2. There you go. That's the answer we are getting. Minus Rf by R into V1 plus V2. Is that understandable to you? Simply apply the nodal analysis. If this node is 0, this node is also 0. 0 minus V2 by R plus 0 minus V1 by R plus 0 minus V0 by Rf plus 0 ampere would be equal to 0. We have got the answer. That's it. Simple mathematics. Let's solve this one. Again, gate PYQ only. Now I don't know this potential. Let's just say if I know this potential is X, then what this potential will be? This potential will also be X. Can I apply nodal at X? Yes, sir. What I will be getting? X, this current and this current. Because I already know that this current would be 0. So X minus 0 divided by R plus X minus V0 divided by Rf, that would be equals to 0. So what you will be getting? V0 will come out to be, you can do the calculation, it will come out to be 1 plus Rf by R into X. How did I write down directly? You can do the calculation, this answer will come. How did I write it down directly? Because I know that, sir, if I consider only this much scenario, that forget about this circuitry. If I only consider about X, then X connected to positive terminal. What does that mean? Non-inverting amplifier. What is the gain? 1 plus Rf by R into X. So this is the V0 we are getting. 1 plus Rf by R into X. Now can I write down the X potential in terms of V1, V2 and V3? Surely I can write down. How? I know that, sir, this current is 0. I can apply nodal at X. So outward current, if this node is X, this node is also X. If this node is X, this node is also X. So outward current and outward current. X minus V1 by R1 plus X minus V2 by R2 plus X minus V3 by R3, that is equals to 0. Let's take R1 equals to R2 equals to R3 equals to R. Okay, otherwise the calculation will become very complex. Let's take all of them equal. So if all these are equal, then this will be gone. X will simply come out to be V1 plus V2 plus V3 by 3. Okay, you can do the calculation. R will be gone here. This will become X plus X, 3X, V1, V2, V3. So X will be equals to V1 plus V2 plus V3 by 3. So what you are getting? V0 is coming out to be nothing but 1 plus Rf by R into V1 plus V2 plus V3 divided by 3. There you go. This is your V0. Well and good. Very simple question. Just assume this node, if this node is X, our target is always make the positive node equals to negative node. That's it. If this is X, apply nodal here, get the V0 value. Now you need to get the value of X in terms of V1, V2, V3. Again apply the nodal analysis. Nodal. Everywhere nodal analysis we need to apply. OpAmp has infinity gain, find V out. But this time I have given some I1 current. This current is given. You need to find out V out in terms of I1, I2 or simply in terms of I1 or whatever the parameter that is given. What will be the answer? What do you think? Sir, if this node is 0, what is the condition? What is the condition of virtual short? That, sir, there should be negative feedback. Yes, negative feedback is present. Sir, there should be gain infinity. Yes. Output should not be saturated. As of now, I don't even know the output. But I am saying that, sir, there are two conditions already present. That negative feedback is present. Yes, it is present. Gain is infinity. Yes, it is infinity. So if this potential is 0, this potential will also be 0. That's for sure. Now this potential is 0, this potential is also 0. So 0 minus 0 divided by R. So how much current will be flowing here? 0 ampere current would be flowing here. So what you can see that, sir, from here 0 ampere current is coming. And sir, this current you are saying I1. What does that mean? That means this current would have been I1 as well, no? Because I1, this current is 0, so and then this current would be I1. Is that understandable to you? If this current is 0 ampere and this current is I1, so this current would have been I1 only. Now if this current is I1, then in this resistor the current is flowing from right to left. How much current is flowing? From right to left, I1 current is flowing. What will be the drop here? From right to left, the drop will be I1 R from right to left. Now if this node is 0, this node is also 0, right? Take a jump and look back. So 0, looking back, there is a positive sign, 0 plus I1 R. So what is the value of V naught we are getting? I1 into R. There you go. 2 marks. Get PYQ only. Although I gave the input current, so what? I usually consider that it is 0, ideal op-amp. But in this case, in this op-amp, the gain is infinity, negative feedback is there, I can apply the virtual short. Current is given, my final output is coming in terms of current only. That's it. This is the answer. Very simple thing, right? Again, solve this particular question. Again, it's a good question, okay? Just think about it. What is your answer? Sir, this is 1 volt. Sir, negative feedback is present, this will be 1 volt as well. No. Why is that so? Because this node is fixed, no, this is grounded, it is fixed. They have fixed the node, they have fixed this particular node as 0 volt. And this node is 1 volt. So what is the scenario here now? This is your op-amp, there is no virtual short applicable. This node is 0 volt, this node is 1 volt. Op-amp gain is infinity. The gain is infinity, ideal op-amp is there. It would be written in the problem. So what do you think, what will be your output? Sir, output will simply be A into positive potential, that is 1, minus negative potential, that is 0. So output will be, sir, infinite gain. That means infinite value will be the output. But that can never happen, right? That can never happen. Output can never go to infinity. That means output will be saturated at 12 volt. So what will be the output? Plus 12 volt will be the output. Is that understandable to you? Let's just say in place of this 0 volt, here they would have made a battery of 3 volt. Then let me know what will be the output. That means they have fixed that potential here. If this potential is 1 volt, they have fixed this to be 3 volt. So again, the op-amp will be acting as a comparator now. So this will be the scenario now. So output will be A into 1 minus 3. That means output will be minus 2A. Now what is the value of A? Value of A is infinity. That means output is minus infinity. But it can never go to minus infinity. That means output will be saturated at minus 12 volt. Then what would have been the answer? Minus 12 volt. Is that understandable to you? This is 1 volt. This is fixed to 3 volt. So if negative terminal potential is more, then output is minus 12 volt. If positive terminal potential is more, then output is plus 12 volt. Is that understandable to you? Simply op-amp is working as a comparator. No negative feedback. They have fixed the potential here. Potential is fixed. Understandable? Now solve this question. You should be able to solve it. Is there any potential fixed? No. Whatever the potential that you are getting here, the same potential you will be getting here. That is 0. Now if this node is 0, sorry, if this node is V naught, then this node will also be V naught. Right? If this is V naught, this node will V naught, V naught, V naught, V naught, V naught, V naught, V naught. Can I apply nodal at 0 volt? Yes, sir. Outward current 0 ampere. This current, can I write down? Yes. Can you write down this current as well? Yes, sir. So can I apply nodal at 0 volt? Yes, sir. 0 minus V in by R1 plus 0 minus V naught by R2 plus this outward current is 0. 0 minus V naught by R2 plus 0 minus V in by R1, this current is 0 equals to 0 only. So when you solve it, what you will be getting? V naught is coming out to be minus R2 by R1 into V. That would be the final answer. Again, very simple question. 2 marks, these marks are for free only. Okay, very straightforward question. Let's go to next one. Again, you need to write down V naught in terms of V1 and V2. V naught in terms of V1 and V2. What you will see? So negative feedback is present. If this is V2, then this node is also V2. If this node is V2, that means, sir, there is V2, 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 V2. This node is also V2. What will be 0 ampere current? This, how much will be this current? 0 ampere? No, I told you, inside the negative terminal, the current is 0. This current is 0 ampere. Right? Not this current is 0 ampere. No. Inside the negative terminal, the current would be 0. This current is also 0 ampere. This node is V2, this node is also V2, this node is also V2. Which is 0 ampere current? This is 0 ampere current. This is 0 ampere current. Understandable? Right? So now this is V2, this is V1. So what is the scenario now? Can I apply the nodal? Nodal at V2? Yes, you can apply. But sir, I don't know this current. I don't know this current. Let's just say this current is I. Now you know that, sir, this current is 0. And if this current is I, what does that mean? This current I would be flowing here. If this current is I, this current I would be flowing here. If you apply the nodal, what you will write down? Sir, V2 minus 0 divided by 2R plus V2 minus V1 divided by R plus current I, that would be equals to 0. Now what is current I? So current I is simply, this node is V2, this node is V2. What is this node? This node is V node. So current I is simply nothing but V2 minus V node divided by 3R. That's the I current. V2 minus V node divided by 3R. Or simply you can think that, sir, pull this wire here, pull this particular wire here. If this wire was pulled like somewhat like this, if this wire was pulled somewhat like this, then you would be saying that, sir, easily I can apply the nodal. V2 minus 0 divided by 2R plus V2 minus V1 divided by R plus V2 minus V0 divided by 3R. But what if this is the scenario, then you are getting confused. So no need to get confused. Assume this current is I, this current would also be I, V2 minus V0 divided by 3R only. V2 minus V0 divided by 3R only. Okay. So in place of I, what you will put? V2 minus V0 divided by 3R. That would be put equals to 0. Now simply you need to do the calculation. What I can sense here is that R will be going there, but LCM would be coming as 6. So this will become 3V2 plus 6V2 minus 6V1 plus 2V2 minus 2V0. That would be equals to 0. So what you are getting from here, V0 is coming out to be 11V2 minus 6V1. 11V2 minus 6V1 divided by 2 divided by 2. So V0 is actually coming out to be 5.5 V2 minus 3 V1. This is your V0. Okay, very easily we are able to solve these problems. Very straightforward these are. This question, you need to find out the value of V0 and Vx. Negative feedback is present, sir. Negative feedback is there. What does that mean? If negative feedback is present, then, sir, this potential will be equal to this potential. That means, sir, Vx will be equal to 0. Right? And, sir, if Vx is equal to 0, standard circuit, 1 volt connected to 1 kilo ohm, which is connected to negative terminal. Sir, if Vx is 0, let's just forget about standard circuit. Sir, Vx would be 0. Negative feedback is present, Vx will be 0. So, Vx will be 0 here. Right? Can I apply the nodal? Yes, sir. 0 minus 1 divided by 1 kilo ohm plus 0 minus V0 divided by 31 kilo ohm. This current is 0 ampere only, so no need to write it down, would be equals to 0. From here, sir, if I solve it, V0 is coming out to be minus 31 volt. So option will be mentioned minus 31 volt and 0 volt. You will say that, sir, plus 2 marks. Wrong. Why is that so? Can output go to minus 31 volt? No. So what will happen? Output will be actually saturated. It will be saturated at minus 15 volt. So first you consider that, sir, yes, gain is infinity and negative feedback is also there. So, sir, I will apply the virtual short. But when I applied the virtual short, I got to know that output is actually being saturated. So output is actually minus 15 volt. So till this point, what conclusion I have made is that, first is that, let's add a page. The conclusion that I have made is that, sir, I tried applying the virtual short. When I applied the virtual short, I got to know that my output is actually saturated. That means the virtual short that I applied, this 0 volt that I applied here, that is wrong. You cannot apply this virtual short. You have got to know that, yes, output should be coming minus 31 volt, but actually it is being saturated. Now, if it is saturated, you cannot apply the virtual short. So now you have to solve it. So now you need to find out Vx potential. How will you find out? Again, input current would be 0. Virtual short has nothing to do with the input current. So this current would be 0. Apply the nodal. Vx minus 1 divided by 1 kilo ohm. This current plus Vx, this node is Vx, this node is V0. So Vx minus V0. What is the value of minus V0? What is the value of V0? That is minus 15. So Vx minus V0, that will become plus 15 divided by 31 kilo. That would be equals to 0. So from here it would be 31 Vx minus 31 plus Vx plus 15. That would be equals to 0. Now 32 Vx will be equals to 16. So Vx is coming out to be 0.5 volt. That's the answer. Okay. So what is the correct answer? Correct answer is that, sir, output will be minus 15 and Vx is 0.5 volt. So what I first thought was that, sir, I will apply the virtual short. I go to know that output is actually saturated. So virtual short that I applied, that is wrong, but output is saturated. Output is minus 15 volt. That I can tell. So output is minus 15 volt. Then what I did, again now I need to find out the value of Vx. So how will I find out the value of Vx? This node is 0, I don't care about it. This is Vx. So Vx minus 1 divided by 1 kilo ohm plus Vx minus V naught divided by 31 kilo ohm, which will be plus 15 plus 0 ampere current would be equals to 0. So from here Vx value is 0.5 volt. Is that clear to you or not? Absolutely it is clear to you. Let's go to this question. You need to find out the value of I naught. So what is the first thing that will click to you? That, sir, if I need to find out the value of I naught, one thing I know that, sir, this is 2 volt. Again there is a negative feedback quotient. This will also be 2 volt. So let's do, sir, one thing. Let's apply nodal here. First let me know one thing. Will this current be I naught only? No. What is I naught current? The current that is coming here, let's just say this current is I1 and this current is I2. So what you can write down, I1 plus I naught. I1 plus I naught equals to I2. So I naught is I2 minus I1. So first thing that will click to me that, sir, let's apply nodal here. So how will I apply the nodal? V naught minus 2 outward current. Forget about all these things now. So what will click to me is that, sir, I will apply the nodal here. V naught minus 2 divided by 1 kilo ohm, this current I have written. Then V naught minus 0 divided by 1 kilo ohm, this current I have written. And then this I naught current would be there. But there will be two variables, no? You don't know the value of V naught as well, you don't know the value of I naught as well. So applying the nodal here, that is not a wise idea. So what I do? Let's apply the nodal here at 2 volt. Do I know this current? Yes, sir. Do I know this current? Yes, sir. Do I know this current? Yes, sir. So 2 minus 0 divided by 1 kilo plus 2 minus V naught divided by 1 kilo. That would be equals to 0. So what you are getting? V naught equals to 4 volt. And it is pretty obvious as well. Again, this input applied to the positive terminal. What will be the gain? 1 plus Rf by R. 1 plus Rf, which is 1, divided by R, which is also 1, into V in, which is 2. So this will be your value of V naught. So 1 plus 1, that is 2, 2 into 2, 4 volt. If you don't remember it, no need to worry. Simply get the final answer, that is 4 volt. Now V naught value we have got, that is 4 volt. Now let's apply the nodal here. Now it is easy for me. What will be my nodal? 4 outward current. 4 divided by 1 kilo ohm. 4 minus 0 divided by 1 kilo ohm. Plus outward current. What is the outward current? 4 minus 2 divided by 1 kilo ohm. 4 minus 2 divided by 1 kilo ohm. Now I naught is the inward current. So what will be the outward current? That will be minus I naught. Would be equals to 0. So this is 4 divided by 1 kilo ohm, that is 4 milliampere. This is 2 divided by 1 kilo ohm, that is 2 milliampere. That would be equals to I naught. So I naught is coming out to be 6 milliampere. If I was smart enough, I could have solved it very easily. This is 2 volt, this will be 4 volt, right? Now if this is 2 volt, this current will be 2 milliampere, the same current will be flowing here. So this current would be 2 milliampere, this current would be 4 milliampere. So this is 2, this is 4, this current would be 6 milliampere. Although it will require very high practice, you are not having high practice, better apply nodal analysis and get the correct answer. Answer is 6 milliampere. That's it. Okay, let's go to the next one. Now, sir, what is this VIOS? I don't know. What is this V in? I don't know. What is the gain here? Finite gain is there. Virtual short will not be valid now. What will happen? Virtual short will not be valid now. You need to find out the value of V naught. You know that, sir, this is 25 millivolt, this is 5 millivolt. So, sir, this potential will be 30 millivolt for sure. Okay, because from 0 to 25 plus 5, it will be 30 millivolt for sure. Now the gain is A here. Let's just say this potential is V plus and this potential is V minus, or let's put this as V1 and this as V2. So what will be your V naught? V naught will be nothing but gain A, which is 100, multiply with V1 positive potential minus the negative potential. This will be your answer, right? Say yes or no. Virtual short is not valid. Negative feedback is there, but gain is finite. No, virtual short is not valid. Do I know the value of V1? Yes, sir. What is the value of V1? V1 value is 30 millivolt. Minus, do I know the value of V2? No. So who is the problem now? V2. So let's go to V2 now. Let's talk to V2. So let's remove this V1 here. This was your V2, right? So this is also V2. If this node is V2, this node is also V2. Now in the problem, it will be mentioned that it is an ideal op-amp. That means this current will be 0 ampere. Basically, this current is 0 ampere, so this current will also be 0 ampere. Now at V2, can I apply the nodal again? Yes, sir. This current do I know? Yes, sir. This current do I know? Yes, sir. So what I will do? V2 minus 0 divided by 1 kilo plus V2 minus V0 divided by 15 kilo. That is equals to 0. So what you are getting? 16 V2. This 15 will go here and 16 V2 equals to V0. Right? That means V2 equals to V0 by 16. This is the equation that I am getting. Is that understandable to you? Right? So V2 I can put as V0 by 16 here. So this is your V0, 130 milli minus V0 by 16. So this is 30 millivolt. 30 millivolt multiplied with 100. So this will become 3000 millivolt. So actually it will become 3 only. Minus 100 V0 by 16. That is equals to V0. So now 100 by 16 you do and then simply multiply, you will get the answer. So now it is simply mathematics. Did you understand what I did here? 100 into 30 milli. So that will become 3000 milli. Milli means 10 to the power minus 3. So what does that mean? It will become 3. So 100 V0 by 16 it became. So what is the value of 100 by 16? 100 by 16 plus 1. Then take the reciprocal into 3. So 0.413. V0 is coming out to be 0.413 volt. That is the answer we are getting. Okay, very simple thing. 25.5, this became 30 millivolt. 30 millivolt cannot be copied here. That means I have to wait here. V2 I have to wait. What will be the V0? Virtual short is not valid. This potential is 30 millivolt. This potential is V2. So it will be 30 millivolt minus V2. Now I need to get the value of V2. What will be the value of V2 in terms of V0? You can say that, sir, both current would be same only. No, if this current is 0, if this current is I, this current will also be I. So simply you could have put that, sir, V2 will be 1 by 16. If you don't know that much of network analysis, no need to worry. Simply apply the nodal. V0 by 16 you will get. Simply put V0 by 16 here. Do the calculation. Job done. 0.413 volt. This is also a gate PYQ. Let's solve this one. 2013 question. You should be able to solve this one. Okay. Have some patience. You will be able to solve. You need to find out the value of V0 in volts. Negative feedback, negative feedback. Is there any use of this 1 kilo ohm resistance? No. Why is that so? This current is 0 ampere, so this current will also be 0 ampere. So if this is 1 volt, this will also be 1 volt. Now can I copy this 1 volt here? Yes, sir, this 1 volt could be copied here. Now, do I know this potential? No. Let's just say if I know this potential, that is X. If this potential is X, then sir, whatever the positive potential you are getting, the same negative potential also you will get. So this potential will also be X. Now if this is X, then this will also be X. Is that clear to you? If this potential is X, this will also be X and this will be also X. This will also be X, this will also be X. Now one thing you know that, sir, here there is 0 ampere current. So this current will also be 0 ampere. Right? So can I apply the nodal at X? Yes, sir. You can apply the nodal at X. What kind of nodal you will get? Sir, X outward current you are putting up. So what you are doing? You are putting up the outward current. So X divided by 1 kilo. X minus 0 divided by 1 kilo. Plus X minus V0 divided by 1 kilo. That is equals to 0. So V0 you are getting as 2x. X minus 0 divided by 1 kilo ohm plus X minus V0 divided by 1 kilo ohm. So this 1 goes here. V0 is coming out to be 2x. Now I need to find out the value of X. Can I get the value of X? Where I can apply the nodal analysis? Can I apply the nodal analysis at X? Someone would say that, sir, let's apply nodal at X. Do I know this current? Yes, sir, 0 ampere. Do I know this current? Yes, sir, X minus 1 divided by 1 kilo ohm. Do I know this current? No. I said that input current of the OpAmp is 0. This current is 0. This current is also 0. I did not say any comment about this particular current. So I don't know about this particular current. No. So I cannot apply nodal at X. I will apply the nodal at 1. Do I know this current? Yes, sir. What that would be? 1 minus of minus 2 divided by 1 minus of minus 2 divided by 1 kilo. Plus 1 this outward current 1 minus x divided by 1 kilo plus this current 0 current, that would be equals to 0. So 3 plus 1 minus x, this 1 kilo will go, this is becoming 3 plus 1 minus x, that would be equals to 0. So x is coming out to be 4. If x is coming out to be 4, so V naught is coming out to be 8 volt. That's it. So that's the answer. So bigger circuitry doesn't mean it will be a tough question. Very easy question. Although these are standard circuit only. From here I could have simply said that the gain will be 1 plus RF by R. That would be 2. So V naught would come out to be 2x. Then I need to find out the value of x. This is 1, this is 1. So how much current would be driving here? This is 1, this is minus 2. So here current will be 3 milliampere. Did you understand this point? 1 minus 2. So this will be 3. 3 divided by 1, 3 milliampere current. The same current will be flowing here as well. Where? Here. Why is that so? Why 3 milliampere current will be flowing here? Because this current is 0, no? So 3 milliampere current will be flowing here as well. That means what will be this drop? 3 milliampere into 1 kilo ohm, that will be 3 volt. Now this potential is 1 volt. Jump and see the sign, positive sign. So 1 plus 3, this potential will be 4 volt only. And this potential is 4 volt, so this will be simply double 8 volt. That's it. 1 here, 3 milliampere current, 3 volt drop here, 1 plus 3, 4 volt. This is 4 volt, this became 8 volt. That's it. Although it will require higher practice, that's why we are solving with nodal analysis. Nodal analysis just requires your patience, not the higher practice. So just solve it by the patience, you will be able to solve it. Solve this particular question now. You need to find out, the condition is that V out is equals to 0. This node is 0 volt. What will be the relation between V in and V ref? If this is 0, forget about V out. One thing I know that again negative feedback is there. So if this node is 0, this node is also 0. Now this node is 0, this node is also 0. So how much is the current here? 0 ampere current. How much is the current here? That is also 0 ampere current. So how much will be the current here? That will also be 0 ampere current. 0 ampere, this will also be a 0 ampere current. Now if this node is 0, this node is 0, this node is also 0 volt. Now can I apply nodal at 0? Yes sir. This downward current do I know? Yes sir. This downward current, this current do I know? Yes sir. This current do I know? Yes sir. This current is 0 ampere. So can I apply the nodal? Yes sir. 0 minus, if this node is 0, what will be this node? Just see the negative sign here. This node will be minus V ref. Do you understand this point? If this node is 0, take a jump and look back. This node is minus V ref. If this node is 0, jump and look back. What will be this node? This node will be V in. So 0 minus V in by R plus 0 minus of minus V ref. That means 0 plus V ref divided by R. And then outward current, that is equals to 0 only, and that would be equals to 0. Is that understandable to you? This was 0 already given, this was already 0, so this node also becomes 0. 0 minus 0, this will be already 0. This current would be 0, this current is also 0, this current is also 0. 0 minus of minus V ref divided by R plus 0 minus V in divided by R. Outward current I have written. This outward current is 0 ampere only, so this equation I have wrote. Is that understandable to you? So what you are getting? V in equals to V ref. That's it. There you go. Understandable? So V in equals to V ref. That's it. Very simple thing. Well and good. Okay, let's go to next one. Yeah, that's a good question, although it became NAT. Okay, in the final examination it became NAT. Why is that so? Because they forgot to put the negative sign here. Actually answer would be coming negative. Minus RF by R, RF by R in value would be coming negative. Can you solve it on your own? Can I leave it up to you? Like what is given? V out value is 1 volt when V in is 0.1 volt. When V out, and V out is 6 volt when V in is 1 volt. So what will be the ratio of RF by R in? This is what they are saying. So first target is that I write down the equation of V naught in terms of V ref and V in. Can you write it down on your own? Do you know this potential? No. But can you find it out in terms of V ref only? Yes. What will be this current? 0. If this current is I, then this current is also I. What does that mean? They are in series. If they are in series, can I write down this potential? This potential would come out to be V ref into, simply the potential division I am doing, V ref into R2 upon R1 plus R2. There you go. Right? Now, can you see this OpAmp? If you see this OpAmp very carefully, then this particular potential I have find out, that is Vref into, how did I find it out? This current is 0. So you can simply apply nodal here. Let's put this node as x. X minus Vref by R1 plus x minus 0 by R2 equals to 0 ampere. X value will come out to be Vref into R2 upon R1 plus R2. How did I directly write it down? I know that, sir, this current would be same. They are in series. So simply I can put Vref into R2 upon R1 plus R2. So X node is Vref into R2 upon R1 plus R2. So this potential I have find out. This is the scenario, right? This is positive, this is negative. Here, this is your Rin. This is your Rin. And this potential is Vin. Now here there is RF. And this is your V naught. This is your RF. Now whatever the load is there, I don't care. There is some 100 ohm load. There is no use of this load. Now can you see one thing? If I apply here superposition, if Vin is gone, Vin is shorted, then what will happen? This will become non-inverting amplifier. What will be V naught? V naught will simply be 1 plus RF by Rin, 1 plus RF by Rin into the potential of positive terminal, that is Vref into R2 upon R1 plus R2 plus. Now if I ignore this Vref, if this is shorted, there are two sources, no? One source is this, other source is Vin. So when I ignored Vin, my answer would come out to be 1 plus RF by Rin, because it is non-inverting amplifier. 1 plus RF by Rin multiply with this voltage, that will be your V naught, right? What about if I only consider Vin? Then this will be gone. So what it will become? Vin connected to Rin connected to inverting terminal, inverting amplifier. So what will be the answer? Answer will be minus RF by Rin into Vin. So that's the scenario you are getting. You can directly write down the output. Output is coming out to be minus RF by Rin into Vin plus 1 plus RF by Rin into Vref into R2 upon R1 plus R2. This is the V naught value that you are getting. Now what is the scenario that is given? That V naught equals to 1 volt for Vin equals to 0.1 volt. V naught equals to 1 volt for Vin equals to 0.1 volt. Now let's call this particular thing as alpha. This is alpha only. Okay, we are not caring about this. Now other thing that is given as V naught equals to 6 volt for Vin equals to 1 volt. V naught equals to 6 volt for Vin equals to 1 volt. Let's call this as alpha only. My target is to find out RF by Rin. Can I find it out? Yes, sir. Simply subtract both of the equation. This is 1, 2. Subtract both of the equation. What you will be getting? RF by Rin into 0.9, but negative sign. 6 minus 1 will be 5. So RF by Rin is coming out to be 5 by 0.9. 5 by 0.9. So answer is minus 5.555. That's it. Although they forgot to put the negative sign here, this would have been the answer. Okay. It would be very disheartening for a student who is actually studying in a good manner. He would solve this particular question, he would get this answer, then he would see that yes, there is some calculation error. He will again keep on checking it, and his examination may be messed up. So this kind of blunder should not happen actually. But continuously this is happening, continuously. From 2021, 2022, 23, 24, 25, 26, always you will see that some questions are marks to all. Okay. So this should not happen. MTA. Did I say NAT first? So neither it is NTA, neither it is NAT, it is MTA, marks to all. They forgot to put the negative sign here, right? So this will be the answer. That's it. These many questions are more than enough. Okay. We have solved more than enough questions on negative feedback. Okay. Let's see new concept, that is concept of filter. But after a break, I will take a break, drink some water, and then we will study about the concept of filters. What is the meaning of filter? What is the meaning of frequency? Everything we will see. So, but after a break. Yeah, so now we need to study about filters. But before studying about filters, do you know the concept of frequency? Like this is a signal sine 2t. So this is having a frequency component of 2 radian per second. If I talk about sine 2t plus 5t, so this is having a frequency component of 2 radian per second and 5 radian per second. Two frequency components are present here. In this signal xt, let's call it x1t and let's call it x2t. In x1t, there is only one frequency component present, 2 radian, and in x2t, there are 2 radian and 5 radian. These two frequency components are present. Okay, so nothing like, basically this is the meaning of frequency. Like sine 2t is having a frequency component of 2 radian per second. If you find out its Fourier transform, then in the Fourier transform you would see that there is an impulse that is coming at 2 radian per second. And when you find out its Fourier transform, then you would see that there is an impulse coming at 2 radian and 5 radian per second. That's it. Okay. Now when I say low frequency, so from now onwards, whenever I say low frequency, you will consider the frequency is 0. And whenever I say high frequency, you will consider it is infinity. Low frequency means omega equals to 0. High frequency means omega equals to infinity. Is that understandable to you? Will you be able to consider this? Surely, sir. Low frequency means omega equals to 0. High frequency means omega equals to infinity. Is that absolutely clear to you? Yes, sir. Let's understand the behavior of capacitor. So, a capacitor, how much impedance a capacitor provides? Do you remember that? In your class 11, 12, you might have studied, or somewhere you would have studied. How much impedance a capacitor would provide? Sir, impedance provided by the capacitor is 1 by j omega c. Say yes or no. And in the Laplace domain, how do you replace the capacitor? In Laplace domain, sir, I replace the capacitor by 1 by cs. Basically, in place of s, I am just putting j omega. That's it. Or in place of j omega, I am putting s. So this is not important for me. The important part is that the impedance provided by the capacitor is 1 by j omega c. And what is the impedance provided by the inductor? That is j omega l. So at low frequency, at omega equals to 0, what will be the impedance that will be provided by the capacitor? At omega equals to 0, sir, 1 by 0, that would be infinity. So at omega equals to 0, the capacitor will provide infinite impedance. What is the meaning of infinite impedance? Infinite impedance means open circuited. Say yes or no. Now at high frequency, that means at omega goes to infinity, what will be the impedance that is provided by the capacitor? Sir, 1 by infinity, that would be 0. That means at higher frequency, capacitor will be shorted. Is that clear to you or not? What about the inductor? Inductor provides the impedance of, inductor will provide the impedance of j omega l. If you need to show it in the circuitry, this would be ls. Simply s is replaced with j omega. Okay, this is the Laplace domain representation. If you don't know it, no need to care about it. Just remember one thing, that the impedance provided by the capacitor is 1 by j omega c. Impedance provided by the inductor is j omega l. At zero frequency, it will provide infinite impedance. At infinite frequency, it will provide zero impedance. Now, what about inductor now? At zero frequency, put 0 here. What will be the impedance provided by the inductor? So that would also be 0. What is the meaning of zero impedance? Zero impedance means short circuit. Right? At omega goes to infinity, how much impedance this inductor will provide? The inductor will provide infinite impedance. At omega goes to infinity, inductor will provide infinite impedance. What is the meaning of infinite impedance? Open circuit. That's it. Okay. Now let's understand the meaning of filters. So first one would be written as low pass filter. What do you think? What is the meaning of low pass filter? That means low pass filter, low. So it will provide the, it will pass the low frequency. That means low frequency will be passed, but higher frequencies will not be passed. Passed means like basically there is a signal xt. There is a signal xt. Okay. And then there is a low pass filter. So what will be your output yt? So in this xt, whatever the low frequency components are present, they will be passed. Whatever the high frequency components are present, that will not be passed. Let's just say this low pass filter will pass the frequency component till 3 radian per second. So in xt, if 1 radian is present, 2 radian is present, 7 radian is present, and 9 radian is present. So in the yt, what will happen? Only till 3 radian will be passed. That means this will be passed, this will be passed, but they will not be passed. That means it will be passing the low frequency component, but higher frequency component it will not be passing. What is the meaning of high pass filter? What is the meaning of high pass filter? High pass filter means it will be passing the, it will not be passing the lower frequency component, but it will be passing the higher frequency components. What does that mean? Let us say this is a high pass filter. Input is having again 3 radian, 2 radian, 1 radian, 7 radian, 9 radian. This is your XT. This high pass filter is saying that I will pass all the frequency components which are having cutoff frequency, which are having frequencies greater than 5 radian, which are having frequencies greater than 5 radian per second. 5 radian per second. That means which all component it will pass? It will pass 7 radian and 9 radian. Okay. As of now, like in this particular lecture, I am not giving you the complete concept of filter. When we study, I teach right from the scratch what is the meaning of filter. And when we move to signal system, we design those filters. Along with that, we see the frequency domain representation of those filters as well. But as of now, we need to study on the surface level, right? What do you think? What is the meaning of band pass filter? Band pass filter. So it will pass a particular band of frequency. Like it will neither pass omega goes to 0. It will nor pass omega goes to infinity. But some mid frequencies will be passed. Some mid frequencies will be passed. So omega goes to 0 will also not be passed. Omega goes to infinity will also not be passed, but some mid frequency will be passed. What is the meaning of band reject filter? What do you think? Band reject or band stop, or it is known as notch filter as well. That means it will neither pass, sorry, it will pass omega goes to 0 as well. It will pass omega goes to infinity as well. But it is band reject filter. That means somewhere mid frequencies it will not be passing. Some mid frequencies it will not be passing. 0 it will pass, infinity it will pass, but mid frequency it will not pass. Band stop filter, band reject filter. What is the meaning of all pass filter? It will pass all the frequencies. All the omegas it will pass. All frequencies it will pass. All pass filter. It will pass all the frequencies. So these are the types of filter. Low pass filter, low frequency will be passed. High pass filter, high frequency will be passed. Band pass filter, low and high both will be passed, but band pass filter. That means neither low will be passed nor high will be passed. Somewhere in between, some middle frequency will be passed. Band reject filter. What is the meaning of band reject? Some band, some particular frequency it will not pass. Lower also it will pass, higher also it will pass. All pass filter means everything it will pass. Let's see what kind of questions are asked. This kind of question would be asked, that find out that type of filter. How will you find out the type of filter? So first what you will do, you will put omega equals to 0. Now you know that, sir, at omega equals to 0, the capacitor will provide infinite impedance. At omega equals to 0, capacitor will provide infinite impedance. So how will my circuit look like? This is how my circuit will look like. The capacitor has provided infinite impedance. This is your resistance R and this is my V. Right? How much current is flowing here? Since it is providing infinite impedance, so there is no current flow. What does that mean? V naught is coming out to be V in. That means output is present, no? Like V in is, let's just say V in is 2 volt. That means, yes, sir, some output is coming, no? Some output is actually coming, right? But if omega goes to infinity is there, at a high frequency, what will happen? At high frequency, the capacitor will provide 0 impedance. At high frequency, capacitor will provide 0 impedance. So this will be shorted. Capacitor will provide 0 impedance, so this will be shorted. So this is V naught and this is V. This is resistance R. So what is the value of V naught here? This is shorted, no? So V naught is 0 volt. What does that mean? At higher frequencies, your output is 0. But at lower frequency, you are getting some certain output. That means some non-zero output you are getting. So at lower frequency, some output you are getting. At higher frequency, no output you are getting. What does that mean? What kind of filter it is? It is a low pass filter. There you go. Is that understandable to you? What about this one? Check at omega goes to 0 and check at omega goes to infinity as well. At omega goes to 0, capacitor will provide infinite impedance. At omega goes to 0, capacitor will provide infinite impedance. So this node is V, then shorted, and this is the resistance R, and this is your V naught. How much current would flow through this resistor? 0 ampere. Why is that so? Because it is open circuited, no? This is open circuited, no current will be flowing. So 0 ampere current is flowing through this resistor. So how much will be the drop here? 0 volt will be the drop. 0 ampere current is flowing, 0 volt will be the drop. So what will be the value of V naught? That will be 0 volt. Now what about omega goes to infinity? At omega goes to infinity, capacitor will provide 0 impedance. So this capacitor will be shorted, and this is your resistance R, and this is your V naught. So V naught is coming out to be simply equals to V. Let's just say V is some 2 volt. So V naught is coming out to be 2 volt. So at higher frequency, you are getting some non-zero output, but at lower frequency, you are getting zero output. What does that mean? What kind of filter it is? It is your high pass filter. It is passing the high frequency component, high pass filter. Is that clear to you? What about this one? Check at omega goes to 0 and omega goes to infinity. Check at omega goes to 0 and omega goes to infinity. So at omega goes to 0, what will be the scenario? This will provide 0 impedance. At omega goes to 0, the inductor will provide 0 impedance. At omega goes to 0, it will provide 0 impedance. So this will provide 0 impedance. This is R, this is V in, and this is your V naught. So what is the value of V naught you are getting? 0 volt. Right? Because it is shorted, this is grounded, so it is 0 volt. But at omega goes to infinity, what will happen? Inductor will provide infinite impedance. Right? Inductor will provide infinite impedance. So inductor is providing infinite impedance. So what will be the current here? 0 ampere current would be there. Why is that so? Because it is open circuited. 0 ampere current is there, that means there will be 0 volt drop here. 0 volt drop, that means V naught is equals to V. That means at higher frequency you are getting some output, but at lower frequency you are not getting any output. What does that mean? What kind of filter it is? It is a high pass filter. What about this one? You can check it, it will come out to be low pass filter. In the same manner you will check. At low frequency what will happen? It will be shorted. That means V naught will be at omega goes to 0, what will be the scenario? Inductor will be shorted. So V naught will come out to be equals to V in. At omega goes to infinity, what will be the scenario? Inductor will be open circuited. That means here there will be 0 ampere current. That means there will be 0 voltage drop here. 0 voltage drop means V naught will be equals to 0. That means it is passing the lower frequency. It is a low pass filter. Solve this question. Use your brain. Solve this question. You will be able to solve. Again, the same method is there. Omega goes to 0. Omega goes to infinity. So let's see. At omega goes to 0, what will happen? At omega equals to 0, what will happen? So let's check for omega equals to 0. At low frequency, what will happen? So when omega equals to 0, at omega equals to 0, what will this capacitor do? This capacitor will provide infinite impedance. Omega equals to 0, capacitor will provide infinite impedance. 1 by j omega c, it will provide infinite impedance. That means it will be open circuited. So this will be gone. Open circuited means it will be gone basically. It will not drive any current. This is the scenario. That means it is gone, right? Now you know that, sir, this current is 0. Can you say, sir, this current is 0? No. This current is 0. Now, sir, this is also a 0 current because it is open circuited. That means this current will also be 0. So there is no meaning of this resistor R. So, sir, if this is V in, this will also be V in. Now you know that, sir, V in is connected to positive potential. Positive terminal. V in is connected to positive terminal. What will be your V naught? Sir, V naught I will be getting as 1 plus R2 by R into V1 into V. So basically the bottom line is that, yes, sir, some output I am getting. At omega goes to 0, this is the scenario that I was getting at low frequency. At omega goes to 0. Now let's check at omega goes to infinity. At omega goes to infinity, what will happen? At omega goes to 0, sir, this provided infinite impedance, open circuited. 0 ampere current, this became V in. If this is V in, then I can find out the V naught. Some output, some V naught I am getting. Some V naught I am getting. Let's check at omega goes to infinity. At omega goes to infinity, what will happen? This capacitor will provide the 0 impedance. Capacitor will provide the 0 impedance. That means it will be shorted. So capacitor will be shorted. Capacitor is shorted. Capacitor will be shorted. Now, what is this node? What is the potential of this node? That is 0. So what will be the potential of this node? That will also be 0. So this time the positive terminal potential is 0 volt. So if this is 0 volt, because of the negative feedback, this will also be 0 volt. Now if this is 0 volt, this is also 0 volt. Already it is grounded. So how much current it is driving? 0 ampere current it is driving. Now this is 0 ampere current. How much is this current? That is also 0 ampere. So this current is 0 ampere. This current is 0 ampere. That means here also the current has to be 0 ampere. If this current is 0 ampere, that means what will be the drop across the resistance? 0 ampere current is flowing. So drop will be 0 volt. Now this node is 0 volt. Take a jump and come here. 0 volt, take a jump, negative sign, minus 0. What is the answer you are getting? 0 volt. So what is the value of V naught you are getting? 0 volt. That's it. Sir, what will happen to this V in? I don't care about it. No. what will happen to this V in? I don't care about it. This is 0, this node is 0, this node is 0, this node is also 0, 0 ampere, 0 ampere current, 0 ampere current here, 0 node, V node is 0 volt. That means at omega equals to 0, you are getting some output was non-zero. And at omega goes to infinity, output is 0. What does that mean? Lower frequency is being passed. It is a low pass filter. Okay. More questions we will see, but I need to change the slide because 50 pages are completed actually. So just as 50 pages are completed, I will have to change the slide. So I will have to pause the video and then next slide I will open up. There we will see more examples. In that manner only we need to solve. Omega goes to 0, omega goes to infinity. That's it. Okay. Yeah, welcome back guys. So we were studying about filter. So look at this particular circuitry and tell what kind of filter it is. Same thing, omega goes to 0. At omega goes to 0, what will happen? This capacitor will provide infinite impedance. If the capacitor is providing infinite impedance, then how would the circuit look like? So sir, what I will do is that I will simply copy this particular circuitry and I will make capacitor to go to open circuit. This capacitor will be open circuited, right? Capacitor will be open circuited. Now, if it is open circuited, there is no connection with V. That means this is open end. So this is driving 0 ampere current. Say yes or no? It is open circuited. So this is driving 0 ampere current. Now here there is also 0 ampere current. Here also there is 0 ampere current. If this node is 0 volt, then this node is also 0 volt. If this is 0 ampere current, this is 0 ampere current. So here also there is 0 ampere current. 0 ampere current means here also there will be 0 voltage drop. Now if this node is 0 volt, then this node will also be 0 volt only. 0 take a jump. This will also be 0 volt only. Is that understandable to you? Omega goes to 0, capacitor providing infinite impedance, 0 current, 0 current, 0 current, 0 volt. That's it. Let's check at omega goes to infinity. At omega goes to infinity, sir, I will copy the same circuit, but capacitor will provide 0 impedance now. At omega goes to infinity, capacitor will provide 0 impedance. That means it will be shorted. If it is shorted, have you seen the circuit? V in connected to a resistance connected to a inverting terminal. What will be the output? Minus RF by R. So it will be minus R2 by R1 into V. That means some output you are getting. Some output you are getting. Omega goes to 0, output was 0. At omega goes to infinity, output is non-zero. What does that mean? What kind of filter it is? High pass filter it is. This is a high pass filter. Okay, let's go to the next one. So again you will analyze in the same manner. Let me know the correct answer. Have some patience. Let me know the correct answer. You should be able to solve it. What you will do? Omega equals to 0, omega equals to infinity. Omega equals to 0. Let's do omega equals to 0. What you will be getting? For omega equals to 0. What this inductor will do? At omega equals to 0, inductor will provide 0 impedance, right? Because inductor gives j omega L impedance. So at omega equals to 0, this will provide 0 impedance. That means this will be shorted. And at omega goes to 0, this capacitor will provide infinite impedance. That means this will be open circuited. So this branch is gone. Like there is no meaning of this branch. This is simply open circuited. Right? Now have you seen this kind of circuitry? Yes, sir. Like this branch is gone. No, open circuited means it is gone. It is not even there. That means it is gone. Right? So have you seen this circuitry? Yes, sir. What is V naught? Minus R2 by R1 into V. Do you understand this point? So at omega goes to 0, you are getting some output. Some output you are getting. Let's check at omega goes to infinity. So at omega goes to infinity, what will happen? Sir, infinity it is. So at omega goes to infinity, this inductor will provide infinite impedance. This inductor will provide infinite impedance. That means this is open circuited. And this capacitor will provide 0 impedance. This capacitor will provide 0 impedance. Now this is infinite impedance, this current is 0. This current is also 0. So from here as well there is 0 ampere current. Right? And this node is 0, so this node is also 0. Now if this node is 0, then you know that this node will also be 0. If this node is 0, this node is also 0, this node is also 0, then this node will also be 0, then this node will also be 0, and this node will also be 0. So what will be your V node? That will be 0 volt. What did you see here? At omega equals to 0, output was non-zero. But at infinity frequency, what did you see? Output was 0. What kind of filter it is? It is your low pass filter. Very simple, very straightforward, nothing else. What about this one? Sorry, one more example should be there, no? Let's wait for a minute. Yeah, I guess one more example has to be there. So let me frame it. There is one more example. Okay, I forgot it actually. So let's take this example. One more example has to be there, which I forgot. So what I am doing now is that in place of this inductor, I am simply putting a capacitor. Okay. Now let me know what kind of filter it would be. This is C1. Let's call this as C2 and this as C1. What kind of filter it is? This is the question in front of you. What kind of filter it is? Check omega goes to 0, omega goes to infinity. So same analysis. Sir, I will check at omega goes to 0 and omega goes to infinity. So checking at omega goes to 0, what will happen? Sir, copied the circuit. At omega goes to 0, capacitor will provide infinite impedance. Capacitor will provide infinite impedance. What will happen? This will be open circuited. That means this branch is gone. No meaning of this branch. This is also open circuited. That means this branch is also gone. This branch is also gone. So here there will be 0 ampere current. Here also there will be 0 ampere current. This current is also 0. This current is also 0 ampere. 0 ampere current, 0 ampere current. If this node is 0, this node is also 0. So 0 will be traveling here, traveling. What is the current here? 0 ampere. What will be the drop here? 0 volt. So this is 0 volt, 0 volt, 0 volt, 0 volt, 0 volt. Output will be 0 volt. So at 0 frequency, what output you are getting? 0 volt. At infinite frequency, let's see what happens. At omega equals to infinity. At infinite frequency, let's see what happens. At omega goes to infinity. Sorry. Yeah. At omega goes to infinity, what will happen? Capacitor will provide 0 impedance, right? Capacitor will provide 0 impedance. That means it will be shorted. It will be shorted. 0 impedance means it will be shorted. It will be shorted. It will be shorted. Okay. Right. Now, sir, this node is 0. This node is also 0 volt. Now, if this node is 0, then 0 node, 0 voltage, 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 0 voltage. What is V node? 0 volt only. Now, someone would say that, sir, current is not 0. Yes, sir, current is not 0. If this node is 0 volt, then current here is V in by R. V in by R1. No doubt about it that current is not 0. Sir, here there is 0 input current. So, what will be the current here? Sir, that would be V in by R1. Right? Whatever the current that is coming from here, the current is going in this branch. Now, this current has two paths, either to go from this resistance or to go from here. So, where the current would flow? The current would be flowing from this path. So, although in the resistor, although in this short circuit part there is some current flowing, but does that mean there would be some potential? What I am saying is that, sir, in this particular branch, yes, this V in by R current will not flow through this resistor. This is least resistance part. So, it will go from here only. This current will go from here only. But does that mean that it will have some voltage drop? It is not necessary, no? 1 ohm, 1 volt. Let me know what will be the current flowing here. What will be the current? 1 by 1 ampere current is flowing. Here also 1 ampere current is flowing. So between these two nodes, how much current is flowing? 1 ampere. But what is the potential drop here? If this potential is V, this potential is also V. Right? Both of the potentials are same. So for the current to flow, potential difference is not necessary. I have seen a lot of people saying that if there is a potential difference, then only the current would flow. No. The current can flow without the potential difference as well. Like what is the current between these two nodes? 1 ampere. But what is the potential difference? 0. Same potential is there, no? So for the current to flow, potential difference is not necessary. Right? So yes, current is flowing. But still this node is 0 volt. No, so this node is also 0. 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 V node is 0 volt only. Is that understandable to you? 0, 0, 0, 0, 0, 0, 0. Current is flowing, so what? Okay. So what did you understand from here? That at omega goes to 0, output came out to be 0 volt. At omega goes to infinity, output came out to be 0 volt. That means it is neither passing low frequency nor it is passing high frequency. What does that mean? It would be passing some mid frequencies, no? So it will be known as band pass filter. Band pass filter. Okay, neither low nor high. That means some mid frequency it is passing, so it is known as band pass filter. Is that understandable to you? Well and good. Okay. Yeah. So this is the analysis of filter. Now there is another concept that is asked, that find out the cutoff frequency. Find out that 3 dB cutoff frequency. 3 dB cutoff frequency. This kind of question is also asked. So you need to have good knowledge of Laplace domain. What is the meaning of Laplace domain? That I told you that our capacitor will provide us the impedance of 1 by j omega c. So this j omega means S. So in the Laplace domain, this capacitor could be replaced as 1 by Cs. This capacitor will be replaced as 1 by Cs. And how much impedance this provide? Inductor will provide, that will provide j omega. So in Laplace domain, our inductor will be replaced as Ls. And how will the resistance be replaced as? How much impedance the resistance provides? How much impedance the resistance will provide? It will provide R resistance only, right? It will provide R impedance only. That means there is no j omega term. So resistance will be as it is. So in Laplace domain, resistance will be as it is, inductor will be Ls, capacitor will be 1 by Cs. Is that understandable to you or not? Now you need to do the analysis in Laplace domain and you need to find out the transfer function. Then you will be able to tell the 3 dB cutoff frequency. Let's see this question. You need to find out V naught S by V in S. So what do you mean by V naught S by V in S? That means you need to go to the Laplace domain. So this capacitor will be replaced by 1 by Cs. This resistance will be R2 only and this will be R1 only. Now V naught will become V naught S, V in will become V in S. Now you need to find out V naught S by V in S. Let's just say this much impedance is nothing but Z1. This much impedance is Z1. This much impedance is Z1. Now if I give you this Z1S, let's just call it Z1S. If I give you this particular circuitry, that here there is some impedance Z1S, okay, and then there is a OpAmp. Then there is a OpAmp. This thing is grounded. This is V in S, and then here there is a resistance R2, and this is your V naught. So, and this is your V naught S. Can you let me know what will be V naught S by V in S, or can you just let me know what will be V naught S? Sir, standard circuit, V in S connected to a resistance connected to a negative terminal, minus Rf by R, minus R2 by R1. What is this resistance? That is Z1S. Feedback resistance divided by this resistance, that is Z1S, multiply with V in S. So that will be the scenario. What you need to find out? V naught S by V in S. So what is V naught S by V in S is coming out to be? V naught S by V in S is coming out to be minus R2 by Z1S. Now can you let me know what is Z1S? Z1S is the series combination of 1 by Cs and R1. So what is Z1S? Z1S is nothing but a series combination of 1 by Cs plus R. So what is the answer you are getting? Minus R2 upon, this is R1, no? So R1 minus R2 upon Z1S is R1 plus 1 by Cs. So what you are getting? Minus R2 Cs upon R1 Cs plus 1. So what is your V naught S by V in S eventually? Minus R2 Cs upon R1 Cs plus 1. And from here as well you can check the type of filter. How can you check the type of filter? Let's write it down on the next page. Let's write it down on the next page, and from here you can find out that 3 dB cutoff frequency as well. So what you are getting? V naught S by V in S is coming out to be minus R2 Cs upon minus R2 Cs upon R1 Cs plus 1. This is the scenario. Now what is S? S is equals to j omega. So what is the meaning of low frequency? What is the meaning of low frequency? Low frequency means omega equals to 0. If omega is 0, what does that mean? S is also 0. Right? Now if S is 0, then what will be your V naught S by V in S? If S is 0, what will be your V naught S by V in S? 0 put here, put 0 here. 0 divided by 1, what will be that? 0. So what you are getting? V naught S is coming out to be 0. What is the meaning of high frequency? High frequency means omega equals to infinity. If omega is infinity, S will also be infinity. So what will be your V naught S by V in S? Sir, it will be infinity by infinity form. Right? So you can apply the L'Hopital rule, or you can simply say that, sir, if S is infinity, then R1 Cs will be much larger than 1. What I am saying, if S is infinity, then this value will be much larger than 1. So 1 can be ignored. So it can be written as minus R2 CS upon R1 CS. Now CS will get cancelled out. It is coming out to be minus R2 by R1. So from here you can see that V naught S by V in S is coming something. That means V naught S is coming out to be some non-zero value. Whatever the value is there, I don't care, but some non-zero value you are getting. What does that mean? Low frequency is not being passed, high frequency is being passed. So it is a high pass filter. Sir, I could have directly checked it without this analysis as well, which I have already done. This particular circuitry we have already seen, right? Here we have seen. Without this analysis, it was also high pass filter only. The same circuitry it is. So, sir, why did you teach us this particular scenario? Which scenario? This Laplace domain scenario. Because they will ask what is the 3 dB bandwidth. Okay, not bandwidth, 3 dB cutoff frequency they will ask. What is your 3 dB cutoff frequency? So, what will be your 3 dB cutoff frequency? Sir, whatever the denominator is there, no? Put that equals to 0. Sir, why do we do so? That we will study in comprehensive course. Okay, not as of now. Whatever the transfer function you are getting, this is known as transfer function. Okay, this is known as transfer function. So, whatever the transfer function that you are getting, just put the denominator equals to 0. What you are getting? If I put denominator equals to 0, R1 CS plus 1 equals to 0. So, S is coming out to be minus 1 by RC. I don't care about the negative sign. So, what will be my 3 dB cutoff frequency? That will be nothing but 1 by RC. R1C. So, 1 by R1C. So, 3 dB cutoff frequency is 1 by R1C. But make sure that this is coming in. What is S? S is equals to j omega, no? So, ignore the j part, ignore the negative sign, just see the real value 1 by R1C, real positive value. So, 1 by R1C. This will be your 3 dB cutoff frequency. Just get the value of S, remove the negative sign, this will be your 3 dB cutoff frequency. Okay, only the 3 dB cutoff frequency, not the bandwidth. Only in case of low pass filter, 3 dB cutoff frequency and bandwidth are same. But in case of high pass filter, 3 dB cutoff frequency is minus 1 by R1C, but bandwidth is infinity. All these concepts we can understand in comprehensive courses. As of now, we need to study on surface level. 99% of the questions will be solved by this analysis. 1% chances are there that it might be they can ask something else. But 99% problems will be solved by simple analysis. So what will be your 3 dB cutoff frequency? That is 1 by R1C. It will be in radian per second. If they are asking in hertz, then what you will do? You know this relation, omega equals to 2 pi f. So here if you put 2 pi f, so what you will be getting? 2 pi f I will be putting, so 2 pi coming downward. So answer will be 1 by 2 pi R1C hertz. So just find out the transfer function. What you will do? Just find out the transfer function in this manner and then simply find out these values. We will solve the gate PYQs now. So first let me know whether it is a high pass filter or low pass filter. So this analysis we have already done. Omega goes to 0 we have put, omega goes to infinity we have put. You can do the analysis on your own. When I put omega goes to 0, what will happen? This will provide infinite impedance. Output will be 0. When I put omega goes to infinity, this will provide 0 impedance. It will be a simply inverting amplifier. Output will be non-zero. Same circuitry. Ditto same circuitry. R2, R1, C1. R2, R1, C. So, R2, R1, C. Right? So, what will be the answer? It will be a high pass filter. What about the 3 dB cutoff frequency? Sir, I saw that when I did the analysis, it is coming out to be 1 by R1C. The same circuitry it is there, no? Same circuitry. Same circuitry. It came out to be 1 by R1C. Most probably, sir, 3 dB cutoff frequency will come, which is near, like capacitor will surely come. 1 by capacitor will surely come. What will be the resistance? Most probably it will be near to the capacitor one. That's it. Okay, but again, for better understanding or for better confidence, always find out the transfer function. But again, in 99% cases, whatever the capacitor will see near, whatever the capacitor will see nearby, that will be the resistance we need to take place. Okay, so what do you think? What will be the cutoff frequency? So cutoff frequency in omega, that would be 1 by capacitance value 1 microfarad into resistance value 1 kilo. So what you are getting? 1000 radian per second. A lot of people have made the concept as well that just find out the equivalent resistance across the capacitor, but it is always not necessary. Whatever the gate PYQ has been asked, in those PYQs, mostly chances are there that just find out the equivalent resistance, that would come out to 1 kilo ohm only, your job would be done. Right? So just multiply both of them, that will be the 3 dB frequency. But if they want to frame a good question, there they can mess it up. Like there they can frame something good out of it where your method is not working. So that's why I said that always find out the transfer function and then get the correct answer. But this method will also work in most of the problems. Let's go to this particular question. Now, if you have studied control system, then you will be able to read this particular graph. Are you able to read this graph? What did I say? 3 dB cutoff frequency. 3 dB cutoff frequency means whatever the maximum gain is there, from that maximum gain, 3 dB less gain. This is 12, this is 9. So this is 3 dB, no? So what is the 3 dB cutoff frequency here? This is the 3 dB cutoff frequency. 3 dB cutoff frequency is 3 radian? No. This is the value of log tan omega. So what they have said that your 3 dB cutoff frequency, is, let's just say omega. 3 dB cutoff frequency is nothing but omega. Then value of log tan omega is given as 3. Right? What is the meaning of 3 dB cutoff frequency? From the maximum gain, 3 dB lesser. Okay? From this pass band gain, 3 dB lesser. So this is your 3 dB cutoff frequency, which is coming out to be log tan omega equals to 3. Log tan omega equals to this 3. So log tan omega equals to 3. So here your 3 dB cutoff frequency is 1000 radian per second. Again, you can find out the transfer function. All these things you can do, but cutoff frequency will come out to be like in the cutoff frequency. I told you that one capacitor will surely be there. What resistance would be there? The resistance that would be there near to the capacitor, there is only one resistance. Let's call it R1. So this will be your 3 dB cutoff frequency. Okay. So what did you see here? That 3 dB cutoff frequency is 1000 should be equals to 1 by R1, which is 1 kilo ohm, into capacitor C. So from here, value of C is coming out to be 1 microfarad. So this is the value of C we are getting, 1 microfarad. Now we need to find out the value of R. So this option is possible, this option is possible. They are gone. Now what about the value of R? How will you find out the value of R? What is this gain? Can anyone tell? When omega equals to 0, what is the gain you are getting? Like this is the value of gain, log tan 20 AV. They are saying that log tan 20 AV means voltage gain. What is the meaning of voltage gain? Voltage gain means, what is the meaning of AV? AV means voltage gain. That means V naught by V. So what they have said is that, let's put it on the next page. Like this was not a very easy question actually. Here the concept of concept of control system is also used. Although it is easy if you study in comprehensive course, but if you are studying in one short session, in very crash courses, in these kind of crash courses, then it will be tough for you. But in comprehensive courses, this will become very easy. So at 0 frequency, here the frequency will become very low, no? So at low frequency, what is the gain you are getting? So what they have said is that at 0 frequency, the gain that I am getting, but the value is log tan mod of AV. The gain that I am getting is 12. So from here, can you find out the value of mod of AV? So that would be 12 by 20, then take 10 to the power. So 3.98. Almost we can write down it is 4. The gain is 4. Now in this particular circuitry, can you find out the gain at omega equals to 0? We have solved more than enough problem. We are discussing for last 3 hours. At omega equals to 0, you should be able to find out the gain. V naught by V in, what will be the value at omega equals to 0 of V naught by V in? Will you be able to find out? At omega equals to 0, what will happen? Capacitor will be open circuited. So this will be gone. Now if this is gone, here there is 0 ampere current, here also there will be 0 ampere current. There is no meaning of this 1 kilo ohm resistance. So if this node is V in, this node will also become V in. If this node is V in, this node will also become V in. Right? Then this node is also becoming V in. So what will be the gain you will be getting? It will simply become non-inverting amplifier. So the gain that you will be getting is 1 plus RF by R. 1 plus RF by R. That will be 4. So value of R is coming out to be 3 kilo ohm. Okay. So value of R is coming out to be 3 kilo ohm. So this will not be a possible answer. This will be the correct answer. I don't know why gate set up these kind of options. Like in our test series, you would have seen that I don't set up this kind of option. If someone is very smart, what he can do? Sir, three kind of capacitor value I am getting: 1, 2, and 3 microfarad, right? 2 microfarad is only coming once, 3 microfarad is only coming once, but 1 microfarad is coming twice. That means, sir, surely one of the options would be correct. Okay. Next, what he will think? Let's talk about the resistance value. 1 kilo ohm is coming once, 4 kilo ohm is coming once, but 3 kilo ohm is coming twice. That means here 3 kilo ohm should be correct, and here 1 microfarad should be correct. First option correct. No concept, nothing. Plus 1 mark. Every time gate has set up the options like this, but if I am the educator, what I would do? I will repeat both of them only once. Like in all the options, what I will do is that here I will put 4 kilo ohm. So that student try to become smart, that sir 4 kilo ohm is coming twice, I will click on this option. Okay, this is what I would have done. And 1 microfarad as well, I will keep this as 3 microfarad. Or no, not 3, I will keep this as 2 microfarad. Then you would think that, sir, 4 kilo ohm and 2 microfarad would be the answer. Right? So it has happened, but who knows, in future gate examination, what they can do is that they can change their strategy of framing the options. But here the options are not framed smartly. Right? Yeah. So did you find out the value of cutoff frequency? Yes, sir. 1 by R1C. Cutoff frequency you have find out. Capacitor value you will be getting. And resistance value also you can find out by the omega goes to 0. At low frequency, what is the gain you are getting? Based on that, you can find out the value of resistance as well. Well and good. Let's see the last question. This is the last question. This is also a gate PYQs. This is also a gate PYQ. What should be the value of R such that cutoff frequency is 5 kilohertz? 5 kilohertz. Notice this thing, 5 kilohertz. Okay. What does that mean? This is the value of F. What do you think? What will be the cutoff frequency? Sir, I told you cutoff frequency is either you first find out the transfer function, but one trick I have said, whatever the capacitor value is there, that will come. Multiply with near resistance value. What is that? R2. This should be the cutoff frequency. But again, this is in omega. But the value of cutoff frequency omega C I am putting. Cutoff frequency omega C. That is 5 kilohertz. So in omega, it will be 2 pi into 5 kilo, right? So it will become 10 pi kilo radian per second. So it will become 10 pi kilo radian. That means 10 to the power 4 pi. 10 to the power. What is the meaning of 10 nano? 10 nano means 10 to the power minus 8. 10 to the power minus 8 into R2. So what is the value of R2 you are getting? 10 to the power 4 by pi. 3183, and they will be asking in kilohertz, so it will become 3.183 kilo ohm. Okay, you can simply do the calculation, you can find out the value of R2. This 10 to the power 4 come downward, this R2 goes here, so it will become pi by 10 to the power 10 to the power 4 into 1 by pi. That would be the answer. So what is the value of 1 by pi? Multiply with 10 to the power 4, that means 4 zeros. So 3.183 kilo. Well and good. So yeah, that's it. That's it about the negative feedback OpAmp. Next, we need to study about positive feedback. Okay, next what we need to study? OpAmp in negative feedback we have seen. Like first we saw OpAmp as open loop. Like OpAmp as comparator we have seen, right? OpAmp as comparator we have seen. Next, we studied about OpAmp in negative feedback. Negative feedback. Then we saw filters, right? OpAmp filter. Again, like I did not teach very in depth, but still you have good problem solving skills. You will be able to solve the gate PYQs, and upcoming question also you will be able to solve if it is coming on the surface level. If it is coming very in depth, then for that comprehensive courses are required, right? But surface level problems you will be able to solve. And mostly they are asking from the filters, from negative feedback, from comparators, they are asking surface level problem only. Till this date, they never asked anything in depth, right? Next, we need to study OpAmp in negative feedback. Sorry, no, OpAmp in positive feedback. This is also important, but before that, more important part is MOS amplifier. So this video I already made last year. So what I will do is that I will add up this video now. You study MOS amplifier, right? Now you already have a basic idea of negative feedback, so you will be able to understand this particular video as well. So what I would do, first I will add up this particular video which I have already recorded now, then I will add up this video, and then we will go to positive feedback, because this is more important. This is also very, very important, and these guys are also very, very important. So here I will put 2 star, 2 star. Let's put 3 star here. This is also 3 star, so this will be 2 star. Okay, so these guys are again very, very important. Again here there is no prerequisite. Just like this, was there any prerequisite? Did you feel like that, sir, I don't know anything, still I am not able to understand? No, there is no prerequisite at all. Simple basics of network analysis you need to know. Similarly here as well, basics of network analysis you need to know, no prerequisite. And then coming to the positive feedback, again there is prerequisite, but this is the prerequisite which I have already covered. Okay, so here as well there is no prerequisite. So this video is helpful for all those guys who are having zero idea of analog electronics. Still they will be able to understand and look from here. Okay, so all this part will be completed. Then in the end I will ask you something, that what all I can bring, what more things I can bring. Okay, so in the end I will ask that, yeah, this is the planning, can I bring more things or not? So that will be up to you. You will let me know that what more things I can bring. Okay then, yeah. So let's see the next part where we are talking about MOS amplifier, which I recorded last year. Then I will be adding up this video in this particular session. Okay, yeah, thank you. Hi everyone. So in this video we will study about MOS amplifiers, which is a very, very, very important topic for your upcoming GATE EC examination. So who should watch this video? This is the first point. So if you are someone who did not study this particular topic and you are thinking that you will completely drop it, then you should watch this video, because here I am gonna tell you problem solving skill, that how you would be able to solve the problem in the examination. Here I'm not gonna dive deeper into the concept. Here only thing I'm gonna tell is how to solve the problem in the examination. So if you are someone who completely skipped this particular topic, then you should watch this video, because what I feel is that this should come for 3 to 4 marks. So you can watch this video, or if you are someone who has already studied it but you are not feeling so much confident in this particular topic, then you can watch this video. Okay, so yeah, so in this particular video we are not going to solve any challenging problem or any exceptional problem. Here we are going to see the basic problem which can be asked or which have been asked in the examination. Okay, so if you are someone who is already confident with this particular topic, then you can skip this video. So with that we will start learning our MOSFET amplifier. So before going into MOSFET amplifier, first let's understand the basic meaning between large signal and small signal. So again and again, when you see a problem of a MOS amplifier, there will be these two terms, large signal and small signal. So what is the meaning of that? So let's just consider this mic I am having. So in this mic, how many input signals are there? How many input signals are there? So first thing is that this mic is connected through a wire from PC. So when I turn on the PC, what it does, it turns on the mic as well. Like this mic is getting one supply from the PC. So this is the one input it is getting. The other input is my voice. The job of this mic is to amplify my voice. So one thing is that the supply from the PC, the supply from the laptop is turning on this mic. So first you need to turn on this mic. Let's just say I did not even turn this mic and I am saying something. Will it amplify my voice? No. First I need to turn it on. So for turning it on, I need to give it a supply. So that supply is our large signal. And that signal is DC. So from the laptop it is getting some constant 0.8 volt, it could be 5 volt, it could be 2 volt, something it is getting from the laptop. The other input is my voice. Like I am saying something, it is amplifying it. So that is the other input, and that signal is small signal. Why do we call it small signal? So generally this large signal is DC bias, 0.8 volt, 5 volt, 2 volt, and this is small signal. So this input, this voice input, that will have amplitude of some millivolts. 20 millivolt, 10 millivolt, 5 millivolt. So that is a AC signal. The signal would be something like this. So the voice that is coming from me, that would be a AC signal. The amplitude will be varying. So I am saying that my voice is some 20 millivolt sine omega t. This is my voice. Now why I am saying that this signal has to be small and this is large? So let's just say to turn this mic on, I need 0.8 voltage. To turn this mic on, I need 0.8 voltage. So from the PC, I am giving it 0.9 voltage. Like if my voltage is 0.8 or greater than 0.8, then my mic will turn on. Okay. If my voltage is 0.8 or greater than 0.8, then my mic will turn on. So what I did, I gave it 0.9 voltage so that my mic is turned on. So now my mic is turned on. Now what do? I will apply my voice signal as well, no? Because I need to give it a voice, because the job of this particular mic is to amplify my voice. So I will give a signal as well. That should be my voice. Now let's just say I gave the signal of amplitude 0.2 sine omega t. Now what is this? This is my applied input. This is my voice. This is my voice, and this was the DC bias. Now how my voice will look like? This is how my voice will look like. It can go plus 0.2, it can go to minus 0.2 as well. Now what will happen? This DC bias and this voice signal will be superimposed. Basically, the total input that is applied to the mic will be 0.9 plus 0.2 sine omega t. Now maximum it can go up to 0.11 and minimum it can go up to 0.7. So if it is going towards 0.11, then it's fine. Mic is turned on. But if it is going towards 0.7, then mic will be off. So here I was expecting, at this point I was expecting that my voice will be amplified. But what will happen? If mic is not even on, then how the voice will be amplified? So the reason is, if I am superimposing a small signal, a different input, a small signal, if I am superimposing on the large signal, then the signal has to be small. So this AC input has to be small. So that's why it is known as small signal, and it will have a very small amplitude. So in the examination, you don't need to worry about all these things. I told this particular topic just because you should know what we are going to study. We are going to study that how this particular device will amplify my voice, how much amplification it will give. So that thing we are going to study. But in the question there will be word written large signal, or it can be written DC bias. There will be small signal, there will be AC input. So you should have an idea, what do we mean by small signal? What is the meaning of AC input? Why we are giving it a DC supply? So DC supply we are giving to turn it on, and this AC input is the input that user is applying. That means that I am applying that so that my voice gets amplified. So the job of analog designer is to design a particular amplifier. He will design a particular amplifier. He will tell the user that to turn it on, you give this particular amplifier this much amount of voltage. Let's just say 2 volt. When it is turned on, now you can apply another small signal input here. So there are 2 input on this amplifier. One is the supply, which is shown by VDD, and this is small v in, which is given from the user. I hope you would have understood this point. Let's go to our analysis part now. Okay, so I will remove all this off, because here I just wanted to let you know that what we are going to study. Okay, same goes for this loudspeaker as well. I thought I would explain it with loudspeaker example as well. Same goes for this loudspeaker. First we need to turn it on, then we will give it a song. Like we can insert some song in this one, then it will be amplifying the song as well. Like we use this loudspeaker at some occasion, no? So first we need to turn it on. So that is the DC bias. And then we will apply some song to it, and that will be amplified. So that is the small signal. So we will study this analysis only. We study this analysis as well, but this is also important, but not that important. And this analysis is pretty straightforward. But now we are going to study this small signal analysis, this AC analysis we are going to study. Now, important thing, whenever you are studying small signal analysis, at that time you will ignore large signal. That means you will nullify all your large signals. Basically, if I am doing the analysis of small v in, then whatever the supply that I have applied, VDD, that will be shorted. This is my amplifier. Okay. It is having a VDD supply as well. It is having V input as well. And it will generate some V out. So if I am studying this analysis, if I am studying about this guy, then I will nullify this VDD. Okay. Not only VDD, it can have some current source as well. In place of this VDD, there can be some current source as well. VDD, IDD, IDC. So when I am studying about this V in, this IDC will be nullified. That means this will be open circuited. Nullifying means you understand, right? Voltage source will be shorted and current source will be open circuited. So here current source will be open circuited. And why do we do so? That region I explain, but in the comprehensive course, not here. Okay. It will not be possible to explain that particular topic or that particular point here in this course, because here we are just looking at the problem solving. So first 10 minutes I wanted to spend just to let you know that what you are studying. So I hope the idea is clear now that what you are studying. Now let's get started with our MOS amplifier. So you will see this kind of structure in the examination. what you will see, this kind of structure. So if the arrow is outward, okay, if the arrow is outward, this is known as NMOS. What it is known as? NMOS. If the arrow is outward, this is known as NMOS. Okay, this this arrow is there, no? So this particular node is known as source. Even if you forget these names, then also it is fine. This particular node is known as source. You are not going to forget it because I will we will solve a lot of problems. So you are eventually going to remember it. After 1 or 2 hours of this video, then eventually you are going to remember these points as well. So this point is known as source. Wherever you see the arrow, that is source. The middle one is gate, and one which is left, that is drain. All fine? Okay. Now there is a small signal resistance R0 is present between drain and source. It will not be shown. In the examination, only this much structure will be shown. In the examination, only this much structure will be shown. But you should understand on your own that there will be one R0 present as well. One resistance is also there between drain and source. Are you getting this point? Between drain and source, there will be one resistance present. Is that clear to you? Okay. Now let's see about our small signal analysis. So this is my, let's just say here I have applied some small signal V1 voltage, and here I have applied some small signal V2 voltage. Okay. And here there is a resistance, that is R0. Now in this MOS, in this particular MOS, in this device, how much small signal current will flow? The current will be GM into V1 minus V2. How I am writing down the current? The current is, in which direction I am writing down the current? I am going from V1 to V2. I am writing down the current in downward direction. So what current I will write? GM into, I am writing in the downward direction. That means I am going from V1 to V2. So GM into V1 minus V2. That current I am writing down. And R0 is also present. Okay. Now let's just say I need to write down the current in upward direction. Let's just say I need to write down the current in upward direction. I can write down the current in upward direction as well. This current is flowing from this device. That's it. There could be any circuitry here. There could be any circuitry here as well. But if I know the potential of gate, if I know the potential of source, if I know these two potential, the potential where there is arrow and the potential which is there right in between. This right in between is known as gate. This is known as source. So potential at the arrow if I know, and potential that I know right in between. So if I know these two potential, and if I need to write down the current, then certainly I can write down the current as well. I can write down the current in downward direction as well, in the upward direction as well. So how will I write down the current in the upward direction? So what will be the current? GM. What is this GM? I will tell you. Okay. GM into, where I am writing down the current? Upward direction. So where I am going? From V2 to V1. So GM into V2 minus V1. So this is how I am writing down the current. This current is flowing from this MOS, not from this R0. This current is flowing from this MOS. Okay. Is that clear to you? So in both of the direction you can write down the current. Just you need to know these two potentials. Just wait a second. Yeah. So you would have understood this point. So I am again making this circuit. Again I am making this circuit. Okay. We know all the potential. This is known as gate, source and drain. Between drain and source, from here to here, there is a resistance R0. Now let me know if this potential is V3 and if this potential is V1. Can I write down the current in MOS? No. For writing down the current in MOS, you need to know this potential, that is V1, and you need to know the potential where there is this arrow, which is this V2. Now I can write down the current in downward direction as well, in upward direction as well. So how I will write down in downward direction? Because here I have shown already the upward direction. Downward direction, that means I am going from V1 to V2. So the current would be GM into V1 minus V2. This GM is known as transconductance. Okay, transconductance. Mostly your answer in the examination will be given in the terms of transconductance. Okay, this is known as transconductance, but mostly in the examination you will not have to calculate this GM. Because if you need to calculate this GM, then it will come from large signal analysis. Large signal analysis. So it might happen that you need to calculate this GM as well, but in this video we are not learning this particular topic. We are only learning how to do the small signal analysis. So there is very high chance that in the examination your answer will be given in terms of GM only. Are you getting this point? So this particular circuit was known as NMOS, and here you have seen this is gate, this is source, gate source V1, V2, write down the current direction, and then there is a R0 present, which you can, which will not be shown in the examination, but you have to assume this R0 on your own. Okay, so we will come to this particular structure, but first let's solve some problem. First let's solve this question. What they are saying, VDD and VX are the DC bias. You need to tell the small signal input resistance R in. This resistance you need to tell. So what you will do, first thing, VDD, DC bias shorted. So what I am gonna do in the examination, VDD is the DC bias, it will be shorted. VX is the DC bias, it will be shorted. Now what I need to find, V in. If you need to find any resistance, what do you do? If I need to find any resistance from anywhere, from here I need to find V in. So what I will do, here I will apply V in and get some I in out of it. I will apply some V in, get some I in out of it. So what will be my answer? My R in would be V in by I. Okay. But important point is, between this drain and source there is some R0 connected. This R0 is connected. So R0 is connected here. R0 is connected here. Where you are applying V in? Here you are applying V in. And where is your I in? I in is here. So I in is not the current in MOS. The current in MOS will be something different. I in is the current that is flowing here. Here there will be some different current that I don't know. Are you getting this point? Shall I make this circuit again? Okay. Let me make this circuit again on a bigger level. That here this guy is shorted. So from here to here I have R0 and this is also shorted. Now what I am doing, I am applying a V in here and getting I in out of it, and my R in will be V in by I in. Okay. If this potential is V in and this current is I in, so here what will be the current? Certainly not I in, it would be something else that I can write down. We will certainly write down that current. So how we will write down the current? For writing down the current in MOS, which all two potential you need? This potential I need and this potential I need. I need these two potential, this potential and this potential. Do I have this potential? Yes, that is 0. Do I have this potential? Do I have the potential of this node? Yes, because V in will travel here. There is no resistance in between. Let's just say if this potential is V in, so what will be this potential? V in only, because there is no resistance in between. So if this is V in, this will also be V in. Now I need to write down the current. I can write down the current in upward direction as well, in the downward direction as well. Here this is V in, so I am writing down the current in upward direction. So what will be the current in upward direction? So if I am going upward, that means I am going from V into 0. So my current would be GM into, I am going from, current would be GM into, I am going from V into 0. V into 0. So GM into V in minus 0. So what will be the current? GM into V in the upward direction. Direction is very important. So current is GM into V in the upward direction. GM into V in the upward direction. What will be the current in R0? Because what is my target? My target is to write down V in by I in. So I need this I in value now. So for that I am finding, because this I in will be divided in two paths. One path is this one, GM V in. Another path is this. So what will be the current in this R0? The current would be this. What is this potential? V in. What is this potential? This is grounded, so this is 0. So what would be the current here? V in by R0. Are you getting this point? Why I am doing so? Because what is my target? Target is V in, finding V in by I in. Are you getting this point? So I applied V in here. I got to know that in MOS GM V in current is there. In this resistance, V in by R0 current is there. So what did I get to know here is that my I in is equals to GM into V in plus V in by R0. Right? So what I am getting? V in by I in. So my V in by I in would be, V in by I in would be 1 by 1 upon R0 plus GM. Right? So let's just say I write down this as 1 upon 1 by GM. Can I write it down? Say yes or no, right? If two resistors are connected in parallel, R1, R2, and I write down their equivalent, what I can write down? 1 by R equivalent. This is equals to R in, right? This is equals to R in. This is equals to R in. So if I am writing down the equivalent, it would be 1 by R1 plus 1 by R2. Say yes or no, right? 1 by R equivalent is equals to 1 by R1 is equals to 1 by R2. So what you can write down? R equivalent is equals to R1 parallel R2. Say yes or no, right? R equivalent is equals to R1 parallel R2, or you can say 1 by R equivalent is equals to 1 by R1 plus 1 by R2. Now you let me know one thing. This is your R in, right? If I write down 1 by R in, 1 by R in, that means R in goes here and this thing goes here. So what will be your 1 by R in? 1 by R in will be equals to 1 by R naught plus 1 by GM. 1 by GM. Because here there was GM, so I am writing 1 by GM. So 1 by R in is equals to 1 by R naught plus 1 by GM. So what is your R in? So R in is equals to 1 by GM parallel with R naught. Say yes or no. This is the answer. In the examination, it will not take this much of time. Believe me, in the examination, it will not take this much of time. This is very, very easy. Without even learning any model, without even learning anything, without even going into complexity, we are solving the problem. And with this concept, you will be able to solve any problem from MOS. Okay. What we are applying? First, we will write down what is our target. Our target is to find R in, V in by I in. V in, it is there. So GM V in by R naught. So I in is equals to GM V in plus V in by R naught. So V in by I in is equals to 1 by GM parallel with R naught. Okay. So we will come to the conclusion. In the end, it will be very easy for you to write down. Okay, we will certainly come to the conclusion. But first, let's solve some problem. Then we can come to the conclusion. Let's solve this one. From here, I need to find I in. So one thing I forgot to tell you, that this gate always drives 0 ampere current. Okay. This gate always drives 0 ampere current. Whatever this current is flowing, GM V2 minus V1, that is flowing from this MOS. From this gate, there will be 0 ampere current. From this gate, there will be 0 ampere current. So this current will be 0 ampere. Right? So now what I need to find? I need to find this R in. What will be this R in? R in will be equals to, what do we do? DC bias is shorted. DC bias is gone. This DC bias is gone. So what I will do now? Here there is R naught present. Here there is R naught present. Between these two guys, there is R naught present. There is R naught present. Between these two guys, there is R naught present. But DC bias is gone. So what I am finding? R in. What is my R in? V in by I in. Basically, I will apply a V in here and get I in out of it. I don't know what is my V in. I don't care about that. But I know that my I in is 0. My I in is 0. That means my R in is infinity. So looking from the gate, how much resistance do you see? That is infinity. And that is obvious as well, because the current is 0. This current is 0. If the current is 0, that means resistance will be infinity. Certainly, we will come to the conclusion. Don't feel like that, sir, I need to remember all these things. No. We will come to the conclusion and it will become very easy for you. Let's see this circuit now. What we need to find? We need to find again R in. So from here, I need to find R in. So what I'm going to do? I'm going to apply a V in here. I'm going to apply a V in here and get I in out of it. Say yes or no. And DC bias will be gone. This is a DC current. It will be mentioned in the examination, although the ID is a DC current, VDD is a DC bias. It will be mentioned. So this is a DC current. This will be gone. Now VDD will be shorted, but since the connection is broken here, since the connection is broken, so this is of no use. VDD will be shorted, but current source is gone. No. So connection is broken. So this is of no use. This VDD of no use. So I can remove this whole part now. Whole part is removed. So now this is my circuit. Okay. What is this node? What is my target? My target is to find R in. That is equals to V in by I in. What is this node? This node is V in only. Now between drain to source, there is R naught connected. Now this node is V in. Can I write down the current in MOS? Let me make R naught a bit far away. Okay. Can I write down the current in MOS? Yes. How I am writing down the current? I am writing down the current from V in to ground. From V in to ground, that means I am writing down the current from up to down. V into ground. So what will be the current? GM into V in. Now what is my target? My target is to find I in. Now let me know one thing. Will this drive any current? Look, the circuit is this one. If you look it closely, this is the circuit. What did I tell you? That this drives 0 ampere current. That doesn't mean that this will also drive 0 ampere current. No. Are you getting this point? Here this guy is driving 0 ampere current, but from here current can flow. Why is that so? Because this current will have another path, no? This I in current will see two paths. One is going into the MOS and one is this one. This current has two paths. The I in current got to know that the input of MOS, this will drive 0 ampere current. So I in has no other path but to go here only. Are you getting this point or not? A lot of guys do this mistake. They see from here, they will say I in is 0. No. I in has two paths. One is this one. Another one is this one. So I in will go here. So now I in again have two paths. One is this GMV in, and what is the other path? Other path is to go into R node. So what will be the current in R node? Think about it. If this node is V in, if this is V in, this will also be V in, 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 V in. This will also be V in. Say yes or no. V in will completely travel. So this node is also V in. If this node is V in, then this node is also V in. This node is V in, this node is ground. So what is the current here? V in by R node. So what do you see here? I in is equals to GM V in plus V in by R node. Have we seen this kind of equation before? Yes. I in is equals to GM V in plus V in by R node. So what was our R in then? What was our R in? R in was 1 by GM parallel with R node. Say yes or no. Yeah, sorry for the interruption because I was kind of feeling hot. Not hot like that. Hot means feeling the heat, okay? Yeah, so where were we? We calculated R in. That was also coming out to be 1 by GM parallel with R node. So first thing, you don't need to mug up these results. You can derive it in the examination, or we will write down the conclusion now. So let's see the conclusion. Mic is connected, yeah. So this circuit is given and you need to tell R in value. So what you will do? Sir, I will apply V in and get I in out of it. This is what you will think in the examination. Sir, I in will be 0 only, because here if I apply V in, I in has only one path, that is there to flow from the input of the MOS, or you can say to flow from the gate. So gate will drive 0 ampere current, sir, and that's why my R in will be infinity. Very easy. Here also, sir, I will do the same thing. I will apply V in. I will get I in out of it. But sir, now this I in has two paths. One to flow from the gate, other one is this path. In the gate, there would be no current. So the next path would be this one. So this I in will follow this particular path. Now the thing is, where this I in will go. So I in can go into this MOS as well, and there is one R naught is also connected, which we cannot see. R naught is also connected there. Where it is connected? Between drain and source. R naught is connected between drain and source. Now let me know one thing. Where the source is connected? Source is connected to ground. Now my job is to connect this particular node to source. But source is connected to ground, no? Source is connected to ground. So can I connect it like this? Directly I am connecting it to ground. Because source is already there at ground, so I can make it to the ground as well. Let's just say if your source was connected to some network. It was connected to some network. And then this network was connected to ground. So then you cannot do this thing. Then you will have to connect this particular node to source only. But now your source is connected to ground. So at a lot of places or during the analysis as well, I will also do the same thing. If I see source is at grounded, then between drain to directly to ground I will connect it. Because this is grounded, so this is also grounded, right? So now this V in will be traveling here, this V in will be coming here as well, sir. Now since this is your V in, so I can write down the current in MOS, that would be, sir, GM into V in, sir. Now this I in has, sir, two current components, that one is GM V in and another one is V in by R naught. This I in will have, sir, two components, GM V in and other one is, sir, V in by R naught. If you have written down this equation, then you would know what is your answer. If this equation is coming, then you know that my R in will simply be 1 by GM parallel with R naught. Okay. So what do you think? What will be the unit of GM? What will be the unit of GM? What do you think? GM, 1 by GM is a resistance, right? 1 by GM has a unit of resistance, that is ohm. So GM unit will be Maho, right? So just for the knowledge I am telling, because here my target is just to tell you how to solve the problem in the examination. That's it, nothing else. Comprehensively I teach this topic in 45 hours. Okay, recorded lectures are 45 hours for MOSFET, because that is a very important topic. But since the examination is near and I know a lot of people skip this topic because this is taught for roughly around 4 to 5 hours everywhere. I don't know why, but this is very important. Since it is very important, that's why I am taking it. I will take all the possible example, don't worry. Okay, and certainly you will be able to solve the problem in the examination. Sure, you will be able to solve it. What about this circuit? Have we seen this circuit? Yes, this was our first circuit only. This was the first circuit only. Here what was the scene? Both were grounded. So what did I do here? Here your gate was also grounded and drain was also grounded. Gate and drain both were grounded. Here what did I do? Here also both are grounded only. Here also both are grounded only, but I connected both of them and then I connected a ground. Both are grounded only. And let's just say you forget it everything. You forget everything. What you are going to do? One thing you know, I need to find R in. What I'm going to do? Apply V in, get I in out of it. One thing I know, that here there will be R not connected. Right? The other node of this, one node of this R node is connected to V in. One node of this R node is connected to source, and source is connected to V in. Other node is connected to drain, and drain is connected to ground. So can I make it something like this? Other node is directly connected to ground, so can I connect it to ground? Yes. Now what you can see, I in will have two components. One will be going into MOS, another one will be going into R node. What will be the current in R node? From V in you can see the current is going V in by R node. And from V in the upward direction, what will be the current? GM into V in. So two components, GM into V in and V in by R node. So what will be your R in? R in will be 1 by GM parallel with R node. This will be your R in. So I will remove all this off. Okay, I will remove all this off because here I need to tell you one conclusion. So now let's see a very interesting thing. So what I can say, look, this is a particular structure now. So this particular structure I can call as 1 by GM. This is just a rough way of telling it, that wherever I see the arrow, so this much portion I am calling as 1 by GM. What do I mean by that? What is this? This is our source, this is our gate, and this is our drain. So I will say that from source to gate I can see 1 by GM. From source to gate I can see 1 by GM. What I am saying, from source to gate, I can see 1 by GM resistance. Now gate is connected to drain. And drain is grounded. Here from, what did I say? From source to gate, what do I see? I see this arrow. So from source to gate I see 1 by GM. Now this gate is connected to drain and drain is grounded. So from source to ground I see 1 by GM. Do you agree to this point? Are you getting this point? Now sir, now you will say that, sir, can I apply this concept here? No. Why is that so? Because you are not even looking from the source. You are looking from gate here. So here you will do the same analysis. Here also you can do the same analysis that I have taught you. But just for the shortcut purpose I am telling. If you are looking from the source, whenever you look from the source, there is a shortcut. What is that shortcut? That always you can say that from source to gate I can see 1 by GM. Do you agree to this point or not? Okay, whenever you are looking from source, because in a lot of circuit, like in analog electronics as well, like in 90% of the circuit you will have to look from the source. So whenever you are looking from the source, that's why I am telling this conclusion, this shortcut I am telling. So whenever you are looking from the source, you can say that from source to gate I can see 1 by GM. Here gate and drain both are connected to each other. So I can say that from source to drain as well I can see 1 by GM. Now since drain is grounded, so from source to ground I can see 1 by GM. Now another thing can I tell, from source to drain I can see R naught. What I am saying, from source to drain I can see R naught, and drain is connected to ground. So from source how much resistance I can see? So what I will say, sir, from source to ground I can see, 1 by GM. From source to ground I can see R naught. So basically from here how much resistance I can see? R naught parallel with 1 by GM. There you go. Say yes or no. Will you be able to tell it? Certainly you will be able to tell it. Right? Okay. Well and good. No issue about it. So very good point it is. So let's keep it here. अरे यार चला गया. So I will just make it source R naught, source to gate. Here I am writing 1 by GM, and this I will write source to drain, that is also 1 by Gm. Here I am calculating. So although the drain is grounded, here also the gate is also grounded. So from source to ground I can see 1 by Gm parallel with R naught, and this is what you need to find. What is my Rin? Rin is the resistance from here to ground. Look, whenever I tell, if I ask you this question, that what is your R equivalent? So only at that time you can say R equivalent is, let's just say this is R1, this is R2. So you can say R equivalent is R1 parallel with R2. Only when both are connected to ground or both are connected to each other. Let's just say both are connected to each other. R1 is connected to R2 and they are connected to another resistance. And then this is connected to ground. So always there is a ground. So what you will say, what is your total resistance? That's R1 parallel with R2 plus R3. So these two are providing you R1 parallel R2 plus R3. That would be your answer. So same thing we are doing here. Looking from the source, I need to find the resistance. So from source to ground, I need another resistance. One resistance I need from source to ground, another I need from source to ground only. So from source to ground, I get 1 by Gm. From source to ground, I get R naught. So from source to ground, the resistance is 1 by Gm parallel with R naught. Say yes or no. Well and good. Okay, yeah. So we will use this thing again and again. So there you will learn it in a better manner. So when you go into the video, you will certainly learn all these things. Your target is just to watch it and keep on doing the work in your rough notebook. You should not make any notes. Just keep on doing the same thing in your rough notebook. Certainly you will be able to solve the problem in the examination. Let's get started. Do this question on your own. Okay. You need to find the value of Rin. I will take a pause. You try doing this question on your own. How will you find Rin? This IDC and VDD both are the DC bias. So what will happen? This will be gone. Now find Rin. You should be able to find it. Same thing we need to do. Apply V in, get I in out of it. Target is V in by I in. So now get the relation of I in terms of the known factors. Try doing it. Yeah. So how we will solve it? What we are going to do? V in, get I in out of it. What will be your R in? If you have just solved it, then just skip this. Okay. Just quickly skip that to the next 1 or 2 minutes, because here I will be solving it, and just see if your answer matches or not. If your answer is not matching, then see the solution. Otherwise, go to the next one. So in that manner, you can save your time. That's why I ignore taking the session live. If I have taken the session live, then you would not be getting any, like, your time would be wasted if you see it live. But if you watch it recorded, you can quickly skip to the part which is required for you, right? What I need, V in by I in. So what I know is that there is between drain to source. Source is connected to ground. So between drain to ground there is R naught connected. Drain to source it is connected, but source is connected to ground. So from drain to ground there is R naught connected. So what will be the current in this R naught? That will be V in by R naught. And if I am making the resistance here, then I need to show the current here. This will be my I in. Are you getting this point? So this I in is from drain to ground there is R naught. So how much current is flowing this R naught? That is V in by R naught. And if this node is V in, then this node will also be V in, because this V in will travel here. So how much current will be flowing into the MOS? That current will be Gm into V in, right? Because I am writing down the current in MOS. Gm, I am going from V in to ground. So current will be Gm into V in minus 0. So current will be Gm V in. So what is the factor? I in is equals to two currents. One is flowing in the R naught, that is V in by R naught. And another current is Gm V in. So what will be your R in? This equation I have already seen. So Rin will be 1 by Gm parallel with R naught. Within seconds you will be able to tell the answer. Luckily we are getting these answers again and again. That doesn't mean always the answer will be 1 by Gm parallel with R naught. It would be different as well. We will slowly build the toughness level of the problem. Tell the answer of this one. Again do the same thing. What do I know? This thing I know, right? That between drain to source there is resistance R naught. Now can I connect this R naught to ground? No, because my drain is not connected to ground. Drain is connected to resistance R. So this R naught should also be connected to resistance R only. Say yes or no, right? Now this VDD I can take to ground. VDD I can take to ground. What I need to find? I need to find this R in. That means what I will do? I will apply V in, get I in out of it. So my target is R in, that is V in by I in, right? So what I can do now? Can I write down the current in MOS? First we will solve it, then I will tell you a conclusion as well here. So first we will solve it. So can I write down the current in MOS? For writing down the current in MOS, I need this potential and this potential. Do I know this potential? No. In the previous questions, I was always knowing this potential. It was connected to ground only. But now this is connected to resistance R. So do I know this potential? No. So what I will do? I will assume a potential here. I have to assume a potential that is V. So what I have assumed? I have assumed a potential V here. Okay. So can I write down the current in MOS? Yes. How I am writing down the current in MOS? I am writing down the current in MOS in upward direction. So current in the MOS will be Gm V in minus V. If I am writing down in the upward direction, Gm V in minus V, that will be the current. Now this V node reaches here as well. So what will be the current in this R node? The current in this R node will be V in minus V by R node. Say yes or no. That would be equals to I in. Do you agree to this point? I in has two paths again. One to flow through this MOS and another one to flow this R node. So through this R node, how much current is flowing? V in minus V by R node. And through this MOS, how much current is flowing? Gm into V in minus V. Because I am writing down the current in upward direction, so V in minus V. So that is the equation. But what is the issue here? The issue is this V potential. Because what is my target? To get the relation between V in and I in. So issue is this V potential. So I need to get this V potential in terms of I in or V in. So what do I see here? From V in, I in current is flowing, right? That is being divided into two paths. Now what will happen? These two current will again come back. These two current will again come back and then both will be added. So how much current will be this? If you are not understanding by this particular analysis, so let me show here. I am saying one current is flowing I in from here. Now these are the two current. One is I1, one is I2, right? These are the two current sources. Now if I ask you what is the current in this resistance R, what will be that current? That current will be I1 plus I2. I1 plus I2. Now what is this I1 plus I2 equals to? That is equals to I in only. Because from downward I in current is coming, that is being divided into two paths, then again added. So from R, how much current is flowing? I in only. Say yes or no. Are you getting this point? Right? So all the current will be added and then that is flowing from R. So certainly this current will also be I in only. Getting this point? Right? So in the resistance, I in current is flowing. So can you let me know what will be this drop? The current is flowing from V to ground. What will be this drop? That will be I in into R. Right? So what will be the value of V? The value of V will be I in into R. Say yes or no. Value of V will be I in into R. Because if this node, let's just say, this is very simple network analysis, but if you don't know these concepts, then it is very tough for you. The current is flowing like this. If the current is flowing upward, what does that mean? What will be the drop? This will be the drop. So let's just say this current is I in. So what will be the drop? I in into R. So if this node is grounded, 0 volt. So what will be this node? From here to here if you are coming. So this node will be positive. So positive will be I in into R. The issue will be the direction. Issue will be with the direction or positive or negative sign. So it will be positive. I in into R it will be. Why is that so? Because 0 is a negative. So from 0 to something you are getting. From 0 to towards positive side you are getting. So that is I in into R. Or you can write down the current as well. I in into R minus 0 divided by R. That will be I in from in the upward direction only. So I hope you are understanding these kind of points, which are very basic network analysis. It is right. So I in. Okay. So another relation that I got is this one. That V is equals to I in into R. So here can I put I in into R? Yes. I in into R plus V in minus I in into R divided by R naught is equals to I in. Okay. So now what you can do? So Gm plus 1 by R naught into V in is equals to I in into R by R naught plus 1 plus GMR. Look, this is a very strange kind of expression we are getting, and we are not going to get anything good from it. So whatever the expression you get from here, you will get R in. So that will be equivalent to what? Can I write it down without any equation? Yes, I can write down. How? What did I tell you? From source to gate, how much resistance do you see? 1 by Gm. What did I tell you? That from source to gate, how much resistance do I see? From source to gate, the resistance I see is 1 by Gm. So from source to drain, how much resistance I will see? R naught. From source to drain I see R naught resistance. Now drain and gate both are shorted or not? Yes, both are shorted. Drain and gate both are shorted. This was our drain. This was our gate. From source to gate I see 1 by Gm. From source to drain I see R naught. And gate and drain both are shorted. Now the node of gate is connected to R. Sorry, node of gate you can say, or node of drain you can say. Drain is connected to R. Drain is connected to R, and that R is grounded. Is this the circuit or not? Say yes or no. Where I am looking from the source. So from source to gate I see 1 by Gm. From source to drain I see R naught. Drain is connected to R and R is connected to grounded. Is this the circuit? Forget about this drain, gate and source now. From where I am looking? I am looking from here. So what will be the resistance? 1 by Gm parallel with R naught plus R. Do you remember the example that I showed here? Right? The same kind of circuit we are getting here. Analog electronics is just network analysis only. But here we use devices, nothing else. Okay? So without even getting these kind of complex equation, this is what I wanted to tell. And from the equation we are not getting anything good. But in the examination, what kind of option will be mentioned? The option will be mentioned in this manner. 1 by Gm parallel with R naught plus R. This is how the option will be mentioned in the examination. Because they want you to think in this manner. That from source to gate, I see 1 by Gm, gate is connected to drain. So source to drain, I also see R naught. So R naught is coming parallel to 1 by Gm, then that is connected to R. So 1 by Gm parallel with R naught plus R, that will be the answer. Are you getting this point? Say yes or no. Okay. Solve this question. R naught is infinity here. What they are saying? R naught is infinity. That means whatever the resistance here we got, this resistance here we got, no? So that is infinity. Infinity means open circuit. Basically R naught is not there. This is what they are saying. They are saying that R naught is not there. This is what they are saying. R naught is infinity means R naught is not there. Other way of showing it, they will say that there is no channel length modulation. What they will say? There is no channel length modulation. If they say this thing, now I cannot tell you what do you mean by channel length modulation. In the examination, you just need to understand if they are saying that there is no channel length modulation, or they can say lambda is equals to 0, or they can say R naught is infinity. All three are same thing. What does that mean? That you will not connect any R naught here now. So now this question becomes very easy for you. How this is becoming very easy? Because what do you need to find now? R in you need to find. That means you need to apply V in here and get I in out of it. In the previous problem, I in was having two paths. Here also I in was having two paths. But now I in will have only one path, and that is to flow through MOS. So this I in will be flowing through MOS. This Vx1 is a DC bias. This is gone. VDD is a DC bias. This is also gone. This is gone. And this is also gone. So what do you think? What will be the current in the MOS? The current in the MOS in upward direction will be what? Gm into V. Say yes or no. The current in the upward direction in the MOS will be Gm into V in only. And here what you are having? Here you are having V in. So from V in to 0 you are going. That means the current is Gm V in minus 0. So current is Gm V in. That is equals to I in only. Because R naught is not there. So Gm V in is equals to I in. So what is your R in? My R in is V in by I in. That is equals to 1 by Gm. There you go. Say yes or no. Is that okay for you? Very easy question now, right? Let's go to the next one. Or how you can say that, sir, from source to gate, sir, what do I see? 1 by Gm, and gate is connected to ground. From source to gate, I see 1 by Gm. From source to gate, I see 1 by Gm, but gate is connected to ground. So from source to ground, how much resistance I see? 1 by Gm. Now you will say, sir, what will happen to this R? Does that matter to you? No, it doesn't matter. Like wherever this R is there, I don't care. But one thing I can see that from source to gate, from source to gate I see 1 by GM and gate is connected to ground. So from source to ground I only see 1 by GM, nothing else. From source there is only one branch going in. That branch is this one. From source there is only one branch. That branch is this one, and this branch is 1 by GM. So from source to ground I see 1 by GM. I don't care what will happen to this R. But if I am looking from the source, I can see one thing, that from source to gate I see 1 by GM and gate is connected to ground. That means from source to ground I see only 1 by GM. Answer is 1 by GM. Just by looking at the circuit, I will write down the answer in my examination. Say yes or no. Okay. Let's go to the next one. Did you understand this one as well? This was also pretty good. Here the thing I told you, from source to gate and drain are connected. So from source to drain I see 1 by GM, from source to drain I see R naught, from drain to ground I see R. So this is how I can write down the resistance. Okay. Sorry for the interruption because I was again feeling cold. Okay, yeah. So now let's see this circuit. So in this circuit you need to find the value of Rin. A very good circuit, a very standard circuit as well, and very important for your examination as well. So can you say that, sir, from source to Vx will be grounded? Let's make the small signal circuit. The small signal circuit will be VDD will be grounded. This is the resistance R. And from here I apply V in, and this node is also grounded. Okay, and then there is R naught present as well, because this time R naught is finite. Now R naught is not infinite, R naught is finite. What I will do, I will apply V in and get I in out of it. So can I say, sir, now from V in to ground, or I can say from source to drain I see 1 by GM, or I can say from source to ground I see 1 by GM. There is no issue about that. But is that the only resistance you see? From source side or from V in, do you see only 1 by GM till the ground? No. From source till the ground, you do not only see 1 by GM, because from this V in there is this R naught is also connected. No. The thing is, here there is source. Here you see 1 by GM, that is connected to ground. But now here the scene is R naught is also there. This R naught is also there. And previously when we saw this particular circuit, these two nodes were connected to each other. That means source and drain were connected to each other. Both of them will be connected to each other. There I saw 1 by GM as well, there I saw R naught as well, but both were connected to each other. But here what is the case? This guy and this guy is not connected to each other. Right? And can you say that, sir, directly this R naught, this R resistance is connected to R naught? No. This R resistance is connected to MOS as well, and it is connected to R naught as well. Previously, what I could have said that, sir, my resistance R is connected to drain as well and source as well. My resistance R is connected to drain as well and source as well, and both are connected to each other. So this circuit was okay. This circuit was fine for me. But now, if I say that, sir, from where I am, yeah, here I am. So sir, if I say that, sir, from drain to ground I see resistance R, will that be okay? No, because what R will say? R will say that, sir, I am connected to drain as well and another MOS as well. In the previous circuit, in this circuit, R was saying that, sir, I am connected to drain and I was connected to gate, and both are connected to each other. But here R will say that, sir, I am connected to drain and connected to MOS. Basically, R will say that I am connected to drain only, and drain will say that, sir, I am connected to R naught and I am connected to MOS. In the previous question, the drain was saying that I am connected to gate only. So now the small signal, that circuit, that will not work now. So you have to do the analysis. Are you getting this point? That shortcut is not working. Basically, if I see the conclusion here, if both are connected, then this particular configuration will give me 1 by GM parallel with R naught. I can say that from source to gate I can see 1 by GM, and gate is connected to drain. So from source to drain I see 1 by GM, from source to drain I see R naught as well. So basically my Rin would have been 1 by GM parallel with R naught will be given by this much configuration, and then in series there will be R. In series there will be R. This would have been the answer. But now this is the scenario. Here drain and gate both are not shorted. So now you need to do the analysis. What kind of analysis? Let's remove this off. Okay. So can I write down the current in MOS? Yes, I can write down the current in MOS. Let's remove this drain as well. What will be the current in MOS? That will be GMV in. So current in MOS will be GMV in. GMV in. What will be the current in this R naught? That I don't know, because the current in R naught will be V in minus this potential. Let's just say this potential is V, but I don't want that. In the previous question, in this question, I wrote down this V potential, but I don't want that. I'm not gonna introduce any new variable now. So what I'm gonna do, I know one thing, that from V in I in current is going, and this I in current is divided into two paths, then both of the currents are added and it will be flowing through R. So if someone will ask you what is the current through R, that will be I in only. Right? I in current is going, that is divided into two parts and then again added back. So through the resistance R, how much current is flowing? I in only. So what will be the drop here? What will be the drop here? I in into R. Look, I could have introduced another variable as well, but the thing is I don't want to introduce any other variable. So I just want to solve my problems in terms of V in and I in only. And believe me, in the examination you will be able to solve. Okay. So I have reduced down my complete circuit in terms of V in and I in only. So this node is I in into R. And why I need the potential of this node? Because my I in will depend on the current in R node, and R node will depend on the potential V in as well and this potential as well, which is equals to I in into R. So that's why I need this particular potential. So can I write down the KCL now? Yes. So my I in will be equals to the current in MOS that is going upward. What is that current? GM into V. Plus what will be this current in R node? That would be V in minus I in into R divided by R naught. So what you are getting? I in into this goes here. So R naught plus R divided by R naught is equals to GM V in. So what is your R in? Here it is R naught only. So V in by I in I need to find. So क्या कुछ गड़बड़ हुई है यार? No. Okay, fine. R naught plus R divided by 1 plus GM R naught. So this is the answer of R in we are getting. What answer we are getting? R naught plus R 1 plus GM R naught. You need to remember this answer. If it is possible, then remember it. Otherwise, at least you will be derived in the examination. But if you remember it, then it will be very good. Where I am going? I am going from source. I am looking from source. Looking from the source, how much resistance I am getting. Looking from the source, how much resistance I am getting. So how will you remember? First look from the source. This is just a way of remembering it. This is not any intuition, nothing like that. Just a way of remembering it. Okay? Just a way of remembering, I am telling. So looking from here, what do you see? These two resistance. Just assume them in series. R naught plus R divided by something. So this factor GM R naught, that you will be remembering like 100%, because now we are going towards, now we are writing down what we are writing down. We are writing down the input resistance. But when we will go towards the gain, so at that time you will be certainly remembering this term. This term is very easy. GM from here, R naught here, GM into R naught. So if you remember it, then it is pretty good. Otherwise you can derive in the examination as well. Usually people remember this particular resistance. What I am asking, like I am not saying common source, common drain, these things I am not saying. Okay, this particular structure is known as common gate. Why it is common gate? Because gate is grounded, no? So it is known as common gate structure. But that will not be asked in your examination. In your examination, what you need to do, they will ask you resistance or gain from a particular node. So these kind of analysis you can do. Otherwise, if you want to remember the answer, then also you can remember the answer, because it is a standard circuit. Okay, and what is the way of remembering? R naught plus R divided by 1 plus GM R naught. Okay, but just remember one thing, because this option will also be there. This option will also be there. So don't do this mistake. The point is, both are not connected to each other. If both are connected to, and in this example as well, this option will also be there. Because IITs know that people remember this answer. And what students will do, okay, we are looking from the source. What is the answer we remember? If R is connected, so R naught plus R divided by 1 plus GM R naught. Wrong. That will also be wrong. So you just need to keep your concentration high. You need to give your full concentration that what is happening. Drain and gate are connected to each other or not. If they are connected, then 1 by GM parallel with R naught plus R. If they are not connected, then R naught plus R divided by 1 plus GM R naught. Okay, and here in a lot of example we are getting 1 by GM in a lot of example we are getting this thing as well, no? 1 by GM parallel with R naught. Now in the examination this option can be mentioned, or the final answer can also be mentioned. How you can reduce 1 by Gm parallel with R naught? How you can solve it? 1 by Gm into R naught upon 1 by Gm plus R naught. So what you are getting? R naught upon Gm R naught plus 1 Re. So this answer also can be there. Okay, or this answer can also be there. So the same kind of answer here also you are getting. Here also R naught upon 1 plus Gm R naught, just R is also there. Okay, so what you are getting? What will be the answer here? Here the gate is grounded but drain is not connected to gate. So your Rin will be R naught plus R divided by 1 plus Gm R naught. Okay. And what about this one? Here what we are saying that R naught is infinity. Then no matter whatever the network is there, I don't care about that. One thing I know that from my V into ground, I only see 1 by Gm. That's it. So my Rin will be equals to 1 by Gm. Are you getting this point? So these three different circuits are there. These three different answers are there. I hope this is also clear to you. Now just see one thing. What was the Rin we were getting? R naught plus R upon 1 plus Gm R naught. Now what is the difference between these two circuits? No difference is there. In place of this resistance R, can I use any network? Yes. No difference is there. The only difference is this R naught is infinity. That means in this circuit, in this particular circuit, if I put R naught equals to infinity, in this particular formula, if I put R naught equals to infinity, if R naught equals to infinity, so what will happen? R naught plus R, that means R naught is very large. R naught is infinity means let us say it is some this much and R is some 100. So can I reduce R naught plus R equivalent to R naught only? Yes, because R naught is very large. What is this Gm R naught? Plus 1. Since R naught is very large, that means this quantity is also very large. R naught is very large, that means this quantity is also very large. So I can ignore 1 as well. So what I am getting? R naught divided by Gm R naught. So what I am getting? 1 by Gm only. So this circuit and this circuit both are same only. If R naught is infinity, you are getting the same answer. But in the examination, you will not be doing this much analysis. That you put R naught equals to infinity. There, you will just be seeing that from V naught to ground, I see only 1 by Gm. That will be your answer. Right? But I am just telling you that all things are interrelated. And all these things are very confusing. Student can do minor mistake anytime. If IITs want to frame a very good question, then they will frame the question like this. Are you getting this point? Okay. And my target is just to teach you right from the zero, even if you haven't studied anything, to the point if they are asking very tough questions as well, then also you will be able to solve. Basic question everyone will be able to solve, but those who have studied it comprehensively, believe me, they will also not be able to solve this particular structure. Right? In this circuit as well, they will do some minor mistake. So we are seeing everything. That's why it may take some time, but again, you will be very confident in the examination because that is very important for your upcoming examination. This particular topic is very important. Let's solve this one. Try thinking about it. Look, where I need to see the circuit from, where I need to see the Rin from downward here. From source I need to see. So whenever I need to see from the downward, in the previous example, here I was already getting R. So my concern was not to look from here. Like I knew one thing that upper side I only see R. Are you getting this point? But here R naught will be connected, right? But on the upper side as well, you see another circuit. So that circuit also you need to solve. So always start the circuit from the top. Let's just say from here I need to find. So I will start the circuit from here. If I needed to find the resistance from here, then I would have started the circuit from bottom. Are you getting this point? If I am looking from here, then I will start from here. If I am looking from here, then I will start from the bottom. So one by one, step by step, I will go. Are you getting this point? Okay. So let's make the equivalent circuit first. VDD will be grounded, VX1 will be grounded. This will be mentioned in the examination that both are your DC bias. Or in the examination, it can be mentioned that VX1 is a small signal. What I am saying, in the examination, they can say that VX1 is a small signal. Then also it will be grounded only. Because what we are finding? We are finding Rin. Whenever you find the Thevenin resistance, what do? Everything is gone. Current source is open circuit, voltage source is shorted. So even if they say that this is your small signal voltage, then also it will be shorted. All the voltage sources will be gone. Whether it is small signal, large signal, everything will be gone. Condition that you are finding Rin. So if your Vin is not in use, then that will also be shorted. So here in place of Vx1, if I write down Vin1, which is a small signal, I am saying that this is a small signal, then also it will be shorted only. Okay, this will be shorted only, and then VDD will also be shorted. Both are shorted. So can I connect them to each other? Yes, I can connect them to each other, and then I can say that both are connected to ground. Say yes or no, right? Then downward I am getting this circuit. Both are connected to each other, and they are connected to R0. And from here I am looking, right? Here also there is a R0. Say yes or no. This is connected to ground, but can I say from source to drain there is a R0, and this drain is also connected to ground. Say yes or no. Is this the equivalent circuit? Are you agreeing to this point? Yes. So what did I say? If I need to start from the bottom, I will start solving from the upward side. So my point is, from here I will look that from here to upward side, how much resistance do I see? That means now I need to replace this much of circuit, because if I have replaced this much of circuit, then half of my job is done. Are you getting this point? How I can replace this much of circuit? I know that from here to ground I see 1 by GM, and from here to ground I see R0. That means 1 by GM is parallel with R0. Are you able to understand this point? I am replacing the circuit from here. So what I will say, from source to ground I see 1 by GM, and from source to drain, or I can say from source to ground I see R0 as well. So this particular circuit can be replaced with 1 by GM parallel with R0. Do you agree to this point or not? So how I have reduced the circuit? So from this source to ground, what do I see? 1 by GM parallel with R0. Say yes or no, right? Okay. Now what is the scenario? This is the scenario, and there is also R0. This was not my target. My target was to find the resistance from here. So now if I look from here, what I can see? How much resistance this will offer? How much resistance this much configuration will offer? What I can say? My source is from source to gate. From source to gate, what do I see? 1 by GM. From source to drain, what do I see? R0. And gate and drain are shorted to each other. That means from source to drain I see 1 by GM. From source to drain I see R0 as well. That means how much this is to offer? 1 by GM parallel with R0. This we have already seen. How much this thing will offer? 1 by GM parallel with R0. And that is in series with R. But now what is the scenario? How much thing this is offering? 1 by GM parallel with R0. That is in series with 1 by GM parallel with R0. There you go. And in the examination, what may happen is that they can call it M1. They can call this one as M2. So this will be R0. Sorry, this will be R02. This will be R01. So this I am going to write down as 1 by GM2 R02, and this is your R01. So this will offer you 1 by GM parallel with R01. So what is the scenario now? This is your ground. Just a second. Why this handwriting is not coming that good? I don't know what is the reason. Yeah. So what is the scenario now? That 1 by GM2 parallel with R02, and this much is offering you 1 by GM1 parallel with R01. And from here you are looking. So from here to ground, what do you see? Your Rin is equivalent to 1 by GM1 parallel with R01 plus 1 by GM2 parallel with R02. There you go. This is what you will see. Say yes or no. Right? Very good question it was. In the examination, it will not take me any time, because now I know the process. Looking from downward, I need to solve the upper circuit first. So what I will see, sir, 1 by GM2 parallel with R02. And so this much circuit will give me 1 by GM2 parallel with R02. Then downward I will see here, okay sir, this much circuit will give me 1 by GM1 parallel with R01. So 1 by GM1 parallel with R01 will be in series with 1 by GM2 parallel with R02. So without even drawing the circuit, if I have enough practice, although you don't have enough time for practice, but if I have studied this particular topic only, then also I will be able to write down the answer. Say yes or no. Okay, well and good. So this is the other way of solving it. Now I guess the example will be from, okay, next example will be from PMOS. So first let's solve this question. What you need to find? You need to find V naught by V in. This is what you need to find. You need to find the voltage gain, small signal voltage gain. So how will you find that? Again, there is certainly R naught connected. So from here to source, from drain to source, R naught is connected, but source is connected to ground. So can I make it like this? Yes. VDD will also be grounded. VDD will also be grounded. So can you say one thing? Can you say one thing? Can you make the circuit again? How will you make the circuit again? This is grounded. This is your V in. This is your V naught. So from V naught to ground, what is connected? R naught. And from V naught to ground only, R is also connected. No? Both of them are coming in parallel only. So can I reduce it to one circuit only? Can I reduce it to one resistance only, and can I call it R naught parallel with R? Say yes or no. From V naught to ground there is R. From V naught to ground there is R naught. So both are in parallel. From V naught to ground there is this MOS as well. In between there is MOS as well. So how much current will be flowing in this MOS? If this node is V in, this is ground. So can you tell what is the current? Yes, that will be GM V in. Can you apply nodal at V naught? Yes. What will be nodal at V naught? V naught divided by, now you will not say that, sir, from V naught I will assume a I naught current. No, nothing like that. From V naught you will assume a I naught current if you need to find the resistance. But here I am finding the gain. Here this V naught was just nothing. This was just an open end. It was nothing. I just gave this node as V naught. Let's just say, if I ask you this question, that this is your 2R, this is your 2R, this is your 4 volt. What is the potential here? What is the value of V naught? You will say 2 volt. Will you say that, sir, I will assume I naught current here? If you assume any I naught current here, then the answer will not be 2 volt. Because what we assume is that all the current is flowing in the 2R as well, there is same current, in 2R as well, there will be same current. Then also you can say there is 2 volt, no? So I just assume a V naught node there. That doesn't mean you will say that, sir, there is some I naught current. No. Previously we assumed the current, here we assume the current because we are finding R in. But here we are finding the gain. So in the V naught there is no current, nothing like that. These are basic thing of network analysis that I am telling. Very basic thing, right? So if I assume this is my V naught, so what will be the current in this branch? That will be V naught upon R naught parallel with R plus GMV in. That would be equals to 0. This is how I can apply the nodal, right? So what do we get? V naught by V in is equals to minus GM R naught parallel with R. That's it. What I will be doing in the examination, I will not be writing on this step. What do I know? That this current is GMV in. Now this current has how much path? This GMV in, this is one circuit, okay, which is connected to ground, and then there is some resistance R. This current GMV in, this current can flow from here, and then it will have to flow from here. Are you getting this point? The current has to flow in the loop. This GMV in has to flow in the loop. Why is that so? Because the current cannot go here. Here the current is 0 ampere. So the current cannot go here. The current has to flow in the loop. So what will be the current? Current has to flow in the loop. So how much current is flowing through this resistance? This is the resistance which is R naught parallel with R. And this is your V naught. So how much current is flowing through this resistance? That is GMV in. And if the current is flowing from down to up, then how will be the voltage drop? This is how will be the voltage drop. And this is at the negative node. So what will be your V naught? V naught will be minus R naught parallel with R into GMV in. Voltage will be current into resistance. So voltage will be R naught parallel with R into GMV in. So what will be your V naught by V in? That will be equals to GM R naught parallel with R and minus sign. That will be your V naught by V in. So this is how I will be solving in the examination. Are you getting this point? Like n number of ways are there. Just I am telling you all the possibility which you can use in the examination. Let's see this circuit. So have you seen this kind of device? No. Till now we were seeing that arrow was outward only, right? So this was our NMOS. Now we are going to see PMOS. So let's get back to the first slide now. Here. So this is known as PMOS. Okay, this is known as PMOS. Arrow is inward. In NMOS, the arrow was outward. Now the arrow is inward. Okay. Yeah. So wherever there is arrow, that is known as source. The middle one is known as gate. Rest will be drain. Wherever there is arrow, this is known as source. Middle one is known as gate, and this will be your drain. Say yes or no. Any issue about that? Why I am writing it again? I'm not sure. Okay, same thing is there. Ditto same thing. No need to worry. Between source and drain, how much resistance is there? Or not? If this potential is V1, if this potential is V2, can you write down the current in MOS? Yes. What will be the current? Do you care about this potential for writing down the current in MOS? No, I don't care about this potential. Whatever the potential is there, the current in the MOS is decided by these two guys. So what will be the current? If I am writing down the current in downward direction, what that would be? GM V1 minus V2, because I am coming from V1 to V2. If I am writing down the current in upward direction, what that would be? I am going from V2 to V1, so that would be GM V2 minus V1. There you go. Same ditto analysis is there. Exactly the same analysis. Are you getting this point? So you are not learning anything new here. Now just the device has changed. Rest all property are same only. Okay. So let's get back to our circuit. So what we need to find? We need to find Rin. So in the examination, what I'm gonna do? First, I will make the circuit. Small signal circuit I will make. How I will make the small signal circuit? That sir, these two are connected to each other. And sir, from here I need to find Rin. That means I need to apply V in and get I in out of it. One thing I know that sir, VDD will be grounded, but from here to source to drain, there will be R0 resistance connected. And since this is grounded, so I can connect the R0 resistance directly to ground. Okay. Now can I write down the current in MOS? Yes. Because if this node is V in, then this node will also be V in. So current in MOS will be from V in to ground if I am writing down. The current in the upward direction if I am writing. V in to ground. So what will be the current? So the current will be GM in the upward direction. And what will be the current in R0? So that would be V in by R0. So this will be equals to I in. So what I am getting? My R in is equals to 1 by R0. Sorry, 1 by GM parallel with R0. So this is my R in. Or what you could have done? Let's just say I am not comfortable with PMOS. So what I will do? I will make the same circuit for NMOS. Although this is a very bad approach, but still I am telling you. Let's just say I am not comfortable with PMOS. Although you should be comfortable. There is nothing different. But what I could have done? That sir, I will make a PMOS now. Sorry, I will make a NMOS now. Now here what was the scenario? That this arrow was connected to VDD. This arrow was connected to VDD. In small signal that was connected to ground. Okay. Connected to ground. Now drain and gate are shorted. Drain and gate are shorted. And from where you are finding out the resistance? From drain. So from Rin. This thing and this thing will give the same result. Do you remember this circuit we have already seen? What was the Rin? Here you will apply V in, get I in out of it. V in will have two paths, GM V in and R0. So what will be the Rin? 1 by GM parallel with R0. So Rin would have been 1 by GM parallel with R0. Right? Both will give the same result. I just interchange the scenario, nothing else. Source grounded, drain gets shorted. From where I am collecting? From drain. From here. There you go. Okay. Let's go to the next circuit. Let me know the Rx value. Rx or Rin, like they can give any name. They can call it R out as well. So here I am giving a random name Rx you need to tell. Should be able to tell. What you will do? This VGG is a DC bias. In place of VGG I will write V in here. Okay. What I am saying? This is given in the examination that this V in is the small signal voltage. Small signal voltage. So what you are going to do with this small signal voltage? You will connect it to ground. So if I connect it to ground, then what will happen? What will be my circuit? This will be my circuit. And this R0 is connected in between, or you can say R0 is connected to ground as well, because this is connected to ground only. And what I need to find? I need to find Rx in this manner they can say, or in this manner they can say that I need to find Rx in here. Okay, this Rx I need to find. So what I will do? I will apply some Vx and get Ix out of it. So my target is my Rx is equals to Vx by Ix. Can I write down the current in R0? Yes. What will be the current? Vx by R0, because this node is also Vx. Now this node is also Vx. So Ix is being divided into two parts. One is through R0 and another one is through this MOS. But what will be the current in MOS? What do you think? The current in MOS will be Gm into this potential minus this potential. What that would be? 0 only. The small signal current in the MOS is 0. Small signal current in the MOS is 0. So now the MOS can be replaced with open circuit. What you will see in the examination, if you feel like that, sir, in the circuit my VGS is gone. My gate to source potential is 0. My gate is also at 0, source is also at 0. It's not necessary that both will be like both are 0. You just need to see that both are at same potential. Let's just say this was at V1 potential. Let's just say this was at V1 potential. And this was also at V1 potential only. So then also what will be the current? Gm V1 minus V1. Again the current would be 0. Both are grounded. Then what will be the current? Again will be 0. So if your gate to source potential or source to gate potential is 0, then there will be no current in the MOS. And if there is no current in the MOS, that means MOS can be replaced with open circuit. So how much resistance you see? Only R0. So what will be the answer of Rx? That is R0 only. Or what you can see? That sir, Ix is flowing, but the Ix will be flowing only into R0 only. So what is Vx? Vx is equals to Ix into R0. So what is your Rx now? That is equals to R0 only. But in the examination, what I will do? I will just see the circuit. I will say that sir, Vin is grounded, this is grounded, grounded, 0 current, Rx is directly R0. Believe me, when you revise all these notes, then you by just looking at the circuit, you will be telling the answer. Here I am taking like 5 minutes, 6 minutes to solve one particular circuit. But in the examination, it will not take you time. That I can guarantee. Okay. Solve this question. Vx is the small signal voltage. Vx is small signal. And VDD is DC. This is given in the examination. Solve this question on your own. I need the answer. What will be the value of Rx? Vx will be grounded. What will happen? VDD is grounded. Vx is grounded. From here I need to calculate. So from here to ground, what I will see? R0 only. So what will be the resistance? This potential is gone, this potential is gone, and these two decide the current in MOS. So if I write down the current in downward direction, what that would be? Gm into 0 minus 0. So current in MOS is 0. So there is no current in the MOS. So from this node to ground, what do you see? Rx. What do you see? Rs is equals to R0 only. From this node to ground, Rx is equals to R0. There you go. Okay. Well and good. Let's go to the next one. R0 is infinity. You need to find V0 by Vin. R0 is infinity given. Okay. R0 is infinity. This is given. You need to find V0 by Vin. Try doing it. Use your brain. Whatever the brain you are having, use your complete brain. And let's see if you are able to answer that or not. V0 by Vin, small signal voltage gain you need to find. So what will be the first step? R0 is infinity. That means it will not come into action. VDD will be gone. This will be your RD. Here this will be Vin. This will be your Rs, and this is your V0, right? Now the thing is, can I write down the current in MOS? Yes, I can write down, but my current will be Gm Vin minus this potential minus this potential. And do I know this potential? No. So what I have to do? I have to assume any potential V here. If you don't know the potential, then you assume it. But my target is what I need. I need to find V0 by Vin. So my target is I want to use all the terms in terms of V0 and Vin only. What I mean to say is that I don't want to introduce another variable. I can introduce it. The current will be this. Then what I'm gonna do? I'm gonna write down the current here. What that would be? The same current will be flowing. Because if this current is Gm Vin minus Vin, the same current will be flowing here as well, here as well. In the complete circuit, there is same current. So this current will also be Gm Vin minus V. Then I can write down V0 potential in terms of Vin, V, Gm and RD. then I will need to eradicate this V. How will I eradicate this V? V by Rs will be equals to minus V naught by Rd. Say yes or no. V by Rs will be equals to minus V naught by Rd. Are you getting this point? Because what is the current in upward direction? V naught by Rd. What is the current in downward direction? V by Rs. So from here I will get the relation, and in that manner I can solve. So this is one way of solving it. Other way could be just don't even introduce this V. Don't even introduce this V. So here all these terms should be gone. So I am not even introducing this V. So what I am doing? One thing I know, that what will be the current in upward direction? That would be V naught by Rd. V naught by Rd. Right? So this V naught by Rd current will be flowing through the MOS as well, and the same current will be flowing through this Rs resistance as well. So this will be the V naught by Rd current. Right? So here what will be the potential? So current will be flowing from downward to upward. So what is the potential you are having? V naught by Rd into Rs minus n. So those who have studied this subject and those who have studied feedback topology, so no matter from wherever you have studied, your educator, your teacher would have always said that this is a voltage sampling circuit. Voltage sampling circuit. Now do you understand why it is voltage sampling? Because your output voltage is being sampled in minus V naught by Rd into Rs term, and that will be mixed with the input. How it will be mixed with the input? Because what is the current? If you are someone who did not study feedback topology and you are not able to understand what I am saying, then you can ignore this part. Our target is to find V naught by V in. But this I am telling only for the students who have studied it. Because this is a very confusing example for a lot of students. They never understand that why there is voltage sampling and why there is voltage mixing. So why there is voltage sampling? Because V naught by Rd, the same current is flowing through Rs as well. So the same current is flowing through Rs as well. So how much is that voltage drop across Rs? That is V naught by Rd into Rs. That means what will be this voltage drop? That will be minus V naught by Rd into Rs. So now what will be the current in MOS in downward direction? The current in MOS will be Gm V in minus this potential. And what is this potential? This potential is this thing. That is equals to V naught by Rd into Rs. Although I want to discuss 10 more things, 10 will be a higher number. Like I can discuss at least 3 to 4 more things about this particular circuit. But I cannot do it because this is not a comprehensive course. In comprehensive course, we study a lot about this particular circuit. But here we are not going to study it. So are you able to understand now? Those who have already studied it. So now what we have done? We have written down the current as well. So what is the current in MOS? That is Gm V in minus this potential, and this potential is equals to minus V naught by Rd into Rs. So this current I have written down. Now the same current will be flowing through this Rd as well, no? The same current in downward direction, the current will be flowing through this Rd as well. And how it will be flowing? From up to down. So this is how it will be giving the drop. So how I can write down my V naught? My V naught will be whatever the current that is flowing. Which current is flowing? This current is flowing. So V naught will be minus sign. Why minus sign? Because voltage drop will be negative here. Right? This current I have written from up to down. So this is the current I am getting. So 0, and this is the negative sign. So negative sign is coming. Minus Gm into Rd into V in plus V naught into Rs divided by Rd. Rs divided by Rd. Are you getting this point? So let me take it a bit upward. So what we are getting? V naught is equals to minus Gm Rd V in minus Gm Rs V naught. So what we are getting? V naught by V in minus Gm Rd upon 1 plus Gm Rs. This is the answer. Have we seen this particular factor? Yes, minus Gm Rd. Where we saw? Here, not here, sorry. Voltage gain we saw now. Minus Gm R naught parallel with R. Or in place of this R naught parallel with R, I could have written Rd as well. So the gain was minus Gm Rd. Now this is the same circuit only. This is the same circuit, but now this Rs is also connected. Now here what did I say? This is a negative feedback and it is a voltage sampling. And in voltage sampling, the gain will be reduced by A upon 1 plus A beta factor. So it is reduced by this particular factor. right? This is just some other topic, like I am getting deviated from the original topic, so let's not do it. Here we are studying only MOS amplifier, we are not studying about feedback topology, but just I wanted to relate the things. If you are someone who has already studied this particular topic, so now you are able to relate. This is how you can get into the depth of analog electronics, but now we are not doing that. We are just writing down what is whatever that is required. So was it easy to find the gain? It was not that tough. Certainly it was not easy, but it was not that tough. Without even writing down any model or anything, we have written down the gain, right? Let's go to the next one. Again I need to write down the gain, but now R naught is also there. But the important point is these resistors are also there in terms of R naught only. So try writing it down. What you can do, what we will do. Simply first I need to tell the current in MOS. How much current is flowing in the MOS. So can I tell the current in MOS? Gm into V in minus something. I don't know this potential, but I want to tell this potential in terms of known voltage only. So what I can do? What I will do first thing, VDD will be gone. VDD will be gone. So what is the current that is flowing through 2R naught? That would be V naught by 2R naught. Say yes or no. That current is V naught by 2R naught. And why I am doing so? Because this V naught by 2R naught current will be going into the MOS. Let's just say this is your V naught by 2R naught current. So this V naught by 2R naught current would be addition of these two current. And this current would be coming from R naught. So R naught was there, that was divided into two parts, and then it became V naught by 2 R naught. From here the current started, this was the I current, then it went into two parts, then again added, and the final current we got. And that final current is V naught by 2 R naught. That means how much this current would have been there? This current would have been already V naught by 2 R naught only. Say yes or no. Are you getting this point? So if that current is V naught by 2 R naught, that means downward current is also V naught by 2 R naught. So if this current is V naught by 2 R naught, that means what will be this drop? This drop will be V naught by 2 R naught into R naught. So what you are getting? Here what you will get? Minus V naught by 2. V naught by 2 R naught into R naught. So here what will be the voltage drop? Minus V naught by 2. Right? And why I found that voltage drop? Because my target was to find the current in MOS. And why I wanted the current in MOS? Because at V naught I can apply nodal. At V naught I can apply nodal. What I can do? From V naught to ground, what is the current? V naught by 2 R naught. From V naught to ground there is current V naught by 2 R naught. Plus from V naught there is another branch, this branch. And in this branch how much current is flowing? V naught minus this potential divided by R naught. So V naught minus this potential, that is minus V naught by 2. So here plus will come divided by R naught. Plus now from V naught to ground, from V naught there is another branch. That means this current also I need to tell. What is that current? From V naught to this, there at V naught you are having three branches. One current is this one, another current is this one, and this is the another current. So three branches will have three different current. V naught by 2 R naught, V naught plus V naught by 2 divided by R naught, and here in the MOS as well there is one current. What is that current? Gm V in plus V naught by 2, and that is equals to 0. Are you getting this point? Is that tough to understand? Like believe me, a lot of students will be treating this question as very tough because they will be making needless model, and if you make the models then it will become very tough. But just if you have written down this equation, everything is there in terms of V naught and Gm, V in, everything. So can you get the value of V naught by V in from here? Very easily you can get the value. So this much easy it is. Just you need to look at the circuit and think about it. And if you are able to do that, then your job is done, right? So here what we will get? V naught by 2 R naught. So yeah, V naught by 2 R naught into R naught. This was minus V naught by 2. So this will be 3 V naught by 2 R naught. So this is 3 by 2 plus 1 by 2. So this will be 1.5 into 0.5. So this will be 2. So 2 V naught by R we are getting. 2 V naught by R plus Gm V naught by 2 is equals to minus Gm V in, right? 2 V naught by R naught. So V naught, what we are getting? 2 by R naught plus Gm by 2 is equals to minus Gm V in. So what is V naught by V in? minus Gm upon 2 R naught is already there. That is 4 plus Gm R naught. So what we are getting? Minus 2 Gm R naught upon Gm R naught plus 4. This is the answer. In the examination, they can give you the value of Gm R naught. Like in the examination, they can say that if Gm R naught is equals to 2, then what will be your V naught by V in? These kind of questions they can ask. So if Gm R naught is equals to 2, then answer would be minus 4 divided by 6. Minus 4 divided by 6, that would be minus 2 by 3. So this will be the answer. Okay. Let me check the calculation because this was a bigger calculation. So I will check the calculation, I will take a break, and then we will move to the next one. So this is the next question. You need to find the V naught by V in. Try doing it on your own. I will take a break, I will check the calculation as well. I will check this calculation as well. You see the circuit, pause the video, try solving it, and then check the answer. And I will also take a break now. Okay. Yeah. So try doing it. Yeah. So the previous question was having all the calculation correct. Now let's start with this one. So V naught by V in I need to find. Okay. So how will I find that? Very easy actually, but R naught is infinity. Okay, R naught is also given infinity. Again, it is very easy. How? What is the current here? Can I write down the current? Yes, I can write down the current. What will be the current? Gm V in minus V naught. Right? Gm V in minus V naught. And the same current is flowing through RS. Gm V in minus V naught. So can I write down V naught in this manner? This is how I can write down V naught. How I can write down? V naught is equals to Gm into RS V in minus V naught. So what I am getting? V naught is equals to Gm RS V in minus Gm RS V naught. So what we are getting? V naught by V in is equals to Gm RS upon 1 plus Gm RS. If Gm RS is pretty large, then it will be nearly equals to 1, right? This gain is nearly equals to 1, but forget about this thing. This is the gain, Gm RS upon 1 plus Gm RS. But why did I take this example? This is a standard circuit. Okay, this is a very standard circuit. This is known as VDD will be grounded, no? So this is known as common drain. So the voltage gain of common drain is nearly equals to 1. Why it is known as common drain? Because your input is applied at gate and you are collecting the output at source. No use of drain. That means drain is grounded. Although drain is not directly grounded, it is connected to RD and then grounded. But input at gate and output at source. At drain you are doing nothing. So this is known as common drain. What was this thing? Input at gate and output at drain. At source there is nothing. So this is common source. Right? Input at gate, output at drain. At source there is nothing. So this is known as common source. What was this? This was also common source. Input, output, common source. And here Rx and all these things we are finding. So yeah. But one very interesting thing we will see. Okay, very interesting thing. This is also a very good method. You can tell the answer from this method as well. But now let's see a very interesting thing. Can I say that from V0 to V in, I see 1 by Gm? Yes. Because from V0 there is only one branch. That is this branch. So I can certainly say that, sir, from V0 to V in, I see 1 by Gm. From V0 to V in, I see 1 by Gm. Say yes or no. And from V0 to ground, what do I see? RS. V0 to V in, I see 1 by Gm. From V0 to ground, I see RS. So this was my V in and this was my V0. V0 by V in I need to find. V0 by V in I need to find. Can I apply the potential division? Yes. What will be V0 by V in? RS upon RS plus 1 by Gm. So what is the answer? Gm RS upon Gm RS plus 1. So this will be my V0 by V in. Gm RS upon 1 plus Gm RS. Right? This is your V0, this is your V in. So from V0 to V in, I see 1 by Gm. From V0 to ground, I see RS. So V0 by V in is simply the potential division you need to do. So again, a very good method. Right? Let's go to the next question. You need to find Rx from here. Try doing it. This is also a very good circuit, very standard circuit. Okay, so try finding Rx. What you will do? This current source, this will be gone, VDD will also be gone. Okay, so what will be your final circuit? So final circuit will be something like this. This is ground, this is R naught, Rx I am saying. So you apply Vx and get Ix out of it. And from source to ground, what do you see? Rs. Okay, what is my target? Rx I need to find, that is Vx by Ix. Now this is the Ix current. Now Ix current will be divided into two parts, and then both combined, Ix current will be divided into two parts, and then both combined will be flowing through this Rs. What will be the value of this current? That I am asking. This will be Ix only. Are you able to understand this point? You should be able to understand this point, because we have seen a lot of circuit like this. Ix is divided into two parts, and then both combined will be again flowing through Rs. So if this is Ix, this will also be Ix. And why I am writing down so? Because I need to name this potential, because I know that this potential is 0, but if I need to write down the current in the MOS, then I need this potential, and I don't want to introduce another variable. So in terms of Ix only, I can write down this term, that will be Ix into Rs. So what will be the current in MOS? What will be your Ix equals to? Ix will be equals to the current in the MOS going downward. What is that current? That current will be Gm into 0 minus Ix into Rs, because I am writing down the current downward. So from 0 to Ix Rs I am going, plus Vx minus Ix Rs upon R naught. Say yes or no? Ix is equals to Gm I naught minus Ix Rs plus what is the current in R naught? Vx minus Ix Rx divided by R naught. The current in R naught is Vx minus Ix Rs divided by R naught. So what you are getting? Okay. So Ix is equals to, so here I am saying Ix plus Gm Rs Ix plus Ix Rs upon R naught is equals to Vx upon R naught, right? So what you are getting from here? Vx by Ix, Vx by Ix, Vx by Ix I need to get. So R naught will be cancelled. So what will be the answer that I am writing down here? So that will be R naught plus Rs plus Gm R naught Rs. This will be the answer. So when I was looking from here to upper side, my answer was R naught plus Rd upon 1 plus Gm R naught. If you remember, R naught plus R, that was R naught plus R upon 1 plus Gm R naught. When I was looking from source, gate was grounded. I was looking from source. Answer was R naught plus R upon 1 plus Gm R naught. If I am looking from the drain, so the answer is R naught plus Rs plus Gm R naught Rs. What is the answer? This is the way you will remember. R naught plus Rs plus Gm R naught Rs. Are you getting this point or not? You are getting two kind of resistance. I have made the circuit here. Okay, forget about this circuit once. Let's see these two results. Have we seen this circuit before? Yes. Looking from the source. What was the answer? R naught plus Rd. R naught plus Rd plus Gm R naught plus 1. Or you can say 1 plus Gm R naught. R naught plus Rd. R naught plus Rd upon 1 plus Gm R naught. This configuration will provide Gm R naught. In that manner you can remember. Looking from the source. This is the resistance. Looking from the source. And looking from the drain. What is the resistance? Looking from the drain. So R naught plus Rs plus Gm R naught Rs. People always get confused that, sir, we will remember these two formula, R naught plus Rd upon 1 plus Gm R naught plus Rs plus Gm R naught Rs. Sir, we will remember this formula, but sir, which one will be for drain, which one will be for source, that we forget. So you can make your own trick. How do I usually, you can remember. So let me tell you a trick. So this is from looking from drain, and this is looking from source. So the resistance from source is coming in two steps, no? Like there is numerator as well, there is denominator as well. Numerator and denominator both are there. But here there is only one line. There is only numerator, there is no denominator. Denominator is 1. So if you are looking from drain, drain means you are drained. Like my battery is drained, my battery is drained, the mobile battery is drained. That means battery is at 0. So if battery is at 0, then battery is not having any energy. You are not having any energy if you are drained. You are looking from drain, that means you are drained. And if you are drained, that means you are not having any energy. And if you are not having any energy, then will you write 2 step or only 1 step? I will write only 1 step. So looking from the drain, I write only 1 step. And looking from the source, you are the source. You are the source of motivation. So your energy is at very high. So looking from the source, what you will write down? 1 step as well, another step as well. That means you will write down 2 steps. This is just a very crude way of remembering the formula. Okay, very crude way of remembering the formula. But you can remember if you want to remember in this manner. Right? R naught plus RD upon 1 plus GM R naught, R naught plus RR plus GM R naught plus RS. R naught plus RS plus GM R naught RS. Okay, these two formulas should be there in your mind. Okay, let me take a break because again I need to take some break because of the headache problem that I have. So I will pause a bit and then I will come back. Yeah, so let's solve this question. Did you try solving this one? This is a very good question. Answer will be the gain will be 0. Why is that so? Let's check that out. So what we need to do, first I will make the model. I will make the small signal model. So that model will be looking something like this. Right, this will be your V in, and here this is your R naught. This is your V naught, and from V naught to ground there is RS. This current source will be gone, VDD will be gone, right? Now what is the current in this MOS? That current is GM V in minus V naught. The current is GM V in minus V naught, right? Now this current will be flowing through this branch here, and that will be flowing through R naught as well. Are you getting this point? Let me make this circuit here. Let me make this circuit here again. This is my R naught. A very important point I am going to explain. And this is my RS. And here this is my V in. And this was my V naught. This was the circuit, right? From upper side current source is gone. So what is the current here? Let's just say the current is I. That is GM V in minus V naught. The current is I. The same current has to flow here as well because this current has no other path. If this current is I, so this current has to flow here as well. Now this current has no other path. This current has to flow here as well. So now from here to here, I current is flowing, right? Now this current has to flow here as well. Why is that so? Because this I current does not have any path. Now you will not say that sir current will be going here. No, V naught will not drive any current. The current will not be going here. This is not a potential. This is not any potential. This is just a node. So this node will not take any current. So this I current has to flow here as well. So now at this node, what do you see? At this particular node, what do you see? From upper side, I current is coming, and here I current is going. So what do you think? What is the current going in RS? At this particular node, what do you see? From upper side, I current is coming, and to this side, I current is going. That means this I current is flowing in the complete loop. Are you getting this point or not? This I current is flowing in the complete loop. This is just network analysis, basics of network analysis it is. If you have studied network analysis from PrepFusion, then these kind of points I explain with a good amount of patience there. Because these are very important. Students ignore these kind of points. That's why they get the answer wrong in the examination. So I current is flowing in the loop only. And how did I get to know? I get to know I current is flowing in the loop because if this is I, this is I, this is I, this will also be I. So from here, there will be no current going into this branch. Although this current I has two paths. One path is this one, another path is this one. But when I analyze the circuit, I got to know that this current is also I only. Right? So this I current had two paths, one to go here, one to go here. But in this path only it is completely going. And if it is completely going in this path, that means RS will drive 0 ampere current. So this RS is driving 0 ampere current. And if it is driving 0 ampere current, then what is your V naught? 0 into RS. So what is my V naught? 0 only. So forget about anything. What is your V in? V in will be a finite voltage that you will apply. That will be 0 by anything. That will be equals to 0. That's the answer. Okay, a very good question it was. Previously we skipped one problem here. So what we were seeing these resistances. We got to know that looking from drain only one step, R naught plus Rs plus Gm R naught. Looking from the source, R naught plus Rd upon 1 plus Gm R naught. Now this question, looking from the drain, what is the answer? Forget about the analysis. What will be your Rx? Looking from the drain, what is the answer? Looking from the drain, if gate is grounded and source is connected to some other resistance, the answer is R naught plus Rs plus Gm R naught Rs. Now what I am saying, R naught is infinity. It is giving that, it is saying that R naught is infinity. So if I put infinity plus Gm R naught Rs, that is also infinity. So what is the value of Rx? That is infinity only. Okay, answer is infinity. But let's solve it without any formula. So if I need to solve it without any formula, so what I will do, I will apply a Vx here and get Ix out of it, right? So what will be my Rx? Vx by Ix. So this Ix will be flowing in this MOS only because R naught is 0. So Ix will be completely flowing in the MOS. So this current will also be Ix. Why I am doing so? Because I need the current in MOS. So from upper side Ix is coming, the same current is flowing in this MOS as well. So this current will also be Ix. So what will be this potential? This potential will be Ix into Rs because current is flowing from up to down. So plus to minus. So this potential will be Ix into Rs. Now what will be the current in MOS? The current in MOS will be minus Gm Ix into Rs. Did you understand this point? Or you can write down the current in upward direction as well. You can write down the current in upward direction as well. What will be the current? From Ix Rs to you are going towards 0. So what will be the current? Gm into Ix into Rs. So from here what you are getting to know that Gm into Ix into Rs is coming out to be equals to minus Ix. Say yes or no? Gm into Ix into Rs is coming out to be minus Ix. So from here what you can see, Gm Rs plus 1 is equals into Ix is equals to 0. So from here what you are getting to know that Ix has to be 0. This GMRS is depending upon you. You can make it like, if you solve this circuit, then there are two possibilities, no? That either Ix can go to 0 or GMRS can go to minus 1. But RS is something, any random RS I am putting, and any like GM is depending on the biasing parameter, but it's not necessary that always it will be equals to minus 1. It can be equals to anything. So that means certainly Ix has to be 0. So if Ix is 0, so what you will get? Vx by 0. That is equals to infinity. So in the examination, if I am the educator, if I am the paper setter, although I will never be, so I will ask this circuit because I know that those who have studied it, they already remember this formula. They already, like a lot of students already remember this formula, R naught plus Rs plus Gm R naught Rs, but they don't remember this one, right? They will see the circuit and they will try solving it by any model or anything like that, and then they will be getting puzzled. So in these kind of scenario, if your equation is becoming strange, then no need to worry. Strange equation can also come. Okay. So have the patience. You got to know that Ix is equals to 0 and then Rx is equals to infinity. Or how you could have solved it. I know that looking from the drain, if my gate is shorted and source is connected to Rs resistance, then my answer is R naught plus Rs. I am looking from drain. That means I am drained. My battery is drained. That means I will write down only one step, R naught plus Rs into Gm R naught Rs. And if R naught is infinity, if R naught is equals to infinity, so infinity plus Rs plus infinity. So what will be your Rx? Rx will be infinity only. Okay, so this will be the answer. Well and good. This also we have solved. Let's go to this one. What you need to find, considering R naught is not equals to infinity, you let me know what will be your Rin. And then considering R naught equals to infinity, you let me know what will be your gain. Okay, these two questions are there. So Vin is here, V naught is here, you need to find Rin. So first let's find Rin. Do I have the page? Because it will take 2 pages. So first let's find Rin. So how will I find Rin? So for Rin, what did I tell you? All kind of biasing will be gone. Whether it is small signal bias or, by small signal we cannot call it bias. So whether it is a small signal or it is a large signal, everything will be gone. So VDD will be shorted, Vx will be shorted. Let's make it on the next page only. Okay, yeah, let's do it on the next page. So there VDD will be shorted, VX will also be shorted. So this was the circuit. This is also gone. This is also gone. This is gone. This is also gone. Okay. Then downward I see V in. And then at the ground I see RS, and this is my V naught. So this is the small signal circuit at least. But if I am finding R in, that means I will nullify V in as well. There are two questions. In the first question, you need to find R in. So if I am finding R in, then this V in will also be nullified. V in will also be nullified. And here there is R naught. Upper side we are calling M2, downward I am calling M1. So this will be your R naught 1, and upper side you are having R naught 2. What did I tell you? From where you need to find R in? From where I need to find R in? Okay, let's change this circuit once. Okay, I am changing the question. I am asking you the R in from here now. From here, where I am asking? I am asking the R in from V naught side. From V naught side I am asking the R in. From V naught side I am asking the R in. Now what do I know? That from V naught to ground I see RS. From V naught to ground I see RS, and from V naught to ground I see this another circuit. Say yes or no? From, or what you can say, sir, from V naught to ground I see RS. From V naught to ground I see 1 by GM as well. But from V naught only I see another circuit. If both were connected, then I could have said that from V naught to gate and from V naught to drain I see 1 by GM parallel with R naught. But now both are not connected. Now first my target should be, if I am finding the R in from here, I should start from the upper side. So I need to solve this circuit. What do you think how this circuit can be solved? And from where I will write down the resistance from downward side? Because I will start solving from the upper side. Like first I will get the resistance of this part, then this part, then this part, looking from downward. So looking from downward, how I can replace this circuit? Think about it and let me know. What will be the current in MOS? Source is 0, gate is 0. Current in MOS will be GM 0 minus 0. VSG is gone. Source potential and gate potential both are 0. That means current in the MOS is 0. So this MOS can be replaced with open circuit. These are considered as a very tough problem in the examination. Believe me guys, these are considered very tough problem. But if you know the concept, whatever that I have taught you in the first initial 20 minutes, then you will be able to solve all the problems. VSG is gone. Then how you will replace R naught? Sorry, how you will replace the complete configuration? Only R naught is left, no? From this particular node to ground, only R naught is left. Say yes or no? Now, coming to this part. This is my, this was R naught 2 actually. This was R naught 2. This is R naught 1. And this is my RS. So this is how I have replaced the circuit. Now from here I need to tell the resistance. So now I need to replace this circuit because I know that from V0 to ground I see RS. From V0 to ground I see RS. From V0 to ground I see 1 by GM as well, but gate and drain are not shorted to each other. That means from source side I am looking. From source side I need to write down the resistance. Drain and gate are not shorted to each other, and drain is connected to another resistance. Have we seen this kind of circuit before? Yes, not here, sorry. From source I need to tell the resistance. Gate is grounded, drain is connected to RD, and then there is a R0. And drain and gate both are not shorted to each other. Here we have seen, previously also we have seen, and I wrote down the conclusion as well. Three kind of circuit we see. From source we are seeing the resistance, gate is grounded, drain is connected to R resistance, and it is connected to R0. And in between there is R0. If there was no R0, then answer would have been 1 by GM. If there is R0, then answer is different. And if both are shorted, then answer would have been different. Say yes or no. We have seen it, right? So same circuit, same kind of circuit we are seeing here as well. Looking from upwards, from source we are seeing R02 is there, R01 G, and this gate is shorted as well. So looking from upward, how much resistance you will see? I am looking from the source. I am the source of motivation. That means I will write down two steps. How I will write down? R01 plus R02 divided by 1 plus GM R01. GM1 R01. R02 plus R01 divided by 1 plus GM1 R01. So upper side you see this much resistance. Now your circuit is solved. How your circuit is solved? That from V0 to ground, you see R01 plus R02 divided by 1 plus GM1 R01. And from V0 to ground, you see RS as well. So looking from V0, how much total resistance you see? RX or Rin, whatever it is. So they are in parallel or they are in series. What you will say? From V0 I need to check, no? From where I need to check? From V0 I need to check. So what I will say? From V0 to ground. From V0 to ground I get any R1 resistance. And from V0 to ground I get another R2 resistance. So answer will be R1 parallel with R2. So from V0 to ground I get this resistance, and from V0 to ground I get RS resistance as well. So what will be the answer? What will be the value of Rin? So value of Rin will be from V0 to ground, that would be R01 plus R02 divided by 1 plus GM1 R01, that is in parallel with RS. That will be your Rin or RX, whatever we can call it. They are calling it Rin, although this is not Rin because this is the applied input, no? So I should have called it RX. Okay. So this is not Rin, this is your RX. So what is my RX? Are you getting this point? How I am doing these kind of questions. So no matter how big the circuit will look like, you can any day solve any problem. Just have confidence on yourself. Just keep on writing on the steps that you know. If you are able to do this thing, at least you will be able to match the option. That I can tell you. At least in the examination, if options are given, then at least you will be able to match the options. Believe me guys, if you have just gone through this video. VGS is gone, R0, R02 is replaced, R02 is replaced, then looking from downward, I have seen this circuit. What is this circuit? R0 plus R0 plus R02 divided by 1 plus GM R01, and RS will also come in parallel. That's the answer. Okay. Let's see the circuit now from where these capacitors came into action. So I just deliberately introduced these capacitors. The point is, when you do the small signal analysis, the capacitor will be shorted. Capacitor will be short circuited. When you do the small signal analysis, capacitor will be short circuited, and VDD will already be gone. And what I do here is that I apply, okay, let it be grounded only. Let it be grounded only. Okay. So VDD will be gone. What will happen to capacitors? Capacitors will be open circuited. These are known as coupling capacitor. Why do we use it? All these things we study in comprehensive course. So you don't need to study, you don't need to think anything about it. Just you need to know that capacitors will be shorted. So capacitor is shorted. This is RD. This is our RS. And this is our V. So what kind of circuit it is? What do you think? You will call it common gate, common source or common drain. Common gate, common source or common drain. What is your answer? Input is applied at source and output we are collecting at drain. Gate is of no use here. So common gate circuit it is. Okay. What we need to find? V0 by V in we need to find. And any other condition is given. Shall we consider R0 here? Yeah, okay. We can consider R0, it will not be that tough. So we can consider R0 as well. If we don't consider R0, then it will be very easy. But let's consider R0 as well. Let's make it on the tougher side. Okay. So what we need to find? V0 by V in we need to find. Small signal circuit I have already made. Try doing it. If this is my V in, what will be the current in MOS? Why I need the current in MOS? Because I will apply nodal at V0. I will apply nodal at V0. What will be the nodal at V0? V0 by RD plus V0 by V in minus R0. Sorry, V0 minus V in divided by R0 plus the current in MOS. What is the current in MOS? V0 by RD plus this current, and you need this current now. Downward current, no? From V0 to downward side and upward side. So V0 minus V in by R0, V0 by RD plus or minus plus what will be the current? The current will be minus GMV in. This is your MOS, right? This is shorted and this is your V in. So what will be the current in upward direction? GM V in. So in the downward direction, the current will be minus GM V in. Or you can say, if I need to write down the current in downward direction, so GM into 0 minus V in, that would be minus GM V in. So current will be minus GM V in. So I am applying the nodal analysis. So plus minus GM V in is equals to 0. So this is what we are getting. So V naught upon RD plus V naught by R naught is equals to GM R naught. GM V in goes here, 1 by R naught goes here. So let's do something. GM plus 1 by R naught into V in. So yeah, so what I can do, can I write down in this manner? V naught divided by RD parallel with R naught. Did you understand this step? V naught divided by RD parallel with R naught. You should be able to understand. Try relating it. If you are not able to understand directly, then spend your time, because this I have already taught. 1 by R is equals to 1 by R1 plus 1 by R2. Same thing is happening here. Try understanding it. Try understanding it on your own. Okay? Or shall I explain it? Basically, what is this? V naught into 1 by RD plus 1 by R naught. And what this is what this can be equivalent to? 1 by R equivalent. So what is your R equivalent? RD parallel with R naught only. So V naught by RD parallel with R naught. Right? That is equals to, although this is of no use actually, GM R naught upon GM R naught plus 1 into V in. So what is the V naught by V in we are getting? GM R naught plus 1 upon R naught into RD parallel with R naught. Anyway, I need to solve it. RD plus R naught. So R naught is getting cancelled. So what we are getting? RD upon RD plus R naught into 1 plus GM R naught. Okay. This is your V naught by V in. Say yes or no. What if the R naught was infinity? Then what will be the answer? GMRD only. Right? If R naught was infinity, then what would have been the answer? GMRD, or another answer will be possible? No, GMRD only. V naught by RD if I say, and V in by RS if I. Look, let's take R naught equals to infinity. Okay. What we are saying, let me add a page, and what I am saying, the same circuit R naught is equals to infinity. The same circuit R naught is equals to infinity. Small signal model, I know. This will be my V naught. This is my V in. Okay. So what will be the current in upward direction? That would be GMV. This VDD will be gone, that will be shorted. Right. So what is the what this GMV in will be flowing here as well, because R naught is infinity. So V naught is equals to, since the current is flowing in the upward direction, so this will be positive, this will be negative. So V naught is equals to GMRD into V in. So what is the gain? V naught by V in is equals to GMRD. Okay. This is the gain. But just one thing clicked to me. What is that? What is the current in downward direction? V in by RS, right? And what is the current in upward direction? V naught by RD. Am I doing anything wrong here? V in by RS is the current in downward direction. V naught by RD is the current in upward direction. Say yes or no. Is there any issue about that? No. And both current will be equal. What say? What is the issue with this one then? Why both current will be equal? Because if this is the current, then this will be divided into two parts. This will be added back, and then if both are added back, then the same current will be flowing here. Are you getting this point? In the downward direction, V in by RS current is there, and in the upward direction, V naught by RD current is there. Both has to be equal. So another answer we are getting, no? V naught by V in. So that V naught by V in is depending on RS and RD. Are you getting this point? What I'm saying? What I'm saying is that whatever the current, if I take this circuit only, R naught is finite. What I'm saying, R naught is finite. If I say here there is I current, the same current will be flowing here as well, no? In RS as well. Say yes or no? So V naught by RD will be equals to minus V in by RS. Even if R naught is not equals to infinity, then also it is true, no? V naught by RD is equals to minus V in by RS. So what is the other value of the gain? Minus RD by RS. But am I doing anything wrong here? Minus RD by RS, because this is the first time this is occurring to me. I never thought of it. Okay. Just when I'm teaching it, it came to my mind. Although there is a question in GATE examination based on this concept only. So this analysis is not wrong. There is nothing wrong with the small signal analysis. But if I see as an engineer, so this gain is independent of anything. Like it is not even depending on any circuit parameter. It is not even depending on GM or not. It is not depending on anything. It is just depending on two resistors that user is connecting, RD and RS, or it is coming from any other stage. So how this common gate circuit is helpful then? It is independent of GM value. Okay, I will think about it, but for this video, like even for your examination, it is fine that you know how to write down the gain. So this is the one way of writing down the gain, but another answer is possible, that is minus RD by RS. Am I doing any mistake in this analysis? I don't think I am doing any mistake. If I am not doing any mistake, then certainly even if the R naught is finite, still this answer is possible, minus RD by RS. Even if it is finite or infinite, still this answer will be minus RD by RS. So this is a common gate structure and this is the voltage gain of a common gate. So common voltage gain of common gate is independent of GM. Common gate voltage gain of common gate is independent of any circuit parameters. Is that statement correct? Looking at the expression, this statement is correct, but usually we don't see this statement, right? Usually we don't get to see this statement. It is not even written down in any textbook as well. I just saw it and I got to know. I will think more about it. Okay, I will think more about it. And another interesting thing, what is that? Usually here there is no phase shift, right? Basically V0 and Vin both are in same phase. But if you go by this expression, then V0 by Vin are having different phases. I am certainly doing something wrong. I don't know, but I am certainly doing something wrong. If you go by this expression, what you can say? That V0 and Vin both are having a phase difference, no? Like both are having a phase difference of 180 degree. Because there is minus sign. Basically V0 is equals to minus RD by RS into Vin. So V0 and Vin both are having a phase difference of 180 degree. Right? But usually we say that there is no phase difference. In common gate amplifier, there is no phase difference, but here I am getting it. Am I missing anything? Okay, that's a very good point that came to me. So I will ask someone, like someone who is working in this field for a very long time. So I will ask some other people. Okay, very good point that came to my mind. Okay, I will post it on LinkedIn, I guess. Then only I will get some answer. Okay, yeah, fine. So it just occurred to me. Otherwise, always when we study, we write down this gain and it is fine for us. But just when I was thinking that I current is flowing here, I current would be flowing here as well, then it just came to my mind that why we cannot write down the gain in this manner. What is the issue behind that? So I will put this query on LinkedIn, and I guess I am doing some mistake. I am not sure what mistake I am doing, but that will be taken care. Okay, yeah, no issue. Let's move to the next one. Now this question, it may feel like that it is a very big circuit, how we will write down the gain. But what did I tell you? Capacitors will be shorted and supply will be gone. VDD will be gone, capacitors will be shorted. So capacitor is shorted. So let's see how I will make the circuit. So VDD is gone. This VDD is gone. This is your RD. This is your V naught. Now this RS is there. This RS is there. It is connected to ground, but the capacitor is shorted. So this complete RS is also shorted, no? RS is connected to ground, but capacitor is also shorted. So complete RS is also shorted. So can I ignore this RS? So RS is not open circuited here. RS is shorted because this capacitor was shorted, right? So this will be shorted. Now this thing is running into my mind as of now, that what really happened here. 2R by 3 resistance. This capacitor is also shorted, no? This capacitor will also be shorted. Now from this node to ground there is a resistance R. From this particular node to ground there is a resistance R. And from this particular node to ground there is a resistance 2R as well. From this node to ground there is a resistance R. From this node to ground there is a resistance 2R as well. So from this node to ground R is there, 2R is there. So can I say both will come into parallel? So 2R and R will come into parallel. Say yes or no. I can remove this thing and 2R and R will come in parallel. Because from here to ground there was R, from here to ground there is R. So 2R and R will come into parallel. So what will be the answer? 2R by 3. Parallel combination of 2R into R divided by 2R plus R. 2R by 3. Right? And now this is my Vs. This is my Vs. What I need, and R naught is also finite. So from V naught to ground as well I will see R naught. From V naught to source I will see the R naught. From V naught, from here to here I will see R naught. From here to here I will see R naught. Right? This will be my R naught. But since this node is connected to ground, so can I say directly it is connected to ground only? Right? So what I am saying here, this is my Vs. I need the potential here. If I need to write down the current in MOS, that means I need the potential here. So 2R parallel with R, 2R by 3. This is also 2R by 3. Basically, equivalent circuit is 2R by 3. This is also 2R by 3. Then this is the MOS. This node is connected to ground. This is your V naught. So from V naught to ground you see RD. From V naught to ground you see R naught as well. So from V naught to ground you see RD. From V naught to ground you see R naught as well. And this is your Vs. This is 2R by 3. And this is also 2R by 3. So how much potential we are getting here? This will drive 0 ampere current. So can I apply potential division? Yes. 2R by 3 resistance, 2R by 3 resistance. This is driving 0 ampere current. So can I apply the potential division? Yes, I can apply. Basically, if this is my R resistance, this is my R resistance. And here I apply V in, V1. So what will be the potential here? V1 by 2. Same thing we are doing here. 2R by 3, 2R by 3. So what will be the potential here? Vs by 2. The potential here will be Vs by 2. So what will be the current in this MOS? The current in this MOS will be Gm Vs by 2. Or you can say, sir, this is simply common source amplifier and I remember the resistance Gm into Rd. Basically, whatever the resistance that V0 will see, Rd parallel with R0 and then multiply with, forget about it, don't remember anything. Okay, forget about this particular expression. Even if you have forget it, then also you will be able to solve. So if this is Vs by 2, so what will be the current in this MOS? Gm Vs by 2. Now this Gm Vs by 2 has only one path to follow. What I am saying, this current is Gm Vs by 2. This current is Gm Vs by 2. So that will flow from here and the same current will be flowing through the Rd as well. This current has only one path. So in Rd parallel with R0, Gm Vs by 2 current is flowing. So what will be your V0? In which direction the current is flowing? The current is flowing like this. So this will be plus, this will be minus. So V0 is equals to Gm Vs by 2 current is flowing. Gm Vs by 2 current is flowing. But the potential is negative into Rd parallel with R0. So what will be your V0 by Vs? That is equals to minus Gm Rd parallel with R0 divided by 2. So that is the final gain. Okay. It was actually very easy in the examination. You will not even have to draw the circuit. What you will see, sir, 2R will come in parallel. This will be 2R by 3. This will be Vs by 2. This is also grounded. This is also grounded. So Gm Vs by 2, R0 parallel with Rd is there. R0 parallel with Rd is there. So Gm Vs by 2, R0 parallel with Rd. So Gm by 2, Rd parallel with R0. So this will be the gain. Very easily you will be able to write down. Till this step you will be reaching very easily. Or one thing what I'm gonna tell is that you can remember this final expression. Which final expression you can remember? This expression at least you can remember. That if this is your MOS, here you are applying V in, and from V node to ground, whatever the resistance you see, this is your R resistance. From V node to ground, whatever the resistance you see, from here V node by V in is equals to minus GMR. That's it. And it is very easy to drive. This current is GMV in. The same current is flowing through this resistance R as well. This has to flow in this manner. So what will be your V naught? Minus GMR into V in. From here we are getting this expression. So you at least remember this one. This is known as voltage gain of common source amplifier. That is minus GM into R. Okay. Try solving this question. You need to tell R in value. What you need to tell? You need to tell the value of R in. Next, what we are doing? Okay, then this question we are solving, and then we are moving to PYQs. Okay, so solve for the value of R in. Mic वगैरह लगाया ना. Here what we are using, PMOSes we are using. Usually what we use NMOS. So even if the PMOS is coming, you should not be getting confused, right? So VX1 will be shorted, VDD will be shorted. Look, directly let me know now. VX1 is shorted, VDD is shorted. From here what we are seeing, there is already R0 is there, right? This is gone, VX1 is gone, VDD is gone. VSG is gone. Source potential is 0, gate potential is 0. That means MOS can be replaced with open circuit now. There will be no current in the MOS because the current in the MOS will be 0. GM 0 minus 0. So current will be 0. So from here to ground, how much resistance do you see? R0. From this particular node to ground, you see R0 resistance. Then there is a source. Vx is grounded. Let's just call it R02. Okay, let's call it R02. So this will be my R01. And from here I need to tell R in. One thing what you can do, you can do the same thing. I apply V in, get I in out of it, because this is not any standard circuit. You don't remember the result, right? You apply V in, get I in out of it, you can write down the value of R in now. Okay, what you can do, this will be I in, then the same I in will be flowing through this I in as well. Then what you will get to know, this potential. If you know this potential, then at V in you can apply nodal. Basically, I in will be equal to the current in this MOS. Current in this MOS will be coming because you will know this potential. What will be this potential? This potential will be equal to I in into R02. So current in the MOS will be from this particular potential. You can write down the current in downward direction, or if you need the current in upward direction, that also you can write down. And you can write down the current in R0 as well, because you know this potential, as well. So current in R0 also you can write, and that will be equated to I in. From there you will get the answer. Okay, but have we done these kind of steps anywhere? Like in the examination, let's just say it did not click anything to you, you will do this step only. In the examination, if nothing is clicking to you, you will start doing this step. Then you will remember that we have done these kind of steps somewhere. Where we have done? Can I make the circuit? Can I make the same circuit using NMOS as well? This was PMOS. Can I make the same circuit using NMOS? Yes, I can make the same circuit using NMOS. What I will do, I need to make NMOS. Okay, I am making NMOS. Gate is grounded, gate is grounded. Between these two, R0 is connected, R0 is connected. From where I am looking? From drain I am looking. That means from drain I am looking. Source is connected to R02. Source is connected to R02, and that is connected to ground. Source is connected to R02, that is connected to ground. What kind of circuit is that? Do you remember the result? Yes. What is your R in? From drain I am looking, gate is shorted. From drain I am looking, gate is shorted. Source is connected to R02. From drain I am looking, that means my battery is drained now. So what will be my R in? From drain I am looking, that means my battery is drained. Battery is drained, that means only one step I will write down. R01 plus R02 plus GM1 R01. GM1 R01 R02. This is the answer. Have we seen this circuit anywhere or not? So if your circuit is reduced to only one circuit, if your final circuit is reduced to only one circuit, and that is PMOS, So what you can do, you can make the same equivalent circuit of NMOS, and then you will be able to understand that what is happening here. If you are not able to solve with respect to PMOS, because you will not be having enough practice with PMOS, right? Because you are just watching this video, and that will be the final video you are going to watch on MOS amplifier. So you will not have enough practice. And if you are not having enough practice, and then you get puzzled that what should be the answer, then what you can do, you can make the NMOS circuit, and from there you will get the answer. Are you getting this point? Are you getting this point? Where we have seen this circuit? Here we have seen this circuit. These two answers we have seen. Looking from the drain, looking from the source. What all are the resistance? Okay. Now usually what happens is that, usually in the examination as well, you can get this option. R01, R02, and this GM R01, R02. So this quantity is very, very larger than R01 and R02. What I am saying, GM1, R01, R02 is very, very larger than R01 and R02. So sometimes Rin approximately can be replaced with GM1, R01 and R02. Okay. This could be the approximated answer. Approximately. But you should remember the exact answer as well. Okay. You should remember the exact answer as well. R01 plus R02 plus GM1, R01, R02. Let's solve this question. What we need to find? R0. From V0 I need to find. So what I will get started with? This thing, this thing, this thing, this thing I need to solve. So from where I need to start? From here I need to start. So first I need to get equivalent of this one. Then I need to get equivalent of this one as well. Right? So from here I am looking. So I need to solve downward as well now, upward as well now. So first let's solve the upper circuit. What will happen? This Vx1 will be shorted, VDD will be shorted. This is shorted, this is shorted. So VSG is gone. Source, gate potential, both are gone. 0 minus 0. That means there will be no current in the MOS, but there is R0 connected. R0 4 is there. Right? R0 4 is connected there. So what will happen now? The upper part can be replaced with R0 4. So in my circuit, the upper part, this part can be replaced with R0 4, and this is connected to ground. Okay. Here what is there? R0 3 is there. I am solving only the upper part. Only upper part. Can you let me know the answer of this thing? What will be the resistance here? Same circuit. Same circuit. If you are not able to click, then what you will do? Grounded, R0 4, R0 3. From where I am looking? From drain I am looking. What is the answer? From here you will be able to understand. Okay, this is a standard circuit. I remember the result. From drain I am looking. That means my battery is drained. So this much circuitry can be replaced with R0 3 plus R0 4 plus GM3 R0 3, GM3 R0 3, R0 4. Say yes or no. GM3 R0 3 into R0 4. So upper circuitry can be replaced with this much of a final answer. Okay. Now let's see the downward circuitry. What I am saying, the downward circuitry. Because from V0 to ground I need to see. From V0 to ground I see this much circuit. From V0 to ground I see this much circuit. So let's see how the lower circuitry can be replaced with. So Vin is the small signal bias, small signal applied input voltage. So this will also be shorted. And from here to ground, or you can see from drain to source, what do I see? R01, which is connected to ground only. Here, what will be the current in MOS? Zero current. VGS will be 0. Gate to source potential will be 0. Or you can say GM 0 minus 0. Current will be 0 only. So this much circuitry can be replaced only with R01. So what do you see downward? This much circuitry can only be replaced with R01. And this Vx3 is shorted. Okay. And in M2, what do you see here? You see R02 here. And here I see another resistance. Can you let me know what will be the value of this one? From V0 node I am seeing. Can you let me know what will be the value of this one? From drain I am looking, gate is grounded, from source there is a resistance. Very standard circuit. R02 plus R01 plus GM2, R02, R01. So what did you understand here? From V0 to ground on the upper side, from V0 to ground on the upper side, I see one resistance. Let's just call this resistance as R1, this resistance as R2. So from V0 to ground, I see R1. From V0 to ground, I see R2 as well. V0 to ground there is R1, V0 to ground there is R2. What will be your R out? R out will be equals to R1 parallel with R2. R1 parallel with R2. What is the value of R1? This is the value of R2. This is the value of R1. 99% of the gate aspirant will fail here. They will not be able to answer this question. They will say this is very tough. Is it tough? If you know the concept, if you have enough problem solving skills, these are not tough. This is a standard circuit as well. This is known as cascade amplifier with cascade current source in load. Usually when I teach this particular topic in comprehensive course, so I start right from the beginning that why we make this kind of amplifier. Here all the configuration that we have seen, no, like all these configuration, they have a reason that why we make this kind of circuit, why we use this current source, how we will use this current source, how we will make this current source, what is the reason behind that. All these things have been explained in the comprehensive course, but that we cannot do here because your examination is there after 12 days. So I need to teach in a very concise manner. So this is something new that I am trying, that I will try to deliver the complete concept within 2 to 3 hours, and I will see whether students are able to understand and students are able to solve the problems or not. So now we will see the gate problems, but not all the gate problems. Okay, only good gate problems we are going to see. Rest simple gate problems you can solve on your own. Only good gate problems I have picked, those problems only we are going to see now. So I guess on MOS amplifiers you will be able to solve decent problem. Like if two problems are coming, then at least one question you will be able to solve. So read this question, and in the examination if you read it, what you need to see from there. Consider the circuit shown with an ideal long channel NMOS enhancement mode. Substrate is connected to the source. So you don't know what they are talking about here. Substrate is connected to source, so you can ignore this line. The transistor is appropriately biased in saturation region with VGG and VDD. That also you don't know, but you got to know that it is biased. That means biasing we have done, appropriately biasing we have done, such that it acts as a linear amplifier. Vin is the small signal AC input. This is a small signal AC input that they have given. VB is VA and VB are represented as small signal voltage at the nodes A and B. Find the value of VA by VB. This is what they are saying. VA by VB you need to find. Vin is a small signal voltage, but that is of no use now. Are you getting this point? Just look at this circuit, what you will think. That even if there is R0, they do not talk about R0 at all. Let's just say even if there is R0, even if there is R0 present, what will happen? Whatever the small signal current is there, let's just say the small signal current is I. The same current I will be flowing here as well. Right? This node is your VA and this node is your VB. What will be your VA? VA will be equals to 4 kilo ohm into minus I. Why minus I? Because this drop will be from up to down, right? So VA will be equals to minus 4 kilo ohm into minus I. 4 kilo ohm into minus I. And what will be VB? VB will be equals to 2 kilo ohm into I. So VA by VB equals to minus 2. This is your VA by VB. So that's the answer. Answer is minus 2. Very simple. Yes or no? This question is straight from Rajavi. Unsolved example of chapter 3 Rajavi. Last question you will see. This is straight from there. VA by VB equals to minus 2. And because of this concept only, now I have got this doubt. Which doubt? Where was our doubt? That gain thing. Here. This is the gain, but V0 by Vin. Now what do I see? That it is equal to minus RD by RS as well. So what is the issue behind that? So I will post it on LinkedIn. We'll see what we can see. Okay. Now this circuitry you haven't seen. What is this circuit, sir? Again, find the gain, whatever they are asking. VD is the small signal input voltage. This time they did not show it by Vin. They are showing by VD. So what you need to find? V0 by VD you need to find. Options are also given. You need to find V0 by VD. Sir, I can do this, but what this is, what this circuit is there. So this is your NMOS only. So I was going to tell you another thing, which is this thing. So how I represented NMOS? This is how I represented NMOS. This is how I represented PMOS. There is another way of showing it. What is the other way? Although here there will be dashed line. So the way would be, they will make a dashed line here. In that manner, they will make dashed line like this. Yeah, just see here how they have made it. This is not actually usually famous. Dashed line there and then one there. Okay. So this is how they will make it. 3 dashed line are there, and this is full line. Okay, same goes for this circuit as well. They will do the same thing. They will do the same thing here as well. So I'm copying the same thing here as well. Okay, then they will make one line here, one line here. Now they will connect this particular line to source. They will connect this particular line. Where is source in NMOS? Sorry, where is source in PMOS? Upper side. They will connect this particular line to source. They will connect this particular line to source. This is known as body actually. What this is known as body. All these things you know, drain, gate, source. This is known as body. This is body. Okay, this is body. They will connect that. Now the sign of arrow. So the sign of arrow, here it was outward, no. In this one it will be inward. Here this was inward, so here it will be outward. So this will be the sign of arrow. Are you getting this point? Are you getting this structure? Can you remember this thing? Very easy. Like a different kind of structure is there. That means inward arrow will be NMOS, otherwise it will be PMOS. So what is this? What is this? This is your NMOS only. This is your NMOS only, right? So can I make the circuit again? Yes. Let's start doing it. So this is my VD that they have given. This is your R0. This is your V0. Then there is a NMOS circuitry is there. This is connected to ground. This is your R0. And here, this is R0. R0 is, this is connected to ground. This is VD. This is VD here. This is your V0. What do I need? I need the ratio of V0 by VD. This was asked in GATE 2022, which was my shift as well. Okay. And believe me, no one gave the answer of this question. When it came, no one gave the answer of this question. Later on, after some days, the answer was given. And I also posted the answer of this question. I don't know why. It is very simple. Just let me know one thing. Because they were solving it with models. And if you solve by models, it can take you some time. So if this is your V0 and this is your R0, this is your R0. How much current this will drive? 0 ampere current. Basically, this node is V0. This node is V0. Then there is R0. Then there is R0. And then there is a MOS, which is driving 0 ampere current. R0, R0, which is driving 0 ampere current. So what will be the voltage here? What will be the voltage here? V0 by 2. Because it is driving 0 ampere current, so you can divide the potential, no? I can do the potential division. If I have done the potential division, they have considered R0 to be infinity, right? Small R0 is infinity. A small signal low frequency VD voltage is supplied if channel length modulation of the MOSFET is ignored. So what line you can see? Channel length modulation of the MOSFET is ignored. What does that mean? R0 is equals to infinity. So R0 is not there. So basically what will be this potential? This will be V0 by 2. So this potential is V0 by 2. Can you write down the current in MOS? Yes. What will be the current in MOS? GM V0 by 2. We are only picking good question. Okay. Basic question you will be able to solve. At least if you are able to solve this one as well, then you don't need to worry about anything. You will be able to solve good problems in the examination. So what will be the current? GM V0 by 2. If this is V0, this will be V0 by 2. So current will be GM V0 by 2. What will be the current in this R0? The current in this R0 will be, this is your V0, this is your V0 by 2. So the current in this R0 will be V0 by 2 R0. This is your V0, this is your V0 by 2. So the current in R0 will be V0 by 2 R0. You know, will this VDD will be shorted? No. This VD is, now this VD is small signal bias. Again, I am saying the word bias. We cannot use the word bias for small signal. What they are saying, a small signal low frequency voltage VD is injected at the supply terminal. Here, a small signal VD is there. Okay. A small signal VD is present. So this is a small signal. You cannot short circuit it. So small signal VD will be there. The small signal VD will already be there. This is your V0, this will be your V0 by 2. So current is GM V0 by 2. So at the V0, can I apply the nodal? Yes. What will be the nodal? V0 by VD upon R0 plus in this direction V0 by 2 R0 plus GM V0 by 2 is equals to 0. Very easy it was. V0 by 2, GM V0 by 2. This is your V0. Here in the R0, how much current will be flowing? Basically from V0, how much branch I can see? This R0, MOSFET and this upper branch. In the upper branch, how much current is going? V0 by VD upon R0. In downward, how much current is going? GM V0 by 2. Here, how much current is going? V0 by 2 upon R0. V0 by 2 R0. V0 by 2 R0. That's it. What is V0? 3 V0 by 2 R0 plus GM V0 is equals to VD by R0. Right? So what we are getting? 3 V0 plus 2 GM R0 into V0 is equals to 2 VD. Okay, VD by R, V0 by R0, 3 by 2 V0 R0, VD by R0 plus GM. Yeah. So what we are getting? V0 by VD. V0 by VD is 2 upon 3 plus 2 GM R0. Whatever we are getting, okay, this is the answer. Well and good. Or what was given in the examination, as far as I remember, they took this 3 down. So what answer they gave? V0 by VD they gave as 3 by 2 plus GM R0 inverse. This answer they gave actually. This 2 goes downward, so 3 by 2 plus GM R0 inverse. This was the answer given. As far as I remember, I hope there is no calculation mistake. V0 by 2, V0 by RD upon R0, GM V0. Okay. There is a calculation mistake. GM V0 by 2. Okay. GM V0 by 2. Actually, I am really tired. That's why this error are happening. So what will happen here? 2 R0 will be common. Then here this 2 will not come. Two upon 3 plus GM R0. 2 upon 3 plus GM R0 will be the answer. Okay, so in that manner you can adjust it. Okay, let's remove it. Well, let me take a break, then I will come back and do the rest of the video. Yeah, okay, let's get started again. So this question was done. Let's go to the last question of our this particular video. After that, you will be much comfortable with MOSFET's amplifier. You will be able to solve a lot of questions, or at least 80% of the problems you will be able to solve from MOSFET amplifier. Okay. In this question, you need to find the voltage gain. V0 by Vin. Vin is applied here. One thing I know, if I look at this circuit, then I know that if I know potential here, if I know the potential here, let's just say if this potential is Vx, then I can directly write down my V0 by Vx. What is my V0 by Vx? I told you one thing. You remember this expression. What is that? Minus GMRD. Right? Here, where I told you to remember. Here I told you to remember. Although this circuit I should have replaced like this. This is my R and this is my V0 and this is my VDD. So what will happen? VDD will be grounded. VDD will be connected to ground. So GM in current will be flowing through R. So this will be the gain. So if I know this potential, Vx, then what is my V0? My V0 is minus GMRD into Vx. When I draw the small signal model, now my target is to get this Vx in terms of Vin. When I draw the small signal model, capacitor will be shorted, right? This current source, everything, this will be gone. This is my M1. So now the thing is, I know RB, everything is fine. But what about this particular circuit? How I can replace this circuit? So now I need to check from here how much resistance do I see. From this side, how much resistance do I see? My circuit has reduced to this part. From here, how much resistance do I see? Have we seen this part? Have we seen this kind of circuit anywhere? Yes. In the beginning only we have seen this circuit. What I will do? I will apply V in here. Why I am doing so? Because I need to connect, no, like this circuit I need to reduce. My final MOSFET that is useful is this one. So I need to reduce this one. And that I will reduce by its equivalent. What will be the equivalent resistance? So from here I need to check the equivalent resistance. And this is the circuitry I am having. Can I tell the equivalent resistance? What I will do? I will apply V in, get I in out of it. So what will be the equivalent? V in by I in. What will happen here? It will have two components. This I in current can go into this MOS as well, but in the MOS it cannot go. So where will the current flow? Here the current will go. Now this I in will have two paths. One is to flow through this MOSFET, another one is to flow through this R naught. But R naught is infinity. That means this I in will flow through this MOS only. This I in will be flowing through this MOS only. So this I in will be flowing through this MOS only. So what will be your I in? I in will simply be, if this node is V in, then what is the current in MOS? The current in MOS will be GMV in. If this node is V in, then the current in the MOS will be GMV in. So I in is equals to GMV in. So what is your R in? R in is equals to 1 by GM. R in is equals to 1 by GM. So this much portion can be replaced with 1 by GM. So what we are getting here? From VS, what we are getting? From VS, I can see RS, or not VS, this is your V in. Now, this node is connected to RB, and RB is in series with this resistance. RB is in series with this resistance. And what is that resistance? This particular resistance. That is your 1 by GM. So from Vx to you are having RB, and that is in series with 1 by GM. And now this is your MOS. And here you are collecting your V node, which is connected to ground, and this resistance is your RD. This is your V node. This is your V node. Okay. So what will be the potential here? What will be your Vx now? Because this will drive 0 ampere current. So what will be your Vx? RB plus 1 by GM upon RB plus RS plus 1 by GM into Vs. So Vx you have find in terms of Vs. So what will be your now? V node by Vs. That would be equals to minus GM RD. What was your V node? V node was minus GM RD into Vx. Minus GM RD into Vx. Here you are having Vx. So V node was minus GM RD into Vx. Now what is your Vx? Vx is equals to RD plus 1 by GM divided by, sorry, not RD, it is RB. RB plus 1 by GM divided by RB plus 1 by GM plus RS. Okay, into V in. Because I am replacing my Vx now. So Vs you can say, or it is V in, whatever you can call it. So what will be your V node by V in now? V in can go here. So my V node by V in is. So that's the answer. And this was considered as one of the finest problem in GATE 2024 examination. But that is very easy. Now it might happen that, sir, how it will click to me in the examination? Sir, it is very tough that all these things should click to me. Like it might happen that what if this is not clicking to me? But there will be options. What I am saying, there will be options. So if you have enough concept cleared and you have options as well, then believe me, you will be able to do at least, you will be able to attempt it in the examination. And if these 3 hours, if you have put your full concentration, then believe me, you will be able to solve as well. And 3 to 4 marks will give you much higher advantage than other students. Okay. If you are someone who is keeping MOS amplifier, that means like your preparation is decent enough. Your preparation is not that good. If your preparation was so much good, then you wouldn't be skipping MOS amplifier. But if you are someone who is keeping MOS amplifier, your preparation is decent enough. But what if in the examination you are able to solve these problems? Then your rank will be much higher than what you would be expecting. Are you getting this point? Okay. So yeah, I gave 3 hours for making this video, and I hope this was helpful. But now the discussion is what's next, because we are having 12 days, and in 12 days we can bring a lot of concept. So what's next? Okay, I am really tired, that's why I am not able to speak properly. So what next thing I should bring? I can bring more concept like that. So first you let me know in the comment section whether this was helpful or not. Like there is someone who did not even study it, or there is someone who was not even comfortable with MOSFET amplifier. Now, what do you feel after watching this video? What do you feel about yourself? Are you comfortable with MOSFET amplifier? Do you feel like that you will be able to do the questions in the examination? Like these questions would have been much easier. This would have been much easier, and this would have been also much easier if I have given the option. In the examination, you will get the option. So what do you think? Will you be able to do the problem in the examination? If yes, then comment down so that I will get to know if these videos are helpful or not. Because here I tried doing a different thing, at least 20 hours of content, 20 or 25 hours of content. I tried to deliver within 3 hours. So just let me know in the comment section if it was helpful or not. If it is helpful, then I can bring more videos like that, because I know a lot of people will be facing problem in, let's just say, in OpAmp only you will be facing problem in a Smith trigger, right? Or positive feedback application. All the positive feedback application I can bring. In digital electronics, I can bring the problems of a sequencer circuit. In EMFT, I can bring the problems on transmission line and oblique incidence, right? In control system, we can bring the video on Nyquist plot, polar plot, Bode plot, right? In network analysis, I guess you should be comfortable. Transient analysis is a bit typical topic, but I guess you are comfortable with that. So network analysis we can skip. Like in different subject, we can bring different topics, right? So certainly we can bring more and more content, but you need to let me know in the comment section, did you find it helpful? Was that helpful for you? If it is helpful, then only we will bring it, no? So let me know, let us know that what was the level, how you did you, like certainly it is a different approach that you might not have studied anywhere else. So this approach helped you or not, okay? Okay, then with that, I would like to end this video. Thank you very much. Hi everyone. So in this video, we will study about OpAmp in positive feedback. OpAmp in negative feedback is also very important, but that is on easier side. I hope everyone is comfortable with OpAmp in negative feedback. So OpAmp in positive feedback, that is one of the topic where students struggle. So that's why we are studying this particular topic. After this video, you will be very comfortable with OpAmp in positive feedback as well. Secondly, when you are watching this video, you need to have a basic idea of OpAmp. At least basics of OpAmp you should be clear. Otherwise, you will not be able to understand this particular video. So if you are someone who has completely dropped OpAmp, if you are someone who has completely dropped analog electronics, then you should not be watching this particular video. But if you have the basic idea of OpAmp, you can certainly watch it, and there is very high chance that 2 mark of question can come from this particular topic. Okay. So let's start with the question. We will go to OpAmp later on, but first let's build up the concept. So what is there in this question? That there is a circuit, you are applying an input, you are getting some output there. On this circuit, you are applying some input, getting some output. What is there inside the circuit that you don't know? What is there inside the circuit that you don't know? Voltage transfer characteristics for the circuit is shown. That what is the relation between V0 and Vin? That relation is shown here. Here there are two characteristics. When we study diode, we also draw the transfer characteristics, right? In diode. Like let's just say if Vin is greater than 0.7 volt, then this is how the graph is go. If Vin less than 0.7 volt, then this is how the graph will go. If Vin is between minus 0.7 to plus 0.7, then output will be 0. So these kind of characteristics we have drawn. But there was only one characteristics, right? There was only one characteristics between V0 and Vin. Now you are getting two characteristics between V0 and Vin. Okay. So we need to study these two characteristics. How we will study it, I am gonna tell you about that. Okay. Firstly, we need to understand how to study these kind of characteristics. So first you need, and what is the meaning of this arrow, that also I will tell. So just hold on to the video. Just see the concept now. So what they are saying, find V0 if Vin is equals to 3 volt. So where will be 3 volt? In this graph, the 3 volt will be somewhere here. And in this graph, 3 volt will be somewhere here. So what is the output when Vin is equals to 3 volt? So this graph is saying that output should be 1 volt. And this graph is saying that the output should be 1 volt. So both graphs are saying that when Vin is equals to 3 volt, output should be 1 volt. So yes, output is 1 volt. Now Vin is equals to minus 2 volt. Where will be minus 2 volt? Minus 2 volt in this graph will be somewhere here. So this graph is saying that output should be minus 1. Where will be minus 2 volt in this graph? In this graph, minus 2 volt in this graph will be somewhere here. And this graph is saying that output should be minus 1 volt. So yes, output will be minus 1 volt. There is no doubt about that. But what about this one? When Vin is equals to 0.5 volt. Vin equals to 0.5. Where will be 0.5? Here it will be 0.5. What this graph is saying, the output should be minus 1 volt. And what this graph is saying, on this graph, where will be 0.5 volt? Here will be 0.5 volt. What this graph is saying, output should be plus 1 volt. This graph at 0.5 volt is saying that output can be minus 1 volt, and this graph is saying that it should be plus 1 volt. So who we should listen to? So that's the point now. In between here in between where the graph is changing 2 volt, this graph is changing at 2 volt and this graph is changing at minus 1 volt. So between minus 1 volt to 2 volt, both graphs will say different thing. Let's just say if my Vin is 0 volt, this graph will say that output should be plus 1 volt. This graph will say that output should be minus 1 volt. Let's just say my Vin is 1 volt. If my Vin is 1 volt, this graph will say that output should be minus 1 volt. This graph will say that output should be plus 1 volt. So who we should listen to? So that is the point here. Now this arrow thing will come into action. So what will be the answer for this one? You will say insufficient information. Insufficient information. So how the question should have been framed? The question should have been framed in this manner, that if my Vin is increasing from minus infinity to infinity, here in place of minus infinity to infinity, they could have written anything. The important point is your Vin is increasing. Your Vin is increasing. So if your Vin is increasing from minus infinity to plus infinity, that means this arrow is showing that Vin is increasing. No, that means you are going into the increasing direction of Vin. This will be the increasing direction of Vin. No? And what will be the decreasing direction of Vin? This will be the decreasing direction of Vin. That means you are working from plus infinity to minus infinity, and here you are working from minus infinity to plus infinity. So what they are saying now, if your Vin is if Vin increases from minus infinity to plus infinity, then find V naught at Vin equals to 0.5 volt. So now you know that which graph you need to follow. Vin is increasing from minus infinity to plus infinity. Here it is decreasing from plus infinity to minus infinity. In this one, Vin is decreasing. Here Vin is increasing. So now I need to listen to this graph. And what this graph is saying? This graph is saying that at 0.5 volt, your answer should be minus 1 volt. So at 0.5 volt, your answer should be minus 1 volt. And in the next one, when Vin decreases from plus infinity to minus infinity, from plus infinity to minus infinity, when Vin is going here, so at Vin equals to 0.5 volt, what should be the answer? So at Vin equals to 0.5 volt, answer should be plus 1. Are you getting this point? Now the next question is saying, comment whether the circuit is inverting configuration or non-inverting configuration. What do we mean by that? So first let's make this characteristics on one graph only. Here we made two graphs, right? Now we are going just to add this graph. What I'm gonna do, I'm gonna add this graph. So what I'm gonna do, first I will make this graph where the transition is at. In the first graph, the transition was at plus 2, right? So first I'm gonna make this graph. The transition was at plus 2. Then I am gonna make the other graph where transition is at minus 1 volt. Transition is at minus 1 volt. So I just combined both of them. I just combined both of the graphs. So now let's see what we can tell. Well and good. So this is how I combined both of the graph. This is 1 volt. So what do you see here? What was this value? Minus 1 volt. So what do you see here is that for higher value of Vin, like after 2 volt, for higher value of Vin, your output is high, right? And for lower value of Vin, your output is low. If you have studied your digital electronics, you would have studied two kind of circuit. One is buffer, one is inverter. In buffer, what happens? If I apply 1 here, I get 1 only. And in inverter, what happens? If I apply 0, I get 1. And if I apply 1, I get 0, right? Here if I apply 1, I get 1. If I apply 0, I get 0. If I apply 0 here, I get 1. If I apply 1 here, I get 0. So here what is happening? For higher value of input, you are getting higher output. For lower value of input, you are getting lower output. But in between, there is a dead zone that you don't know. In between, I will say that I need to know from where to where I am working. But if I am greater than 2 volt, then no matter how from where to where I am working, if I am greater than 2 volt, then always my output will be 1 volt. And if I am lesser than minus 1 volt, then my always output will be minus 1 volt. That means for higher value of input, it is getting high output. For lower value of input, it is getting lower output. So what kind of configuration is that? Non-inverting, right? So what kind of configuration is that? Non-inverting. So what kind of configuration? Non-inverting. Sir, how we will make inverting configuration? So watch the video, we will make inverting configuration as well. Till now, we do not even make non-inverting configuration. It is just the characteristics that is given. But now we need to design it, that how to make this kind of particular circuit. So now our target is clear. Our target is we need to design this kind of circuitry. Can we do it using diode? No. Using diode, what kind of characteristics we were getting? This kind of characteristics we were getting. So using diode, you cannot generate this kind of characteristics. So what you need to use? OpAmp. So there we will use OpAmp. So as of now, all these things are clear or not? Right? So this is how we studied this particular characteristics, and we got to know what is the meaning of these arrows and everything. Right? Secondly, like we will define some terms here now. So -1 is a threshold voltage, no? Like after -1, there is a transition. So whenever there is a transition, that point is known as threshold voltage. So -1 is a threshold voltage, and 2 volt is also a threshold voltage, because at 2 volt there is a transition, at -1 volt there is a transition. So -1 volt is known as lower threshold voltage. Okay, lower threshold potential, you can say lower threshold potential, and +2 is known as upper threshold potential. Why it is known as upper threshold potential? Because this value is higher and this value is lower, that's why it is known as lower threshold potential. There is no other concept. Like some people will say that it is known as upper threshold potential because after that output is +1 volt. No, this is not the reason. The reason is this value is higher, that's why it is upper threshold voltage, and this value is lower, that's why it is lower threshold voltage. There is no meaning of output. The term upper threshold voltage and lower threshold voltage is not defined with respect to output. It is only defined with respect to input. The threshold potential means the where output is changing, where there is a transition. So there is a transition at +2 volt. There is a transition at +1 volt. So there we are having two threshold, +2 and -1. So +2 is our upper threshold voltage and -1 is our lower threshold voltage, just because this value is lower, this value is larger. Now this is known as hysteresis width. Okay, what it is known as? Hysteresis width. Hysteresis width. VH, hysteresis width. So what is hysteresis width here? 2 minus -1. 2 minus -1. So hysteresis width is 3 volt here. Okay, and this zone is known as this zone. Look, this is here output will be +1, here output will be -1. But in this zone, I cannot comment what will be the output. It depends from where to where my input is going. So this zone is known as dead zone. Dead zone. Okay. So hysteresis width, upper threshold voltage, lower threshold voltage. So have you defined these terms? Well and good. Okay. Now we need to get started with OpAmp. But first, let's see the basic concept of feedback. So what do you mean by negative feedback? What do you mean by positive feedback? So in negative feedback, what happens? Output is multiplied with a particular factor and it is coming back towards the input side. But it will be subtracted from the input, negative sign. Here output will be multiplied with a particular factor, but this will be added with the input, right? Whenever you need to check the feedback, how do you check the feedback? You nullify the input sources, Vin will be gone. You nullify the input sources. Now what do I do? Let's talk about negative feedback. So what I will do now, if I increase my V0, just by a small amount, I increase my V0. Like there is no input, let's just say there is some noise. Because of some noise, V0 increases. Now what will happen? This beta V0 will also increase, right? Because if V0 increases, this feedback factor, this will be a certain number. It could be half, it could be 1/4, it could be anything. So if V0 increases, then beta V0 will also increase. Now if this quantity is increasing, so here what you are getting? Vin minus beta V0. Vin minus beta V0. So since Vin is gone, so here what you are getting? Minus beta V0. So here beta V0 is increasing, but there is a negative sign, no? That means beta minus beta V0 is decreasing. Are you getting this point? If I increase V0, beta V0 will increase, but there is a negative sign. That means minus beta V0 is decreasing. Now this decreasing quantity is multiplied with the gain. This decreasing quantity is multiplied with the gain A. That means decreasing is multiplied with gain A. Gain A will be a constant number. It would be 2, 3, 4, 5. It would be anything. So if this guy is decreasing, that means V0 will decrease. Say yes or no. When you tried increasing V naught, beta V naught increased, this quantity decreased, and eventually your V naught decreased. Now this V naught is decreased, so this node is also decreased. If this is decreasing, that means beta V naught is decreasing. If beta V naught is decreasing, that means minus beta V naught is increasing. And if this guy is increasing, that means A into anything that will increase. Now if it again increases, this will decrease. If V naught is again increasing, then this will increase, this will decrease, and then eventually it will decrease. If this is decreasing, then eventually it will increase. So what you are seeing here, once you tried increasing V naught, then when you walk around the loop and when you again come back to V naught, at that time V naught is going down. Now if V naught is going down, you again walk towards the loop, then V naught is going up. So what happened was, initially your output tried to go to higher side, but then it is again pushed back. Then again it tried to go higher side, then again it is pushed back. Again higher, pushed back, pushed back. Then it will go towards a steady state. What do we mean here is that your output will not keep on increasing. That means it is not going towards instability, or your output will not keep on decreasing. That means also it is not going towards instability. That means here output will be certain, output will be fixed. That's why we say that in negative feedback we can avoid getting the condition of plus minus V set, but in positive feedback we get plus minus V set. What is the reason behind that? Why we get plus minus V set in positive feedback? Let's check that out. So here you go to know that output is stable. That means negative feedback circuit are stable. But what happens in positive feedback? If I increase this output, what will happen? This node will increase. Here what is going? Beta V naught is going. There is no negative sign. So this node will increase. If this is increasing into A, this will increase only. If this increases, then again this increases. Then again this increases. Then again this will increase. So it will keep on increasing. Right? I just increased the output by a small amount. Just by a small amount I increased it. Now it will keep on increasing. Let's just say instead of increasing, initially I would have decreased it. Initially I would have decreased it. So if this is decreasing, then what will happen? This will also decrease. Let me use different color of pen. Because let's just say initially I would have decreased it. So if this is decreasing, then this is also decreasing. If this is decreasing, then this is also decreasing. If this also decreases, then finally it is decreasing only. Then more it will decrease, more it will decrease, more it will decrease. So if I try to increase a bit, it is continuously increasing. If I try to decrease a bit, it will continuously decrease. And in OpAmp, the output cannot continuously decrease. It can have maximum plus V set and minimum minus V set. That's why we say in positive feedback we get plus minus V set at output. But in negative feedback we can apply the concept of virtual short, and we can avoid getting the condition of plus minus V set output. Are you able to understand this point or not? So in positive feedback, when we use that as an OpAmp, in OpAmp if we apply positive feedback, at that time we will have only two kind of output, that is plus V set and minus V set. So now you are using a OpAmp circuit in positive feedback. So what kind of feedback is there? Positive feedback. Just because there is a positive sign, that means it is a positive feedback? No. For checking positive feedback, what we need to do? We will nullify this input source. What we will do? If I increase this node, then what will happen? This node will also increase. Now, if positive node increases, then output increases. Right? That's why it is a positive feedback. So if this increases, this node also increases, then this node will also increase. So it will keep on. Are you able to understand why this node is increasing? Because this is simple potential divider, no? So if V node is increasing, then this node is increasing, then output is increasing. So all time output will keep on increasing. That's why there is a positive feedback. So there is a positive feedback, then I know that my output could be either plus V set or minus V set. So there are, and this circuit are same only. These two are same. This is just a different way of representing the circuit. So I can only have two outputs. It could be plus V set or minus V set. So initially I have to assume a particular output. Okay. How do we analyze this kind of circuit? So initially I have to assume a particular output, whether it is plus V set or minus V set. So what I'm gonna do? I'm assuming my output to be plus V set. If your output is plus V set, can you let me know what will be the potential here? V positive potential. So your V positive potential will be what? Simply this will drive 0 ampere current. So how I can write down this potential? Have you seen this circuit anywhere? If here you are having V1, here you are having V2, this is your R2 and this is your R1. Can you write down the potential of Vx? What will be the potential of Vx? You can apply the nodal analysis. I will directly write down the potential of Vx. That will help you a lot in the examination. V1 into R2 plus V2 into R1 divided by R1 plus R2. You can apply the nodal analysis, you will get the same expression. Okay. What will be the potential Vx? V1 into R2 plus V2 into R1 divided by R1 plus R2. So similarly here, output is plus V set. Output is plus V set. So what will be the potential here? Plus V set into R1 plus V set into R1 into V in into plus V set into R1 plus V in into R2 divided by R1 plus R2. Right? Now, if your V positive is greater than V negative, then only output will be plus V set. No, there is your assumption that your output is initially plus V set. This is what you are assuming. But your assumption will be true only when your V positive is greater than V negative. So, if my V positive is greater than V negative, then only my output will be plus V set, right? What is my V positive? My V positive is V set into R1 plus V in into R2 divided by R1 plus R2. It should be greater than V negative. What is your V negative? V negative is 0. So what you are getting? V set into R1 plus V in into R2 should be greater than 0. What is our target? Our target is to draw the transfer characteristics. So your V in will be varying. So I need to get the relation with respect to V in. So what I am getting? V in into R2 should be greater than minus V set into R1. So V in is greater than minus V set into R1 by R2. So this is the condition I am getting. So if V in is greater than minus V set into R1 by R2, then my output is plus V set. And if I just invert the sign, that V positive is less than V negative, if V positive is less than V negative, then what will be your output? Output will be minus V set. So if I have just changed the sign, then what will be the condition? That if V in is less than minus V set into R1, just if I have changed the sign, I will do the same calculation. This arrow will change, right? Greater than will become lesser than, nothing else. So this will be the condition. So from here, what did you get to know? What did you assume first? Now, what is the conclusion of this analysis? What did you assume first is that we assumed our output V0 to be plus V set. Then we got to know that if my V in is greater than minus V set into R1 divided by R2, then your output will be plus V set. But if your V in is less than minus V set into R1 by R2, then your output will be minus V set. Can you draw the transfer characteristics? Yes, sir, I can draw the transfer characteristics, but there will be a very important point to note. What you will say? That, sir, minus V set into R1 by R2, this point will be there. Minus V set into R1 by R2. So this is the point. Let me see one thing. Yeah, okay. So this is the point where things are changing. So, sir, if your value is lesser than this one, then output is minus V set. If your value is lesser than this one, then your output is minus V set. Otherwise, this will be plus V set. Now, the important point is where will be the arrow sign? That is the important point. Where will be the arrow sign? Arrow sign will be going towards from plus V set to minus V set, because what did you assume first? You assumed the output to be plus V set first. So you were at plus V set. Then what did you do? You were at plus V set, that means you were somewhere here. Then what did you do? You keep on decreasing your input. I keep on decreasing my input. When I did my input lesser than this one, then what did I see? My output is going towards minus V set. I was initially at plus V set. That means my input was higher. So when I kept on decreasing it, I got to know that I am going towards minus V set. So I started with plus V set and now I have went towards minus V set. So this is how the arrow will come. Now this is how you will read the characteristics. So this was the important point. Arrow was the important point. That's why I say first we are making an assumption that we are assuming our output to be plus V set. Now you made this assumption, right? Let V naught is plus V set. You could have made this assumption as well. Which assumption? You could have made this assumption as well. That sir, initially I would have assumed my output to be minus V set. Yes, there is no issue. Then what would have been your V positive value? The same analysis you are going to do. What would have been your V positive value? V positive would have been minus V set into R1 plus V in into R2 divided by R1 plus R2. So minus V set into R1 plus V in into R2 divided by R1 plus R2. So what you have assumed, V naught equals to minus V set. Now V naught equals to minus V set. If I have assumed V naught equals to minus V set, this will be only true if your V negative is greater than V positive, right? Or you can say my V positive is less than V negative. If my V positive is less than V negative, then only it is true. No, I have assumed it that my V naught is equals to minus V set. So initially I am at minus V set. So that means certainly this is the condition I am achieving, that my V positive is less than minus V negative, then only I will be at minus V set. So what is my V positive? Plus V in into R2 divided by R1 plus R2. Just a second, I need to drink water. Yeah, so where were we? So what we are doing, your V in, if I solve this equation, what I am getting, V in should be less than V set into R1 divided by R2. So what is the meaning? That you are assuming your output is minus V set. That means certainly you are satisfying this equation. Then only your output would be minus V set. No. So your input was actually this. Your input was actually lesser than this quantity. Then only your condition would have been satisfied. Now what you will do? You will increase your input. Let's just say my input goes above V set into R1 by R2. If it goes above V set into R1 by R2, that means my output would have moved towards plus V set. So initially, if I draw the characteristics here, what happened here? Initially, I assumed my output to be minus V set. Initially, I assumed my output to be minus V set. So actually, if I assume my output to be minus V set, that means my input should have been lesser than this particular quantity, which is this one, V set into R1 by R2. So if I have assumed my output to be if I have assumed my output to be minus V set, that means my input would have been lesser than this quantity. But after this particular value, my output would have been plus V set. So I started from here. I was happy with minus V set. Then what did I do? I kept on increasing the input value. And when I reached at this condition, that when I increased my input such that your input has gone above V set into R1 by R2, then my output went to plus V set. Are you understanding the direction of arrow? So first, whatever your assumption is, you are standing there. And with respect to your assumption, what should have been your input? Then what did you do? You kept on increasing your input. And at one point, your output moved towards plus V set. Are you getting this point or not? So are you able to understand that why we are making those assumptions? We are making those assumptions by making sure that this is our input. Right? So we are getting two characteristics. This characteristics we have got, and another characteristics, this characteristics we have got. So I will draw both of the characteristics on one page and then I will just add them up. So on one page only I am drawing both of the characteristics. So now I hope you are able to understand the concept behind positive feedback. The problem is we do not understand the concept behind positive feedback and just we keep on solving the problem. That's the problem. That's the issue, right? So in our first assumption, I was happy with plus V set. In our first assumption, let's make it with arrow as well. So in our first assumption, I was happy with positive feedback. Then what happened? I kept on increasing, sorry, not positive feedback, sorry. In our first assumption, I was happy with plus V set. Then what happened? I kept on decreasing my input. At some point, the output went to minus V set. And this point was minus V set into R1 by R2, right? This was the point. Minus V set into R1 by R2. And these arrow sign you are understanding, right? In our second assumption, what I was doing, I was happy with my minus V set, but I kept on increasing the input. When it crossed V set by R1 upon R2. When it crossed this value, Vset into R1 by R2. After that, it went to plus Vset. Okay. So if I combine both of them, so what do you see here? If I combine both of them, what do you see? This is for the assumption of minus Vset, and this is for the assumption of plus Vset. Happy with plus Vset, but you decreased so much that you need to go like this. Okay, this point was minus Vset into R1 by R2, and this point was plus Vset into R1 by R2. V in. This is V naught. What kind of characteristics is that? Inverting or non-inverting? Non-inverting, because for higher value you are getting higher output, for lower value you are getting lower output. In between there is a dead zone. What is the hysteresis width? What is VUTP? Upper threshold volt potential. What is that? Vset into R1 by R2. There are two thresholds, Vset into R1 by R2, and other threshold is minus Vset by R1, minus Vset into R1 by R2. Okay, so one which is at higher value, that is your upper threshold, one which it has lower value, that is your lower threshold. What is your hysteresis width? 2 into Vset R1 by R2. Okay, and what kind of characteristics you are getting? Non-inverting. And let's get back to the circuit. Where was your input applied? Your input was applied towards the non-inverting side. This side is known as inverting because there is a negative sign, and this is known as non-inverting. So your input was applied at non-inverting side. So just as you see that my input is applied at non-inverting side, my input is applied at non-inverting side, that means it is your non-inverting Smith trigger. But the reason is not this, that your input is applied towards negative sign, that's why it is non-inverting Smith trigger. No, this is not the reason. The reason is the characteristics. When you get the final characteristics, you get to know that for higher value of input you are getting plus Vset, for lower value of input you are getting minus Vset. So this is the reason why this is known as non-inverting Smith trigger. Are you getting this point or not? Non-inverting Smith trigger. Okay. So what is a non-inverting Smith trigger? So let me show you with the circuit, with the block diagram. If we just make a block, so in the examination you will not have to do this much of analysis to get to the final answer. I will tell you a shortcut as well, but first we need to understand the concept. Otherwise, with the shortcut you will not be able to solve the problem, at least in 2025 or 2026, because now the level of problem has gone up. So they know that if you know just trick, then you will not be able to solve, but if you know the concept, then certainly you will be able to attempt. So now on a block diagram, what I can represent? On a block diagram, I will make it as a buffer like this. I will make it as a buffer like this. What I am saying, in the examination, the block can also be given. It's not necessary that it's not necessary that they will give this particular circuitry. They can avoid giving this circuitry. They will just give the block, and then they expect you to analyze the circuit. What they will write? That it is your non-inverting Smith trigger. They can write this thing, non-inverting Smith trigger. Smith trigger. They will also give that it is having two thresholds. One is UTP, other one is LTP. Okay, so it is having two threshold. One is UTP, one is LTP. VUTP, VLTP. If your input is higher than VUTP, then your output, if your input is higher than VUTP, so here your output will be plus Vset. Since it is non-inverting, the word non-inverting is very important. And if your input is lower than LTP, if your input is lower than LTP, then your output will be minus Vset. In between there will be dead zone. Say yes or no. Okay, so this is the conclusion of your non-inverting Smith trigger. So this should be there in your mind. Okay, non-inverting Smith trigger. That means for higher value it will give higher output, lower value it will give lower output. In between there is a dead zone. So how will you make the characteristics directly? How will you tell these UTP, LTP directly? So let's check that out. So now it is like a trick or it is like a method also you can tell. So how you will tell finding UTP and LTP? So what you are going to do? So first thing is that I will find my V positive potential. What is my V positive potential? V positive potential is V naught into R1 plus V in into R2 divided by R1 plus R2. Now you just let me know one point. When there is a transition, at the transition V positive is greater than V negative or V positive is less than V negative, no? That means when both of them becomes equal, V positive becomes to V negative, at that point transition takes place. Do you agree to this point or not? When your V positive becomes equal to V negative, at that point transition takes place. So here I am not applying the virtual short. I am just telling you a method. What you are going to do is that first you will find V positive, then you will equate your V positive to V negative. And now you will take two conditions. That first you will assume your output to be plus V set, and then second you will assume your output to be minus V set. And based on that you will find the value of V. So what I will do, what I have done is that first I have found out my V positive, then I will equate it to V negative. But how I will equate? First I will assume my output to be plus V set. If I assume my output to be plus V set, what I am getting? Plus V set into R1 plus V set into R1 plus V in into R2 divided by R1 plus R2. And then I will equate it to 0. What is 0? 0. I am not equating it to 0. I am equating it to V negative. I am equating it to V negative. Whatever the potential is given at this particular potential, I am equating it to that particular potential. Okay. The next, I will assume output to be minus V set. So minus V set into R1 plus V in into R2 divided by R1 plus R2. So from here what I am getting, my input value equals to minus V set into R1 minus V set into R1 divided by R2. This is one of the value I am getting, and another value I will get is V set into R1 divided by R2. So this will be the another value I will get. These two are your threshold potentials. The one which is higher value, this will be your VUTP. So from here you go to know that one which is higher value, this will be of higher value. So this is my UTP, and one which is at lower value, that will be your LTP. So did you understand what you need to do? Just first take the output to be plus V set, then take the output to be minus V set, get the V positive potential. Kind of you are applying virtual short. Just remember that kind of I am applying virtual short with respect to output plus V set and minus V set. So from there I will get my two threshold voltages. The one which is at higher value, that will be upper threshold, one which is at lower value, that will be lower threshold. Now how will I draw the characteristics? So first what I will do is that I will see the circuit. When I see the circuit, what did I get to know? That it is my non-inverting Smith trigger. What it is? It is my non-inverting Smith trigger. And one thing I know, that how will my characteristics look like? How will my characteristics look like? That in between there will be a dead zone. And what kind of a Smith trigger it is? Non-inverting. Non-inverting. So what I am doing, in between there will be a dead zone. That means two kind of output are possible. And here there will be transition. Here there will be transition. This point will be VUTP. This point will be VLTP. Transition will be at VUTP and VLTP. For higher value of input, V in, V out. For higher value of input, I will get higher output. Since it is non-inverting, very important point. Since it is non-inverting, that's why for higher value of input I will get higher output. For lower value of input, I will get lower output. So this is how I will make the characteristics. That in between there is a dead zone. For higher value you are getting higher output. For lower value you are getting lower output. Now it will be about arrow. So when you come to this characteristics, what did you get to know? Just see the dead zone. It is moving anti-clockwise. So in non-inverting amplifier, you move anti-clockwise. In non-inverting amplifier, you move anti-clockwise. Now, will it be tough to remember? No, it will not be tough to remember. What it is? Non-inverting. That means it is positive. It is positive. When you take positive angle in mathematics, in anywhere, when you take positive angle, how do you move? Anti-clockwise. When I take positive angle, how do I move? Anti-clockwise. When I take positive angle, how do I move? Anti-clockwise. So whenever we are positive in our complete electronics engineering, whenever we are positive, we always move anti-clockwise. So if it is non-inverting, how I will move? Anti-clockwise. So this is how the movement will look like. Say yes or no. Movement will look something like this. So inside the characteristics, the movement will look something like this. What about these? What about these guys? Here both side will be arrow, no? Here both side will be arrow. Here arrow doesn't matter. Here both side will be arrow. You can check here, right? When you combine both of the characteristics, here also there was arrow. This arrow was there, and here also this was arrow. So here arrow will be on both of the side. So did you understand the trick how you will analyze the circuit within seconds? Any circuitry it could be given. V positive equals to V negative you will do. Threshold you got to know. Then you will make the dead zone. You know that since it is non-inverting, so at higher value of input, you will get higher output. At lower value of input, you will get lower output. Then it's about arrow. You saw that it is non-inverting. If it is non-inverting, that means it will be anti-clockwise. But just remember one thing, in Smith chart, when we study about standing wave pattern, then we make a VSWR circle. So in that Smith chart, we always move clockwise. So this is the only point in your complete electronics where clockwise matters. Okay. In Smith chart, we always move clockwise, not anti-clockwise. So that's the only point that matters in your complete electronics. But yeah, here we will always move anti-clockwise. Why is that so? Because this is your non-inverting Smith trigger. Non-inverting means it is positive, and whenever we are positive in electronics, we move anti-clockwise only. So this will be the anti-clockwise characteristics. Here both arrow will be there. Here both arrow will be there. Now can you read the characteristics? Like if this characteristics is given, can I break it down into two parts? Yes. How will you break it down into two parts? That sir, for higher value you will get higher output, and this is the threshold. Okay. Sorry. So can you break it down into two parts? How will you break it down into two parts? That's the thing. So you need to see the sign of arrow. If I am making for this one, arrow is going this way, this way, this way. Let's see this sign only, this way. First you will make this characteristic, then you need to break it down this way, this way, this way, this way, this, and it is going here. So something like this, it will be broken. This way, this way, this way, this way, this way. So this is one characteristics. Other characteristics, you see the arrow going like this, going like this, going like this, going like this, going upward and downward. You see, going like this, going like this, going like this, like this, like this, upward, 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 and then out. Upward, 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 then out. So just a trick I am telling you that how will you analyze the circuit. Okay, there is very high chance that in the examination they will ask you directly this characteristics. So there you will not do this kind of analysis there. That's our first, this will come. And if there is some complex circuit, then you can do the analysis as well. Analysis will also not take some time. Output you assume plus Vsat, then you get your condition that I was at plus Vsat, then at what condition I am going towards minus Vsat. Output you assume your minus Vsat, then at what condition I am going towards plus Vsat. That's it, you will get the characteristics. So analysis also will not take some time, but if you are in very hurry, then you can just apply the shortcut method. So just answer this question to me. Find UTP, LTP and all these things. Okay, what kind of feedback is there? Only positive feedback is there. Negative feedback is not there. Feedback means from output some part should come towards input. So no part is coming from output towards the input. So only positive feedback is there, right? So what we need to find? UTP, LTP, hysteresis width we need to find, and then we need to draw the transfer characteristics. So what did I tell you? First find out your V positive. What will be my V positive? V in into 2R, V in into 2R plus V naught into R plus V naught into R divided by 2R plus R, 3R. So 2V in plus V naught by 3. What is your V negative? V negative is, this will drive 0 ampere current, so simply you can divide the potential. So what will be your V negative? 3 into R divided by 2R plus R. So it will be 1 volt. So your V positive is this guy and V negative is this guy. So what we need to take? First we need to assume plus Vsat, then we need to assume minus Vsat. So what I am going to do? First I am going to add a page. So what I am going to do? If I assume my output could be plus 5. If I assume my output is plus 5 volt. So what I will get here? 2 into V in plus 5. Output is plus 5, right? 2 into V in plus 5 divided by 3. And I need to equate it to 1 volt. So what I am getting? V in equals to 1, 3 minus 5 minus 1 volt, sorry. V in equals to minus 1 volt. So this is one of my threshold voltage. What could be the other threshold voltage? For the other threshold voltage, I need to take, what is the negative threshold? Just see this. This is not minus 5. This is minus 3. It could be anything, right? It could be 0 as well. Negative threshold is minus 3. So what I'm going to do? 2V in minus 3 divided by 3. That is equals to 1. So what you are getting? 3 you are getting, no? 3 plus 3, 6. 6 divided by 2. So V in equals to 3 you are getting. So what did you see here? Which one is higher? This one is higher. So which is your UTP, which is your LTP? So from here I go to know that my UTP is 3 volt, my LTP is minus 1 volt. So let me know what will be your hysteresis width. 3 minus minus 1, it would be 4 volt. So hysteresis width will be 4 volt. So this will be the hysteresis width. If they ask you to draw the transfer characteristics, what you are going to do? First thing is that you are going to see the circuit. You will see where your input is applied. Input is applied towards the non-inverting side. What does that mean? It is non-inverting Smith trigger. Then you know that there will be a dead zone. So I can quickly make the dead zone. This will be the dead zone. Now I know one more thing, that in the dead zone, how will be the circulation? Circulation will be anti-clockwise. Non-inverting means anti-clockwise. So this is how the circulation will be. Just wait a second. This will not be symmetric, right? The graph will not be symmetric because lower threshold voltage is minus 1 and upper is plus 3. So the graph will not be symmetric. So let me make it in a better manner. So graph will be somewhat like this. This is minus 1 volt and this is plus 3 volt. I got to know that this is your output, this is your input. I know that it is my non-inverting Smith trigger. Anti-clockwise rotation would be there. And one more thing, for higher value of input, you will get higher output. For higher value of input, you will get higher output, and for lower value of input, you will get lower output. And here I can make arrows on both of the side. This side, this side, this side, this side. Here also, this side, this side, this side, this side. And can I read the characteristics? Yes. This is how it is going. Arrow, 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 going here, going here, going here, going upward. This is how it is going. Going here, 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 and here, like this. So this is how the characteristics is done. Within 2 minutes, you will be able to solve these kind of problems. Okay, otherwise it becomes very difficult. Like people don't even understand the analysis first. So that's why I gave the analysis. Otherwise, I would have only told the problem solving skills. But I know that you struggle in the analysis of Smith trigger. You don't even know what is this characteristics. So if now you are comfortable, now you are completely comfortable about these all characteristics and everything. Now what we need to see, we have made non-inverting characteristics. That means for higher value of output, what I am saying, what characteristics we have made? We have made that for higher value of input you are getting higher output, for lower value of input you are getting lower output. But what if I need to design something that for higher value of input I get lower output and for lower value of input I get higher output? So what kind of characteristics you want to make? In your rough notebook you make that characteristics, then match it. Later on, after solving one more problem, I guess. So there is one more question. After this question we are going to make that particular characteristics. So you will analyze this on your own. You will make the characteristics on your own. But before making the characteristics, first let me know that what is your target. What should be my target? My target initially was for getting higher value. I have made a buffer. Now my target is to make an inverter. That for higher value I get lower. For lower value I get higher. In between there is a dead zone. So try making the characteristics. What kind of characteristics you will make? And then you are having a circuit. Here I am already giving you a circuit. And try analyzing it in the same manner that you have analyzed. First assume output to be plus V set, then check the condition, then assume output to be minus V set, then check the condition, and then you understand how you are working. If you assume plus V set, that means where you are, and where you want from plus V set to minus V set, how you are going. So do all this analysis, and before that you can solve this question as well. This is also very easy only. So in the examination, this kind of question can be mentioned. The following sinusoid is applied to a non-inverting Smith trigger with threshold voltage of plus 3 and minus 3. They will not give the circuit. They have just said that it is non-inverting Smith trigger, right? So you know the characteristics of non-inverting Smith trigger. You are supposed to know the characteristics of non-inverting Smith trigger. Non-inverting means higher value will give plus V set, lower value will give minus V set. In between there is a dead zone, and arrow sign also you need to make. Then how will the output look like? So think about it and try making this waveform, and then try analyzing this particular circuitry. So spend some 10 to 15 minutes in your rough notebook on your own, and then start watching the video again. Okay, so yeah, I will take a pause because I am kind of I need a break now, but I will come back and then we will start analyzing from this particular question. Then we will analyze this circuitry as well. Okay, then yeah, so let me take a pause, then you do the rough work in your notebook. Yeah, welcome back. So let's get started. So when you see this question, what you will understand that first, sir, I will have to draw the transfer characteristics because that is the primary task. Let's take this waveform somewhere aside. So first, sir, I will have to draw the transfer characteristics because they have given non-inverting Smith trigger. They did not even give the circuit. They have given nothing. So now I know how to draw the transfer characteristics. Sir, what I'm gonna do? There will be a dead zone. I know the threshold voltage is. It will be -3 and +3 volt. Since it is non-inverting, that means for greater value it will be plus V set. For lower value it will be minus V set. And I know the rotation as well. This is how the rotation should be there. Since it is non-inverting, rotation will be anti-clockwise, right? And here both sign of arrow will come. Here also both sign of arrow will come, right? Now, either I can analyze from this particular characteristics as well, or what I can do, I can break it down. I can break it down into two characteristics. If I break it down, then it will be easier for me. It will be easier for me to look at the circuit, nothing else. So I am breaking it down now. So how I can break it down? I can see that, let's see the arrow that is going this side. So if my input is increasing, then this is how the arrow is going, no? Input is increasing like this. So this is how the arrow is going. So how my characteristics will look like? If input is increasing, then change will be happening at 3 volt. Input is increasing like this, change is happening at 3 volt. This is your minus V set, then you will have plus V set. Saturation voltage will be mentioned actually. Okay. Then next. Now your input is decreasing. This manner we are going. Input is decreasing. So what kind of characteristics we are getting? This kind of characteristics we are getting. So two kind of characteristics are there. These two kind of characteristics we can see. Okay. So this is your -3 volt. Well and good. So it is plus V set, and then downward there is minus V set. This is your V naught. This was also your V naught, and this is your V in. Now you need to study the input. Within 1 minute you will be able to make all these things in the examination. Now you need to study the input and tell the output. Okay, and in the end I will tell you the not shortcut. I will actually tell you the concept that why this is happening. Okay, but first let's study the characteristics and then draw the output. So what is happening? Initially input is 0 volt. So at 0 volt, this guy will say that your output should be -5. This guy will say that output should be +5. So now you need to see -5 means I am calling saturation voltage as -5. So this guy will say that your output should be minus V set. This guy is saying that output should be plus V set. Now you need to see where your input is going. So what do you see? Your input is increasing. So this is how my input is going. My input is going from 0 to 5 volt. That means input is increasing. So in which characteristics input is increasing? In this characteristics. Because in this characteristics we are moving in this manner. So here my input is increasing, but in this characteristics my input is decreasing, right? So in this characteristics it is increasing. So if my input is increasing, right, input is increasing, so I will follow this characteristic. So what it is saying, at 0 your output should be minus V set. So at 0 your output should be minus V set. Till what point it should be minus V set? Until your input increases to 3 volt. So until my input is increasing to 3 volt, my output should be minus V set. After 3 volt, my output should be plus V set. After 3 volt, my output should be plus V set. So till 3 volt, output should be minus V set only. But after that, output should be plus V set. Minus V set to after that, output should be plus V set. When you are going from 3 to 5, when you are increasing from 3 to 5, so till 5 volt, output should be plus V set. Now after 5 volt, what is happening? Input is decreasing. After 5 volt, input is decreasing to minus 5 volt. So if it is decreasing, that means I need to follow this characteristics now. Input is decreasing. So I need to follow this characteristics. Now what this characteristic is saying, if your input is increasing, that means till -3 volt, your output should be plus V set only. Your input is decreasing from 5 volt to minus 5 volt it is going. So from 5 volt to minus 5 volt it will go. But till -3 volt, your output should be plus V set only. So till -3 volt, where is my -3 volt? till minus 3 volt, my output should be plus Vset only. Now from minus 3 to minus 5 also input is decreasing only. Minus 3 to minus 5 also input is decreasing only. So this characteristics only I will follow. But what is this is saying, from minus 3 to minus 5 your output should be minus Vset. So what I will do, from minus 3 to minus 5 your output should be minus Vset. Now after minus 5 what is happening? Input is increasing. Input is again increasing. Input is again increasing. So I will again come back here. I will again come back here. So it is increasing from minus 5 to plus 5. Your input is increasing from minus 5 to plus 5. So what this characteristic will say, that your input is increasing from minus 5 to plus 5. So until you cross 3 volt, your output should be minus Vset only. So until I cross 3 volt, where is my 3 volt? Here is my 3 volt. So until I cross 3 volt, my output should be minus Vset only. After that, it can go to plus Vset. Then again, from 3 to 5, my input is from 3 volt to 5 volt. My input is again increasing. From 3 volt to 5 volt, input is again increasing, and it is saying that your output should be plus Vset. It should be plus Vset. Then what will happen? After 5 volt, again it started decreasing. So again I will come back to this characteristics. So what will happen now? This cycle will keep on following. This cycle will keep on following. Where will be the next transition? Here will be the next transition. So let's draw it with the concept now. So what is the concept? First you need to understand what will be your initial output. Just as I understood that my initial output is minus Vset. Now the thing is, you are at minus Vset. Now what you are doing? You are increasing your input. You are increasing your input in a manner that you want to go to plus Vset. If I am at minus Vset and I am increasing my input, what does that mean? That I want to go to plus Vset? No. Because what does your non-inverting Smith trigger says? That if you are going towards higher input, that means output should be higher only. If you are going towards a higher input, your output should be higher only. So you are increasing the input. That means you want to go towards a plus Vset. So you are increasing your input. So you started with minus Vset. You kept on increasing your input. Now what is the threshold voltage of this Smith trigger? Plus 3 volt and minus 3 volt. So now your Smith trigger will say that if you have crossed 3 volt, you started increasing the input. If you have crossed the 3 volt, then you can make the transition from minus Vset to plus Vset. So now you are in the region of plus Vset. You again kept on increasing your input. Smith trigger will say that if you keep on increasing your input, your output will be plus Vset only. But after 5 volt, what did you say? That now I want to decrease my input. Now I want to go towards my minus Vset. So you started decreasing your input. You decreased your input 5 volt, 4 volt, 3 volt. So what you will say? At 3 volt, can I make the transition? No. If I need to go to minus Vset, then I need to cross this threshold. If I am decreasing, I need to decrease as much as I can. And if I am increasing, I need to increase as much as I can. Here, I am in the zone of plus Vset. In this condition, I am in the zone of plus Vset now. Now, I started decreasing my input. Decreasing. Then I go to know that if I cross 3 volt, that doesn't mean my output will go to minus Vset. No. To go to minus Vset, I need to go to the least number. And my least threshold is minus 3 volt. So I need to go to minus 3 volt. Then the transition will take place. Now I am in the zone of minus Vset. So if I am keep on decreasing my input, then output will be minus Vset only. But after that, after minus 5 volt, what did I say? That I will try to increase my input now. So okay, I am increasing my input. If I am increasing my input, that means I want to go to plus Vset. If I am increasing my input, that means I want to go to plus Vset. So I increase my input. Then I go to know that if you want to go to plus Vset, then you need to cross the maximum threshold. So at minus 3 volt, you will not have the transition. You will have the transition at maximum threshold. Like I guess these dogs are also listening to the concept. Okay, so your transition will be at upper threshold. You are in the zone of minus Vset. Now you need to go to plus Vset. So I was in the zone of minus Vset. Now I need to go to plus Vset. That means I need to cross the upper threshold. And if I am in the zone of plus Vset and I want to go to minus Vset, then I need to cross the lower threshold. This is what your non-inverting Smith trigger says. But you cannot remember all these things in the examination. So what you are going to do? Just make the characteristics, follow the characteristics, draw the waveform. That's it. Now in the examination, what kind of question they can ask? They can ask that what will be the time period of this cycle? Okay, like time period, how will you calculate? You will calculate this angle. You can calculate this angle as well. This is signal system then. They will ask you the time period. They can ask the duty cycle as well, right? So all these things they can ask. And here I gave the threshold voltage to be 3 minus 3. They can give 3 1 as well. They can give 3 minus 2 as well. So accordingly you will draw the waveform, you will draw the characteristics, then you will draw the waveform, and then you will tell the final answer. Well and good, understood? Very easy concept. Did you try analyzing it on your own? Here input is applied to the inverting terminal. So what it will result in? Inverting Smith trigger. But before that, let's analyze it. What we need to do? We will assume an output. What we assume? First we need to assume the output. V naught is equals to plus V set. Okay, let's start with minus V set this time. There is no reason. I am just assuming any output. Let's start with minus V set this time. Okay, I am starting with minus V set. So what will happen? What will come here? So what will be your V positive? V positive will be minus V set into R1 divided by R1 plus R2. What did I do? I simply applied this circuit and this circuit are same only. Okay, because this will drive 0 ampere current, so I can apply the potential division. So minus V set into R1 divided by R1 plus R2. What about, so what is the condition? If you have assumed your output to be minus V set, if you have assumed your output to be minus V set, that means your V positive should be less than V negative. What is your V positive? V positive is minus V set into R1 divided by R1 plus R2 should be less than V negative. V negative is V in. So what is the condition we are getting here? If your V in is greater than minus V set R1 divided by R1 plus R2, then your output is minus V set. So initially you are happy with minus V set. Now what did you do? Now you want to go to plus V set. So what is the condition of plus V set? This is the condition of plus V set. So initially you assumed your output to be minus V set, but now you want to go to plus V set. So what did you do? What kind of characteristics you are getting? Where is the transition point? The transition point is here. Let's call let R1 upon R1 plus R2 equals to beta. I am calling this as beta. Okay, what I am doing? I am calling this as beta so that I don't try to so that I don't need to write down complex numbers. So if this is beta, so what I am getting here? Minus beta V set. So where is the transition? The transition is at minus beta V set. So what is happening? V naught versus V. So initially I was at minus V set. Initially I was at minus V set. Initially I was at minus V set. Then what happened? At minus beta V set, my transition took place and I went to plus V set. And I went to plus V set. And 2 plus V set. Did you understand the sign of arrow? I was at minus V set. Then what did I do? I kept on decreasing my input. I kept on decreasing my input. I kept on decreasing my input. When I kept on decreasing my input, I got to know that after a certain point, I am getting my output to be plus V set. So here what did you see? That for higher value you are getting minus V set. But for lower value you are getting plus V set. What was happening? Initially you assumed your output to be minus V set. If you have assumed your output to be minus V set, that means you are somewhere here. Then what did you do? You kept on decreasing your input. At a threshold point, at a certain point, after a certain point, your output became plus V set. After a certain point, your output became plus V set. So that means this is the characteristics you are getting. Is that clear to you? Right? Can we do the same for the next one? If I assume output to be plus V set. So I have assumed my output to be plus V set. What does that mean? That my V negative should be less than V positive. What is my V negative? V in. What is my V positive? That is V set into R1 upon R1 plus R2. Or you can say your V in is less than beta V set. So if it is less than beta V set, then you are happy with plus V set. But if you kept on increasing your input and you have increased it so much that it goes above plus beta V set, then your output goes to minus V set. Can you draw the characteristics? Yes. I am moving here faster because I have taken enough time to explain all these things, right? So now I can move a bit faster. This should have been done by you on your own because you are someone who has already studied it. So what is the scene? First I was happy with my plus V set. First I was happy with my plus V set. Then what did I do? I kept on, where is my plus V set? Where is my transition point? My transition point is beta V set. Transition point is this beta V set. Okay. So I was happy with plus vset. Here I was happy with plus vset. Then what did I do? I kept on decreasing my, okay, yeah, sorry. When Vin is less than beta vset, when Vin is less than beta vset, when Vin is less than beta vset, I was at plus vset. So I was happy here. Then what did I do? I kept on increasing my input. When I increased it so much that it goes above plus beta vset, then my output goes to minus vset. Okay. So plus vset, minus vset. So are you able to understand the concept? What is happening here? For higher value of input, you are getting lower output. For lower value of input, you are getting higher output. So what did you assume? First, you assume your output to be plus vset. Then what did you do? You kept on increasing your input. First, you would have tried to decrease your input. Then you got to know that if I keep on decreasing the input, my output is still at plus vset only. So in this circuit, if I keep on decreasing my input, my output is at plus vset only. Then what did I try? I tried increasing the input. So when I increased it, and I increased it to a limit that after a certain point it goes to minus vset. So this is how I am moving, and after that it is going to minus vset. Okay. Now how will you draw the transfer characteristics? Final transfer characteristics. You just need to add both of them. Certainly, I will tell you a trick that how you can draw in the examination very quickly. So first one is this one, which I can directly see on the screen. And the second one is this one. It comes like this. Okay. This is minus beta V set. In which direction do you see that rotation of the dead zone? This is your dead zone, no? This is your hysteresis width. This is your dead zone. What is the direction of rotation? Clockwise, right? And what do you see? For higher value of input, you are getting lower output. For lower value of input, you are getting higher output. So what kind of characteristics is that? This is the characteristics of inverting. This is your inverting characteristics. Say yes or no. So in the examination, if it is mentioned inverting Smith trigger, will you be able to make the characteristics or not? Say yes or no. Certainly, sir, you will be able to make the characteristics. What is the shortcut? Shortcut is the same, ditto same. Finding UTP, LTP, how will you find? First, you will find the V positive potential. What will be your V positive potential? V naught into R1 upon R1 plus R2. Then what you need to do? You need to equate it to V negative, which is equals to V in. It could be anything. My target is V positive and V negative I will equate. When I equate them, I will get two values of V in, because output value I will keep either plus V set or minus V set. When, when I get those two value, it will be UTP and LTP. Okay. So what I'm gonna do is that first I am gonna assume output to be plus V set. So if I assume output to be plus V set, so V set into R1 upon R1 plus R2. So this value I am getting. This is the first value I am getting. Secondly, I am gonna assume output to be minus V set. So here what I will get? Minus V set into R1 upon R1 plus R2. That will be the second value. So two values we are getting. One is UTP, one is LTP. So what is your VUTP? Your VUTP is V set into R1 upon R1 plus R2. And what is your VLTP? That is minus V set into R1 upon R1 plus R2. Will you mug it up? No. Just one method I have told you. With that method you can solve. Okay. Then what you need to do? You can draw that transfer characteristics. What you know, there will be a dead zone. So sir, directly I will make the dead zone. Since it is inverting characteristics, inverting, what is the meaning of inverting? What is the meaning of inverting? The meaning of inverting is that for higher value of input, you will get lower output, and for lower value of input, you will get higher output. Right? So this will be the characteristics now. Since it is inverting, what is the word? Inverting. So inverting means when do we take negative angle? Negative angle we take when we move clockwise. So I need to move clockwise now. So this is how I will move. So this is how I will move. So here both arrow sign will come. That doesn't matter. Here also both arrow sign will come. That doesn't matter. Can I break it down into two parts? Yes. Go on increasing the input. So if I increase the input, this is how I am going. And if I am decreasing the input, then this is how I am going. right? So I can break it down into two parts as well. So within minutes, I will be able to solve the problem of smith trigger, which feels like very difficult to me. But after this video, it will not feel like difficult to me, right? So this is your V UTP and this is my V LTP, right? Well and good. Okay, then this is the characteristics we have drawn. Let's see the conclusion then. Non-inverting smith trigger conclusion we have already seen. Here, like here, what I usually here what is mentioned plus V set minus V set, but here I am mentioning it is upper threshold voltage and lower threshold voltage. Okay, it anything can be mentioned in the examination. They can give upper threshold and lower threshold as well. They can give the saturation voltage as well. I am mentioning that this is a circuit I am having. This is like a buffer circuit I am having, and it is having upper threshold and lower threshold. So if your input is greater than upper threshold, then what will be your output? Plus V set. This is for non-inverting. And if it is lesser than that, then what is your output? Output will be minus V set. In between, what will be the scene? In between, the scene will be dead zone, right? What about the inverting smith trigger? What about the inverting smith trigger? Inverting smith trigger says the opposite. If it is greater, then output should be minus V set. And if it is lesser, then output should be plus V set. In between, what is the scene? In between, there is a dead zone. Okay. So here everything depends that how you will work. And will you be able to draw the characteristics as well? Certainly I will be able to draw the characteristics as well. Okay. LTP, UTP will be there. LTP, UTP. I know the process as well that I need to equate V positive to V negative. And if I am able to equate V positive to V negative, after that I can draw the characteristics as well. In non-inverting, I will move anti-clockwise. And in inverting, I will move clockwise. There you go. This is the complete conclusion. Yeah, hi everyone, welcome back. Actually, in between the screen went off. So the thing is, the previous part that I written down, that is not recorded now. So for this video, you will not get the PDF actually. Okay, so sorry for that and please bear with it. You will not get the PDF. So you can see from the video itself, right? Okay, and since this is a revision video, so I don't think you would require any PDF. So what we were doing, we need to solve this question. You need to draw the transfer characteristics when R is equals to 1 kilo ohm and R is equals to 23.625 kilo ohm. Okay. So two conditions are there. Usually when we solve these kind of problems, we never take this R into action. This is what people does. They will say that, okay, OpAmp will give 15 plus 15 volt output and minus 15 volt output. Then what will happen? This 15 volt is enough to take this, like 15 volt will be enough to turn this diode on and to take one of the diode into breakdown. And then they solve the problem. But this is not the case. Here I have given different values of R. So now the things will be different. Okay. So if you have attempted these kind of problems before, now try attempting it on your own. The value of R will play a important role in this particular analysis. Okay. And now what I am doing is that first let me tell you what is the meaning of this particular circuitry. If you don't know the meaning of this particular circuitry, so what is this? This is just Zener. Two Zener connected in series. One Zener and then another Zener connected in series. So these are nothing but Zener diode. These are two Zener diode in series. Well and good. Okay. Now here the thing is, your actual output of the circuit and your output of OpAmp both are two different things. This is the actual output of the circuit and this is the output of OpAmp. Now VA can be plus minus 15. VA will be plus minus 15. After VA there is a R. This configuration is there and then there is a V naught. So VA can be plus minus 15, but V naught, for V naught you need to think. Are you getting this point? For V naught we need to think. It will depend on the operating condition of Zener diodes. So if I need to know the operating condition of Zener diode, then what we need to do? We need to apply the open circuit test. I hope you know how to analyze the operating condition of diodes. So what we need to do? We need to apply open circuit test. So what I am going to do is that this is my VA, right? From VA there is resistance R is connected. R value, we are solving for problem A. So R value is 1 kilo ohm. Then we are considering open circuit condition, right? Now from here, from V0 to directly what is connected? 10 kilo ohm is connected, right? 10 kilo ohm is connected. Then from 10 kilo ohm, what all things are connected? From 10 kilo ohm, one branch is going here, OpAmp is connected. And from 10 kilo ohm, other branch is connected to 0.5 kilo ohm. And then it is connected to 2 volt. So this is the scene, right? So here it is connected to this particular branch. So this particular branch is driving 0 ampere current, right? This is driving 0 ampere current. Input of op amp is driving 0 ampere current. So are you able to understand? Whatever the current that will be flowing from here, let's just say I current is flowing from here. Input of op amp drives 0 ampere current, but output of op amp can drive any amount of current. So if I current is flowing from here, the same I current will be flowing from here as well. The same I will be flowing from here as well. The same will be flowing from here as well, and the same will be flowing from here as well. So all three came into series. Are you able to understand this point? This are 10 kilo ohm and 0.5 kilo ohm. All three came into series. Now my task is to find this Vx potential. So all these three are in series. So I can apply anything, that formula that I told you, Va into R2 plus V2 into R1 divided by R1 plus R2, that you can apply, or you can apply nodal as well. Vx minus 2 divided by 10.5 plus Vx minus Va divided by 1 kilo ohm is equals to 0. That also you can apply. So Va, different condition we need to take. First we are taking Va equals to 15 volt. Okay, I am taking Va equals to 15 volt. So if Va is equals to 15 volt, my target is to get Vx value. If I get Vx value, then I can tell the operating condition of diode. If I am able to tell the operating condition of diode, then I can comment on the output, because this is my output only. Vx is my Vout only actually. So let's first find the value of Vout or Vx, whatever it is. So first we are assuming it to be Vx. So what is the value of Vx? 15 into 10.5 plus 2 into 1 divided by 11.5. Okay, let's do the calculation. 15 into 10.5 plus 2 divided by 11.5, 13.86 we are getting, 13.86 volt. So now what is the scene here at this point? Okay, let's go to the next one. So Vx value I am getting 13.86, and what is the condition? Gainers are connected in this manner. Now what you can see, this 13.86 is connected to the P terminal. This is N terminal. It is connected to the P terminal. So that 13.86 is enough to turn this diode on. So we can assume that this particular diode is on. This will not go into breakdown. This will not even go into reverse bias. This will go into forward bias. So this will be on. So this is enough to turn it on. So what is the potential here? 13.86. What is this? 0.7. So what you are going to get here? 13.16. So here you are going to get 13.16. Now at N side, how much potential you are having? 13.16. And at P side, how much potential you are having? 0. So that is enough to get into breakdown, because breakdown voltage is 6.3 volt. You only require 6.3 volt. So yeah, that is enough to get into breakdown. So now what will be the scene? This is 0.7, and N side will be replaced with P side. Sorry, N side will be replaced with positive side of battery, and P side will be replaced with the negative side of battery. So this will be the final circuitry. So this will be replaced with 6.3 volt battery. This will be replaced with 0.7 volt battery. So you are expecting that here you will get 13.86 volt. But since one of the diode turned on and one of the diode went into breakdown, so here the voltage will be 6.3 plus 0.7, 7 volt. So here actually you are getting 7 volt. So now your V out is coming out to be 7 volt. What was the condition? What I assumed? Va equals to, what we are solving? First we are solving for option A, when R was equals to 1 kilo ohm. So Va is coming out to be what? Va is coming out to be, no, why I am saying Va is coming out to be, Va I assume to be 15 volt. So if I assume Va to be 15 volt, then what is my V out is coming out to be 7 volt, because Vx is V out only, no? Vx is V out only. This Vx is V out only. So V naught is coming out to be 7 volt. So I just need to know what all are the values of V naught. And why I need to know the values of V naught? Why I need to know the values of V naught? Because in this particular circuit, what I'm gonna do, I see that this is a positive feedback circuit. So in positive feedback circuit, what did I tell you? First get the value of V positive and then equate it to V negative. So V negative value I already know. What is my V negative? What is my V negative? My V negative is equals to V in. I need to know the value of V positive. What is the value of V positive? My V positive is V naught into 0.5 plus 2 into 10, 20 divided by 10 plus 0.5, 10.5, right? V naught into 0.5 plus 2 into 20, sorry, 2 into 10 divided by 10.5. So this is my V positive value. So I will equate V positive to V negative, then I will get two values of V in, that will be UTP and LTP. And what do I know? This is your inverting Schmitt trigger. Why inverting? Because it is connected to negative terminal. So this is inverting Schmitt trigger. So I know how to draw the characteristics. But the main point is, what would be the values of V naught? So V naught is not directly connected to the output of OpAmp. In the previous questions, it was directly connected to the output of OpAmp. But now there is a resistance R, there is this particular circuitry, and then there is V naught. So that's the interesting part. That's why we are considered. That's why we are considered about V naught value. So in the examination, looking at the circuit directly, you will not tell us, okay, sir, Jenner will come into action. This is what I have seen in a lot of lectures. This is what is taught, that they don't even care about this R value. You need to do this analysis. Then you will get to know the operating condition of Jenner. Then you can comment, because here the scenes will change. That's why I took this example. No, in the examination, this question was asked. This is a gate PYQ only, but this was asked. Since this was asked, so every time people think that, okay, every time Jenner will get into their breakdown condition or it will be turning on. But it is not necessary. It depends on the value of R. There was also value of R was given. But what if they give the value of R something like this? So here the scenes will change. But first let's analyze for minus 15 as well. What we need to do? Now we need to analyze for minus 15. So now I will analyze the same circuit for minus 15. I can take VA value to be minus 15 volt. Okay, so let me tell you what is the value of Vx. So minus 15 into 10.5 plus 2 into, is this 1 kilo ohm? 1 kilo ohm it was, no? This is the second analysis I am doing when VA is equals to minus 15 volt. Minus 15, 1 kilo ohm, 10, 10.5. Yeah, minus 15 into 10.5 plus 2 into 1 divided by 11.5. What we are getting? 10.5 into 15 minus 2 divided by 11.5. So minus 13.52. Vx is minus 13.52 volt. Okay. So now what is the scene? This is your Jenner. This is minus 13.52 volt. Okay. Now you know that this can go into breakdown because there is very high negative potential on the P side, and this can be turned on. This diode can be turned on and this can be taken into breakdown. So first I am assuming that this goes into breakdown. This guy goes into breakdown. So if this goes into breakdown, then what will happen? This will be replaced with negative terminal. This will be positive. P side negative, N side positive. When it goes into breakdown, opposite happens. So what will be the battery? 6.3 volt. It will be replaced with 6.3 volt. So now you are here you are having 13.52 minus 13.52. So minus 13.52 plus 6.3 minus 13.52 plus 6.3, roughly around here you will be getting minus 7 volt, and then you are having N and P. So P is at 0, N is at minus 7 volt, around minus 7 volt. So what will happen? This is enough to turn this diode on. So this will be going into forward bias. So this diode will be going into forward bias. Since it is going into forward bias, so negative will be negative only, positive will be positive only, and this is grounded. So this will be replaced with the battery of 0.7 volt. So what is the final scenario now? So final scenario, you can directly see that we expected it to be minus 13.52 volt, but we got to know that it is being, one of the diode is turning on and one of the diode is going into breakdown. So we got to know that what we are getting our Vx value, that is equals to V naught value, to be minus 7 volt. So what is the final conclusion we can see? When R was equals to 1 kilo ohm, this is the first question, when R was equals to 1 kilo ohm and we assumed our VA to be plus 15, then what we got? We got our V naught to be plus 7. And when we assumed our VA to be minus 15, we got our V0 to be minus 7. So we expected that our output should be plus minus 15, but since we connected this particular configuration R and GNR, so our output is restricted to 7 and minus 7. That's why we connected this particular circuitry. We connected this particular circuitry so that our output is restricted to plus minus 7 volt. Yeah, so now you are having V negative potential as well, V positive potential as well. You have the value of V0 as well. So directly you can find the VUTP and LTP. Okay. So what you can find now, VUTP and LTP. So what we need to do, V in, that is V negative, I will equate it to V0 into 0.5 plus 20 divided by, this is just a method. Okay. This is not the analysis. We are not applying any virtual short here. This is just the method that I told you, that you just equate them, then put the values of V0, and then you will understand whether it will be going into breakdown or not. So if I put 7 volt here, so 3.5, 23.5, 23.5 divided by 10.5, and one value you will get. What I am doing, first I have put 7 volt here, right? First I will put 7 volt, V0 equals to 7 volt. So for 7 volt, what value of V I am getting? 7 into 0.5, that will be 3.5, 3.5 plus 20, 23.5 divided by 10.5. And when V0 is equals to minus 7 volt, what will be your V in? Minus 3.5 plus 20, that is 16.5 divided by 10.5. So this is the answer we are getting. 23.5 divided by 10.5, 2.238, 2.238. 16.5 divided by 10.5, 1.57, 1. So what is your, which one will be UTP, which one will be LTP? This will be your UTP, this will be your LTP, right? Minus 2.238. So what we are getting, hysteresis width is coming out to be, hysteresis width is coming out to be 0.66 volt. Okay. Now can I draw the characteristics? Certainly I can draw the characteristics very easily, right? Hysteresis, I know, what do I know? That sir, this will result into hysteresis only. So hysteresis I can draw. Why I am drawing like this? Because both are positive, 1.57 and 2.23, right? And one thing, another thing I know, what is that? That for higher value of V in you will get lower output. For higher value of V in you will get lower output. For lower value of V in you will get higher output. This is what we know, right? And since it is inverting amp, since it is inverting Smith trigger, so for inverting what we do, we will move clockwise, right? For inverting we move clockwise. Okay. And here arrows on both of the side, arrows on both of the side. Well and good. So this is the final answer. So this was the first question. The second one is more interesting now. The second one is R equals to 23.625 kilo ohm. So you do the analysis on your own. You would be able to do it. Just you need to put 23.625 kilo ohm here. So what you will get? R is 23.625 kilo ohm. So here 23.625 kilo ohm, then another resistance, and here you are having 2 volt and 2.5, 10 kilo ohm, 2.5. Again I am taking the diode in, I am applying open circuit test here. Here what I am gonna do, here I am gonna apply VA only. VA could be plus 15 and minus 15, anything. So I am using it to be plus 15 volt, and here 23.625 kilo ohm. So what I need to find? I need to find Vx. So what is Vx? Vx I need to find. So 15 into, it was 2.5, no 0.5, that's what I was thinking. This was 0.5. So 15 into 10.5, 15 into 10.5 plus 2 into 23.625. 23.625 divided by 23.625 plus 0.5. This was kilo ohm as well. Mm, 23.625 plus 10.5. 23.625 plus 10.5. 34.125. So what we are getting, 15 into 10.5 plus 2 into 23.625 divided by 34.125. 6. Yeah. Vx is coming out to be 6 volt. Now, do you really think this 6 volt is enough to get into breakdown and all these kind of things? Let's check. So this was our circuitry. Right? Here what I'm gonna assume, 6 volt. So now, yeah, it feels like that sir, this should be going into forward bias because 6 volt is there. That should be enough to take it into forward bias. So what I will do first, I will try to take this into forward bias. So this I have taken into forward bias. So how much voltage drop it will give? 0.7. What I will be having here? 5.3. Now you let me know. Is this 5.3 enough to take into breakdown? No. So now what will happen? It cannot go into breakdown. So where it will go? In reverse bias, because at N potential you are having 5.3, at P you are having 0. So where it will go? Reverse bias. So if you assume this to be forward bias, then this is going into reverse bias. So actually what happened is that if it is reverse bias, then what will happen? It will be open circuited. And if it is open circuited, then what will happen? There will be 0 ampere current. And if there is 0 ampere current through the diode, what does that mean? That both diodes are off only. So both diodes are off here. So here it is open circuited only. We assumed it to be open circuited, then we got to know that both diodes are off, so it will be always open circuited only. So here we connected Zener, but there was no use of those Zener diode. Are you getting this point? Okay. So in the examination, they can play with the value of R. So here there was no point of those Zener diodes. So actually the Zener diode was replaced with open circuit. And if Zeners are replaced with open circuit, then what will be my value of V naught? So Vx will be equals to V naught will be equals to 6 volt. It will not be plus 15. Now, there is a resistance R, there is this 10 kilo ohm, there is 0.5 kilo ohm. So this resistance R will take some drop. That drop it will take. So Vx value will be 6 volt. This will be the value of Vx. Are you getting this point? Okay. So this was your Vx value we are getting. Now you can try for minus 15 as well. So if I apply minus 15 here, then for Va equals to minus 15. If I apply minus 15 here, so what will be the value of Vx I will be getting? Minus 15 into 10.5 plus 2 into 23.625 divided by 34.125. So what value of Vx I will get? 15 into 10.5 minus 2 into 3.625 divided by 34.125 minus 3.23 minus 3.23 volt. Okay. So now what is the condition? This is your Zener. This is your Zener. Here what you are having? Minus 3.23 volt. Do you really think this is enough to take this into breakdown? No. Minus 3.23 is not enough to take this into breakdown. You may feel like that, sir, minus 3.23 is enough to take this into forward bias. Yes. But even if it goes into forward bias, nothing will happen. Even if it goes into forward bias, still what will happen? Here there will be minus 0.7 volt. I am assuming that this is going into forward bias. So here there will be minus 0.7 volt. If there is minus 0.7 volt, then still this is not going into breakdown. So there is no chance that this will go into breakdown. And if it is not going into breakdown, then what does that mean? It will be in reverse bias. This diode will be in reverse bias. And if it is in reverse bias, that means it will drive 0 ampere current. Since both are connected in series, so this will also drive 0 ampere current. If both diodes are driving 0 ampere current, that means both will be open circuited. So this will be the final operating condition. And if both are open circuited, that means whatever the Vx value you are getting, the same value you will get for V0 as well. So this is your final V0 as well. So this time you have two V0 values, plus 6 and minus 3.23. So what we need to do, we will equate Vin equals to V0 into 0.5 plus 20 divided by V0 into 0.5 plus 2 into 10, that is 20 divided by 10.5. V0 into 0.5 plus 2 into 10 divided by 10.5. Yeah. V0 into 0.5. This is what we used to do, right? Yeah. So now we need to put the values. V0 equals to 6 volt you will put, V0 equals to minus 3.23 volt you will put. So getting started, V0 equals to 6 volt I am putting. If I put 6 volt here, what I am gonna get? 3 plus 20 divided by 10.5. So 23 divided by 10.5. And V0 equals to minus 3.23 volt I will get. Minus 3.23. 3 into 0.5 plus 20 divided by 10.5. Okay. So 23 divided by 10.5. 2.19. And here 3.23 into 0.5 plus 20 divided by 10.5. So what you are getting? 1.75. So did you understand the motive behind framing this problem? Did you understand the motive? The motive was that this R also has some importance. Okay, you do not give importance to R, so you need to give importance to R as well. Well and good. So, but let me tell you one thing, guys. Till now, whenever the question has been asked, okay, so always these guys were going into breakdown and forward bias. So let's just say in the examination, the paper comes out to be lengthy and you are not having enough time. If you are not having enough time and paper comes out to be lengthy, so going by the analysis of previous year questions, they are always going into breakdown and reverse bias. So what you can do, you can consider them into breakdown and reverse bias. If in the examination you are not having much time, so without even checking, by hit and trial, blindly you can go them to take into forward bias and breakdown region. But if you are having time, then certainly check it. Or it might happen that in the examination they do not even give the value of R. So if they are not giving the value of R, that means certainly it is going into breakdown. If they are not giving the value of R, what does that mean? That certainly it is going into breakdown. Otherwise they would have given the value of R, no? Right? If they are not giving the value of R, that means they want this to go into breakdown. So this value of R user will put. Now user can put this much large value as well. If he is putting this much large value, then it is not actually going into breakdown. So here we go to know that answer is becoming different. Now our UTP, LTP both are different. So you can draw the characteristics. Characteristics will be same only. Here I am just writing hysteresis width. This will be your UTP. This will be your LTP. Right? So 25 plus 19, that will be 0.44. 0.44 volt. So this will be your hysteresis width. So in this manner we will solve the problem in the examination. Well and good. Let's go to the next question. Try this on your own. Again you need to apply open circuit test, short circuit test, the same thing. What kind of Smith trigger it is? Inverting. This is your inverting Smith trigger. So again you assume plus 10, minus 10, then you see what will are the operating condition of diode, which diode will turn on, and then what we need to find. Our target is to equate V positive to V negative. What do I know? I need to equate this thing. But this is not virtual short. This is just a method. By the method, we will equate this thing, then we can find our UTP, LTP. So what do I know? That my V negative is equals to V in. How do I get V positive? So for getting V positive, two kind of output I can have. What is one kind of output? That V naught could be plus 10 volt. If V naught is plus 10 volt, then which diode will turn on? This diode will turn on. Why is that so? You can apply open circuit test. If I apply open circuit test, what will happen? This is 0.5 kilo ohm, then diode is open circuited. Here 2 kilo ohm, diode is open circuited, right? And this is the condition. Okay. Now what is the scene? OpAmp drives 0 ampere current. Since they are open circuited, we have considered them to be open circuited, so they will also take 0 ampere current. Here also there is 0 ampere current. So what will be the current through this 2 kilo ohm? That will also be 0 only. So this 2 kilo ohm is also taking 0 ampere current. So if there is 0 ampere current, so that means this voltage will be 0, because this is ground, so this voltage will be 0. So this is 0, this will also be 0, and there is no current through the resistance, so this and this potential will also be 0. So now what you are applying, we know to be 10 volt. Here 10 volt, here 10 volt. So now what do you see? At D2 you are having 10 and 0, so this will turn on, and D1 you are having 10 and 0, so this will be turned off. So this is how you can check. So what is happening here? D2 is turning on. The D2 is turning on. If D2 is turning on, then what will happen? This 10 volt will travel and it will reach here. Now 2 kilo ohm will not be in action because D1 has turned off. D1 has turned off, so this 2 kilo ohm will not drive any current. So 10 volt has reached here. If the 10 volt has reached here, what does that mean? This is not even into action, and OpAmp is driving 0 ampere current, and 10 volt has reached here. So what will be the potential of V positive? What do you think? What is the potential of V positive? From V positive upper side there is no current. Here also there is no current. So I can directly apply potential division. No. So what will be the potential? 10 into 2 upon 2.5. So V positive will be 8 volt. Are you getting this point? Understood? So V positive will be 8 volt. What is our target? To equate V positive to V negative. So one value of V in you are getting as 8 volt. So this could be either UTP or LTP, that we need to check. Next is V naught equals to minus 10 volt. So in the same manner you will check, you will understand that D1 will turn on now. If D1 is turning on, then what will happen? D2 will be off. So this guy will not even come into action. If this guy is not coming into action, then what will happen? D1 is only turned on. This is turned on. Then what will happen? This will drive 0 ampere current. This will drive 0 ampere current. So now what will be the potential here? The potential will be divided between 2 and 2 kilo. Here minus 10 is there, so 2 and 2 kilo it will be divided. So V positive will be coming out to be minus 5 volt. Why minus 5 volt? Minus 10 came here. This is turned on. 2 and 2 kilo potential is divided, so this will be minus 5 volt. So V positive is coming out to be minus 5 volt, right? So another value of V in you are getting minus 5 volt. So this is your UTP and this is your LTP. What is your hysteresis width? 8 minus of 5, so that will be 13 volt. This is your hysteresis width, this is your LTP, this is your UTP. Well and good. Very easy question. In these kind of questions, you should not be taking any time. You will be able to answer it very quickly. Even this question you will be able to answer very quickly. Here just I made the problem complex. In the examination you will see, okay, 7 volt will come here, then just find the potential equated to V in. But I just made it complex by this particular question. Otherwise it would be easy. What about this one? This is a good question. Just notice one thing there. Transfer characteristics you need to draw. Let me complete the question. For V naught versus V in. Okay. You need to draw the transfer characteristics for V naught versus V in. Not versus minus V in. So your actual input is V in here. Your actual input is V in. So V in is applied to some circuitry and then you got minus V in. How you can get minus V in from plus V in? This is how you can get minus V in from plus V in. This is resistance R, this is resistance R. Here you apply V in. So from here you got minus V in, right? Minus RF by R, negative feedback. So you can apply virtual short. So this minus V in is applied here. And then the circuit, then you need to tell about the nature of output. So you need to compare plus V in to V naught. You need to make the characteristics between V naught and this V in, not between V naught and minus V in. Okay. So this is the question now. So what do you know? What kind of symmetry is this? If I forget about this minus V in, I just understand that this V in is some input. This V in is some VA input. Okay. If I assume this as a VA input, so for VA, This is a inverting Smith trigger, right? Inverting Smith trigger. Inverting Smith trigger. Say yes or no. So now what do we say? If your minus V, if your VA is high, if your VA is high, then your V out will be low. This is the meaning of inverting Smith trigger. If VA is high, then V out will be low. What is VA? VA is minus V in. So if minus V in is high, what do you mean by minus V in is high? Can I say V in is low? If minus V in is high, that means if minus V in is high, what does that mean? That it is somewhat minus 5 volt. Minus 3 and minus 5. Which is higher? Minus 3 is higher, no? Minus V in is high. So V in will be low, no? Negative sign is there. So V in will be low. Right? If this is the higher, this is on the higher point, then if I remove the minus sign, then this will be on the lower side. But if I add the minus sign, then this will be on the higher side. So V in will be low. If VA is high, then V naught will be low. So what did you understand from here, from this particular analysis? First I consider if VA is high, then V naught will be low. That I know because it is a inverting Smith trigger. So if VA is high, that means minus V in is high because VA is equals to minus V in. That means V in is low. So what did you understand from here? That if your V in is low, if your V in is low, then your V naught is also low. And second conclusion will be what? That if my V in is high, if my V in is high, then my V naught will also be high. So for minus V in, it was inverting Smith trigger, but for plus V in, it is becoming non-inverting Smith trigger. So by the circuitry, it looks like that it is inverting Smith trigger, but actually it is non-inverting Smith trigger. Okay, so this works as non-inverting Smith trigger. Okay, what is our usual target? What is our V negative? Minus V in. What is our V positive? V positive is V naught into R1 upon R1 plus R2, right? So what do we do? First time we put a plus V set, second time we put a minus V set. So if I put a minus V set, then what will be the value I will be getting? V set into R1 upon R1 plus R2. So this will be my UTP. And here, if I put V naught equals to plus V set, then my V in will be minus V set upon R1 plus R2. So this will be my LTP. So now I can draw the characteristics as well. How will the characteristics look like? How will the characteristics look like? So here I am drawing the characteristics. I know that there will be this thing. For higher value, you will get higher output. For lower value, you will get lower output. Okay. Since it is non-inverting, that means non-inverting means anti-clockwise. Okay. You know this thing, you know here as well, whatever the potential are there. Now in the examination, you might not be confident with all this analysis. That minus V in is high. You might not be get confident. So what you will do? You will do the whole analysis. I told you the whole analysis as well, no? Assume first I am at plus V set, or you can assume at minus V set as well. So first I am assuming myself to be at a plus V set. If I assume myself to be at plus V set, then I will find the potential of V positive. Then I will see when I will go towards V negative. Sorry, when I will go towards minus V set. So from plus V set, we are going towards minus V set. So whatever the condition is, based on that you draw the graph. Then assume your output to be minus V set. So from minus V set to plus V set, where I am going. You draw the transition point, and then from there you see how I need to go from minus V set to plus V set. So in that manner you draw the graph and then you get the characteristics. So I have also checked this particular analysis because I was also not confident with this analysis, right? In the examination it might happen that if this question is coming for the first time in your examination, you might not be confident with this analysis. So what you will do? You will do the exactly whole analysis that I taught you in the beginning of the lecture. So that analysis you can do very easily. Within 2 to 3 minutes, you will be able to do that and you will be able to make this characteristics. But if I am confident with this analysis, I don't even think I need to use the pen. Because what I will see, Okay, minus V in. For minus V in it is inverting, then actually it will be non-inverting. Then in the options, this characteristic would be there. I will click on that, right? But if I am not confident enough with the analysis, then I will do the whole analysis that I taught you earlier, right? Let's see this one. So yeah, these kind of questions, I guess it would be coming into the examination in future. Till now, it not has been introduced. So here positive feedback is also there and negative feedback is also there. So shall I apply virtual short or it will be Smith trigger? So how I can comment on that? So the way of commenting here is that you need to see the nature of circuitry. In the first slide, right in the beginning, what did I tell you? In positive feedback, if I increase the output, then output will keep on increasing. And in negative feedback, if I increase the output, then eventually output will decrease. Then again it will increase, again it will decrease. And what did I tell you? Nullify the input source. Nullify the input source. Now, let's just say I increase the output by delta V naught. If I increase the output by delta V naught, so here this node will also increase, no? Because this will drive 0 ampere current and this will also drive 0 ampere current. So if this increases by delta V naught, so this will also increase by delta V naught by 2. So this node will also increase. But by how much it is increasing? Delta V naught by 2. Now this node will also increase, right? This node will also increase. But by how much factor? Here what did I do? I applied the potential division R upon R plus R 1 by 2. Here also I will apply the potential division R upon R plus 3R. That will be 1 by 4. So this will increase by delta V naught by 4. Let's just say I would have increased my output by 1 volt. So here it would have increased by 1 by 2 factor and here it would have increased by 1 by 4 factor. So which potential is increasing more? This potential is increasing more. What is the output of V naught? What is the output of OpAmp? A into V positive minus V negative. So this guy is also increasing and this is also increasing. But this guy is increasing more. So output will increase more. Right? This guy V positive is increasing more. So output will increase more. So eventually this is in positive feedback. Are you able to understand this point? So this is how we need to check. Like in conclusion, what we understood, that first we need to find the potential here. If I assume V naught here only, so I got to know that potential here is V naught by 2. And then here the potential will be V naught by 4. So who is having more factor? Which quantity is larger? This quantity is larger. So positive feedback is there. If this quantity came to be larger, then negative feedback would have been there. So conclusion is, just assume V naught there. Here V naught by 4 will come. Here V naught by 2 will come. So which quantity is larger? This is larger. So positive feedback is dominating. Why it is dominating? Did you understand the logic behind that? Okay. You understood, right? Yeah. So now there is positive feedback. That means it is Smith trigger. What kind of a Smith trigger is that? Input is connected to non-inverting side. If your input is connected to non-inverting side, what does that mean? If input is connected to non-inverting side, that is non-inverting Smith trigger. Non-inverting Smith trigger. Same thing I need to do. V positive, V negative. Those things I need to find. So what is my V negative this time? V naught by 4. Right? V negative is V naught by 4. This is your V naught. Here V naught by 4. This analysis is gone. Okay? This analysis is gone. But let's keep it here. But now what is my target? I know that I need to find UTP LTP. So how do I find UTP LTP? Get V negative. V negative is V naught by 4. Get V positive now. What is V positive? V naught plus V in by 2. How did I write it? V naught into R plus V in into R divided by 2R. So this is my V positive. Next, what is the task? Assume plus V set and minus V set. So first what I am assuming? V naught to be plus V set. So what I will get? Plus V set by 4 divided by V set plus V in by 2. So V set equals to V set by 4 plus V set plus V in by 2. So 2 V set plus 2 V in. So V in is equals to minus V set by 2. Right? Did I do the calculation correctly? V set by 4. Yeah. So this is one guy I am getting. Most probably it will be your LTP only. But let's check other value also we can check. So next we are going to put V naught equals to minus V set. So if I put minus V set, then what we are getting? Minus V set by 4 is equals to minus V set plus V in by 2. So 2 V set by 2. So yeah, V in equals to what we are getting, plus V set by 2. So yeah, so here if I put plus V set by 2, so yeah, we are getting this the same thing. So this is your LTP, this is your UTP. Then you know how to draw the characteristics as well. Same thing, exactly the same thing. Plus V set minus V set, I know there will be one hysteresis. If there is hysteresis, then this is how I can draw the characteristics. I know for higher value it will give me higher output, for lower value it will give me lower output. Since it is non-inverting, so sorry, anti-clockwise, really sorry, yeah, anti-clockwise, this is how it will go. पहले वाले में मैंने clockwise बना दिया क्या? This goes anti-clockwise only, no? Anti-clockwise. यहाँ क्या बना रहा हूँ मैं? Oh, this I am making clockwise. Really sorry, really sorry. क्या कर रहा हूँ भाई मैं? Anti-clockwise. हाँ ठीक है. Okay. So anti-clockwise. Yeah, fine. In the previous one, did I mess up anywhere? This was also anti-clockwise. This was clockwise. Here I did not even draw the characteristics. Here I was expected to do the clockwise. Right? This was clockwise. Yeah. Did not mess up anywhere. Okay, so in these kind of analysis, you should have good amount of patience. Clockwise, anti-clockwise. This is anti-clockwise because this is converted to non-inverting it is. So anti-clockwise. Okay, my plus minus V set by 2 plus V set by 2 plus V set by 2. All good. I guess this was the last question only. Okay. So yeah, we are done with the Smith trigger. So this was the first topic of our positive feedback. Now other two topics are left, which are multi-vibrators. They are astable and monostable multi-vibrator. So now I have given you enough concept. So do I need to make the video on multi-vibrators as well? Because I think you have got enough concept. Now you can analyze multi-vibrator circuit on your own. So can you do that, or you want me to bring the video? I can bring the video if you guys require, but you need to comment down, because I guess now it should be enough that you can analyze multi-vibrators on your own. If you want me to bring, then I will bring. Otherwise, I guess it is fine. Okay, so you guys comment down, then I will see whether I need to bring it or not. And one more thing, for this video we are not bringing notes, because I told you the screen went off in between. Okay, first initial slides are like these slides are saved, but in between these slides are not saved. Like these are saved only. Then coming to this part, so half notes are saved, half are not saved. So and build the habit without the notes as well. Okay, build the habit. Just watch the video, and what you will do now, seeing the notes and all these things, just see the video and proceed. Right, this was just a revision video. So yeah, okay, thank you very much. You can comment down if you want the next video I will bring. Thank you. Yeah, so now we will solve this problem, but before that you will answer me a few things and I will teach you a few things. Okay, so first let me know what kind of circuit it is. It is a PMOS or NMOS? It is a PMOS or NMOS? Sir, arrow is outside, it is NMOS. What about this one? Sir, this will be PMOS. Okay, now let's just say I say this potential is V1 and this potential is V2. This potential is V1 and this potential is V2. Now in the MOS circuitry, this current I need to write down in the downward direction. So what will be value of this current? So it would be Gm into this potential V1 minus this potential V2. The current is going from upward to downward. Kind of you can say that from V1 to V2, from upward to downward, upward to downward. Now if I write down this particular current, and you know one more thing, that whatever the current that is flowing here, the same current would be flowing here as well. So this current would also be Gm into V1 minus V2. In the MOS, the current would be same, and in MOS this current would be 0 ampere. This all these things you already know. This current would be 0 ampere. Now if I ask you what will be this current? Current going in the upward direction. The circuit is same. Circuit is same. Can you let me know that this current? Sir, it would be negative of this. Downward direction current is Gm V1 minus V2. So upward direction current would be Gm V2 minus V1. Sir, it is pretty obvious why you are asking it. But if I need to write it down, so how would I write down? I am going upward. That means I am going from V2 to V1. So what I will write down? Gm V2 minus V1. Like it's just a way. There you don't need to think that, sir, V1 minus V2, V2 minus V1. You see the current direction. current is going upward, Gm V2 minus V1. Similarly here, let's just say this potential is V1 and this potential is V2. Not this potential, sorry, this potential. Because gate and source potential we need to define. So this potential is V2, this potential is V1. Now I'm asking you what is the current in the downward direction. Whatever the current is there, the same current would be here as well. So what is the current in the downward direction? What you would say? So I'm going from V2 to V1. So current would be Gm V2 minus V1. Now again the same circuitry is there, ditto same, nothing changed. But just I'm asking you what is the current in the upward direction. Whatever the current that is flowing here, the same current would be flowing here as well. Similarly, whatever the current that was flowing here, the same current would be flowing here as well. So what is the current? You would say that, sir, current would be Gm. I'm going from V1 to V2. V1 minus V2. That's it. So VGS, VSG, all these things you don't need to see. Just see the current direction from where to where you are going. That's it. V1 to V2, Gm, V2 to V1, Gm V2 minus V1. V1 to V2, Gm V1 minus V2. Same current would be flowing here as well. Well and good. Now another very small thing. There is a potential V. From this potential V, I current is flowing. So what will be the value of this resistance R? From potential V, I current is flowing. So the value of this resistance R is V by I. Similarly, if I say from this potential V, Gm V current is flowing. So what will be the value of this resistance R? The resistance R would be from the potential V, Gm V current is flowing. The resistance R would be 1 by Gm. Well and good. So I will be using it somewhere. Let's get started with the question now. Small signal gain we need to find out. We always have to move from V1 to V0. Sorry, not V1 to V0, V in to V0. What we need to find out? We need to find out V0 and V in. So our matter of concern is V0 and V in. So my target would be that, sir, I move from V in to V0. That's it. Whatever that is coming in between, that I need to eradicate. So let's get started. What I would do? First, I need to do the AC analysis. So what I would do is that this VDD would be grounded, right? And then this circuit is there. If I make in this manner, then it would take a lot of time. So I need to make it quick. This is my V in. Okay. And downward, if I look, okay, now this is your V0. Now this is your V0. Now where will be your R0? Sir, R0 will be somewhere here. R0 will be between drain and source. So drain is connected to, sorry, source is connected to V0 and the drain is connected to ground. So this will be my R0. This is M1, so R0 1. This is your M1, this is your M2. And V0 to ground, this would be your R0 2. Well and good. Right. Now what do you see? From V0 to ground, I see R0 2. From V0 to ground, I see R0 1. Now this potential is V0, right? This potential is V0. Now if this potential is V0, can you write down this current? This potential is V0, this potential is 0. What will be this current? So this current would be, I am calling this current as I1. Okay. So this I1 current would be, sir, Gm into, I am going from V0 to ground, Gm into V0 minus 0. So this, sir, this I1 current would be nothing but Gm V0. So this is your V0 potential. In from this V0 potential, how much current is flowing? Gm V0 current is flowing. From this V0 potential downward, there is Gm V0 current is flowing. So from V0 to ground, what you can assume? You can assume a resistance. What will be value of this resistance? So that would be from V0 resistance. So from V0 potential, Gm V0 current is flowing. So that value will be 1 by Gm. There you go. So what you see? From V0 to ground, sir, I see R0 2. From V0 to ground, sir, I see R0 1. From V0 to ground, sir, I see 1 by Gm1. This is Gm1, no? Gm1, Gm1, Gm1. So from V0 to ground, what all things you see? R0 2, R0 1, 1 by Gm1, and then this circuitry. What will happen to this circuitry? We will see that. But how you can reduce this circuit now? Sir, the reduction I have done in this manner. In what manner? This circuit remains as it is. This is my V in. I will have to add a page because it would not look good. Okay. What I do is that so I will have to add some page. So how I have reduced the circuitry, I have reduced the circuitry in this manner. Sir, this M2 remains as it is. I cannot do anything about M2 as of now because M2 is connected with V in. Now here it is connected to V0. This was grounded already, right? This is the scenario. This is the scenario. This is your M2, V in, grounded, all these things, fine for you. Now from V0, what I have seen? From V0 to ground IC R01, from V0 to ground IC R02, from V0 to ground IC 1 by GM1 as well. That means from V0 to ground, what all things I see? From V0 to ground I see R01. From V0 to ground only, from V0 to ground I see R01, from V0 to ground I see R02, from V0 to ground I see 1 by GM1 as well. That means all are coming in parallel. So you can effectively you can say that from V0 to ground I see R01 parallel with R02 parallel with 1 by GM1. Say yes or no. This is what we see. Well and good. All fine. Now this is your V. This is your 0. Can you write down the current? If I want you to write down this current coming from upward to downward, what that current would be? So that current would be GM2. Upward potential is 0 minus V in. So this current, whatever the current that is flowing here, the same current would be flowing here as well. So this current has become, what this current has become? This current has become minus GM2 V. This current has become minus GM2 V. Now the same current is flowing through this resistance as well. How much current is flowing through this resistance? Minus GM2 V. So what is the value of V0 now? The current is flowing in this direction. That means this will be the value of V0. Value of V0 would be current, which is GM2 V in, multiplied with the resistance R01 parallel with R02 parallel with 1 by GM1. So what is the value of V0 by V in you are getting? Sir, I am getting this as minus GM2 parallel with R01 parallel with R02 parallel with 1 by GM1. So minus GM2 1 by GM1. This is the answer. Always look at V0, look at V in. Whatever that you can reduce, just reduce that and then simply apply the equations, you will get the answer. Detailed discussion, we will solve another problem here. But after that, like before that only I am telling, there is a detailed discussion done on MOSFET amplifier. Like even if you have zero knowledge of MOSFET amplifier, still you will be able to understand. So this is a must watch video for everyone. This I uploaded last year, so you can go solve MOSFET amplifier within a minute. So even if you have zero idea of analog electronics, still you will be able to understand this particular video, and it will be coming for either 2 marks or 4 marks in the examination. So must watch video it is. You can see views are also pretty good. 15K views are there. So you would be able to understand in a much better manner. Even if you have studied MOS amplifier, then also it will be revised in a much better manner without drawing any model. Like this is how we need to consider all the cases. So all the cases I have considered there, and all the gate PYQs also you will be able to solve after this particular video. So surely you need to watch this particular video. Let's solve this particular question now. So what is happening in this one? Again, sir, my eyes will be on V0 and V in. Sir, in between, sir, from V in to IC RS, then sir, at this node there is some issue. Sir, at this node there is RB connected and then this circuitry is connected, sir. But I can see my V0 and V in, this is the relation. So somewhere there is a issue. Let's call this node as a VA node. Okay. Now from VA node, I see RB, but sir, here I see some circuitry. Okay. Let's call this node as VB node. So from VB node, what do we see? I am making that particular circuitry. From VB node, what do I see? From VB node, sir, you see a current source. And then you see this particular MOS circuitry. Which circuitry? This particular MOS circuitry, sir, you see. This is my VP. Okay. And this was your VDD. Now you know one thing that, sir, if I am doing the AC analysis, then this will be open circuited, this will be gone, and this will also be gone. So effectively, this kind of circuitry I see. Effectively, this kind of circuitry I see from VB. Now you know that from VB, whatever that you see, that has to be replaced with some resistance, right? Then what will happen? RB in series with some resistance, and VA node will be simplified. So if this node is VB, this node will also be VB. Now if this node is VB, then how much current it will drive here? This MOSFET is M1. So how much current we will get here? Sir, that would be GM1 VB. Understandable? If this current is GM1 VB, then how much will be this current? That would also be GM1 VB. How much will be this current? That would also be GM1 VB. So this current is GM1 VB. Right? Is that understandable to you? Now just let me know how much will be this current? Sir, 0 ampere. So this current is 0, this current is 0 ampere, this current is GM1 VB. So how much will be this current? So this particular current would be nothing but GM1 VB only. So what do you see here? From the VB potential, I am driving GM1 VB current. So if I need to replace it with some resistance, what will be the value of this resistance? The value of this resistance would be, sir, I am from the VB potential, I am driving GM1 VB current. So the resistance will be 1 by GM1. So this much of whole circuitry, can simply be replaced with 1 by GM1. Is that understandable to you? Is that understandable to you or not? Yes, sir, surely it is understandable. Now from VB to ground, you see 1 by GM1. So from VA to VB, you see RB, and RB is coming in series with 1 by GM1. From VB to ground, 1 by GM1 you see, no? So RB and 1 by GM1 will be in series. So from from VA to ground, what do you see? From VA to ground, what do you see? So let's make the circuitry now. What we are having? Here we are having V in, right? We are having V in. Now after V in, there is RS connected. From V in, there is RS connected. Then sir, there is VA. Then sir, there is VA. So from VA to simply RB is connected, right? From VA to simply RB is connected. This was your VA node, right? Then this was your VB node. From VB to ground, what is there? 1 by GM1 is there. 1 by GM1 is there. This is the scenario. Now after that, what is the scenario? After that, there is simply M2 connected, and then from M2, that VDD will also be ground. This will also be grounded. So sir, this node will become V node, and this will be my RD. Okay, this is the scenario now, right? V node to ground, you see RD. From V node to ground, you see RD. So this is how I can make it. Now can you write down this? Let's remove this VB now, because now I see that this is the total resistance RB plus 1 by GM1 I see. Can you write down this VA potential in terms of V in? Yes sir. What will be this VA potential? Sir, VA potential will be RB plus 1 by GM1 divided by RS plus RB plus 1 by GM1 into V in. Say yes or no. Can you write down this particular equation? This is your VA. RB plus 1 by GM1 upon RB plus 1 by GM1 plus RS, that is multiply with V in, would be equals to VA. Now if you know VA, can you write down V naught? Now this much of basics would be clear to you, sir. If this is VA, then what will be this current? If this is your VA, and here R naught is ignored, okay, channel and modulation is ignored, so R naught we are not considering. If this is VA, so then sir, this current would be GMVA, because this potential is VA, this potential is 0, that means this current would be GMVA. Now the same GMVA current would be flowing here as well, it would be flowing here as well. So this would be GMVA current is flowing. What kind of MOS it is? It is M2, so it would be GM2VA, GM2VA. So what will be the value of V naught? Value of V naught would be, current is flowing downward to upward, so the drop would be somewhat like this, right? So the voltage would be minus GM2VA, that is the current, multiply with the resistance, that is RD. So what you are getting? V naught is minus GM2 RD into VA, that is your V naught. Okay, that is your V naught. Now VA I can replace in terms of V in, so minus GM2 RD, RB plus 1 by GM1. Now in what form answer is given? Yeah, in this form only answer is given. So you can sense that sir, answer is matching now. I am just replacing the value of, I am putting this value of VA here, nothing else. So RB plus 1 by GM1 upon RS plus RB plus 1 by GM1, multiply with V in here, and this is equals to V naught. So V naught by V in, what is your V naught by V in coming out to be? So your V naught by V in is coming out to be minus GM2 RD minus GM2 RD. They are talking about the magnitude, okay? They have just taken the magnitude here. They have taken the magnitude. So what you will get? GM2 RD, RB plus 1 by GM1, RB plus 1 by GM1 plus RS. RB plus 1 by GM1 plus RS. So this option is matching. Okay, if you have more than enough practice, no, then these will not take much time. You would see, sir, RB, the 1 by GM1 is there, so RB plus 1 by GM1, simply the drop would be there and then multiply with GMRD. That's it. Very easily you will be able to do it. Like these are very standard circuits. No, all these things are very standard circuit. So you have reached to this level, then it will be simply a cakewalk. So in the examination, it will not take much time. So this question is also clear. Okay, and surely you need to watch this particular video. Here you will get a clear idea. All the PYQs are also solved in 3 hours. After that you will feel like that, sir, if the question is coming on MOS amplifier, I will be able to solve it. Okay, even if you have zero idea of analog, zero knowledge of analog is there, no, then also you will be able to understand. Okay, let's go to the next one. Great question, absolutely brilliant question. You might have solved it applying some formula. I don't know which formula you would have applied. 2RC ln 1 plus beta 1 minus beta, whatever the formula it is, you would have solved it with respect to the formula. But in the analog, I never believe in formula. So I'm not going to solve it with respect to the formula, but I am going to teach you a very good concept. Now, CMOS Smith trigger is given and it is inverter. So there are two kinds of Smith trigger, inverting Smith trigger and non-inverting Smith trigger. So let's discuss that. What do you mean by inverting Smith trigger? What do you mean by non-inverting Smith trigger? So we are going to discuss non-inverting Smith trigger. Symbol is like this. This is the symbol of a non-inverting Smith trigger. Now it has two kind of voltage, upper threshold voltage and lower threshold voltage. You need to have a basic idea of a Smith trigger, then you will be able to understand. So it has two kind of voltage, upper threshold voltage and lower threshold voltage. Let's just say this is my lower threshold voltage. Let's call it -2 and let's call it +3. So this is your lower threshold voltage, which is -2, and this is your upper threshold voltage, which is +3. Now what is the meaning of a non-inverting Smith trigger? Non-inverting Smith trigger means if your value is, if your input is, this is your input V in and this is your output V naught. If your input is greater than 3 volt, then your output will be high. Let's just say high potential is 5 volt and low potential is -5 volt. Okay, so if your V in is greater than 3 volt, then output will be +5, and if your V in is less than -2 volt, then your output would be -5. That means for higher values of input, you will get the higher output. If your input is greater than 3 volt, then this is the output you will be getting. And if your input is less than -2 volt, then sir, this is the output you will be getting. This is the output you will be getting, which is -5. Now sir, what will happen in between? That's the question. In between, what will happen? So in between you get the dead zone. This is known as dead zone. So in between you get a square. Now what is the meaning of this square? I will explain it. Have some patience. This kind of characteristics you will get in between. This kind of characteristics you will be getting in between. So this is your +5 volt you are getting here and -5 volt you are getting here. Okay, so if your input is greater than 3 volt, then +5 volt, input is less than -2 volt, then -5 volt. Now sir, what do you mean by this particular characteristics? I will tell you, but before that let me tell you one more thing, that if it is non-inverting Smith trigger, then the rotation will be anti-clockwise. What do you mean by this rotation, sir? That also I will tell you. The hysteresis, this is known as hysteresis, that will be anti-clockwise. For non-inverting it will be anti-clockwise, and here both clockwise and anti-clockwise, both nature would be there. Now let's just break down this particular characteristics. What I am doing, I am breaking down this particular characteristics. Just follow this particular sign, forward sign. If you follow this forward sign, then this characteristics you are getting. Say yes or no. Only follow the forward sign, don't follow the backward sign. If you only follow the forward sign, then this is the characteristic you are getting. So this is one characteristic that I have broken down in this manner, that if I only follow the forward sign, this voltage is 3 volt. If I only follow the forward sign, then this is the characteristic I am getting. If I only follow the backward sign, then this is the characteristic I will get. Only follow the backward sign, this is the characteristic I will get. So this point is -2 volt. Understandable? Well and good. This is 3 volt, -2 volt. Higher value will give you output of +5 and lower value will give you output of -5. When you combine both of them, you get this particular characteristics. Okay. Now, how to read this particular characteristics? What is the meaning of this characteristics? If I ask you, my V in is 4 volt, what is your V out? Sir, if your V in is 4 volt, this characteristics is saying that your output should be +5 volt, and this characteristic is also saying that your output should be +5 volt. If your V in is -3 volt, what will be my output? Sir, if your V in is -3 volt, then this characteristics is saying that your output should be -5 volt, and if your V in is -3 volt, then this characteristic is also saying that your output should be -5 volt. In both of the cases, you are sure about the output. But let's just say someone says that my Vin is 0 volt, what will be the output? Sir, when your Vin is 0 volt, then this characteristic is saying that your output should be plus 5 volt, and this is saying that your output should be minus 5 volt. So who is correct? Sir, this particular characteristics that you have made, that will follow both of the cases, no? So which one is correct? You need to ask from where you are getting this 0 volt. Now if someone says that you have moved from plus infinity, or take any value, from plus 10 volt to 0 volt, you have changed your input from plus 10 volt to 0 volt, plus 10 to 0. Initially you were here, let's just say this is plus 10 volt. Initially you were here and you have moved from plus 10 to 0. That means in which direction you have worked? In this direction. So this is the arrow. So now you need to follow this particular characteristics. Here if you have moved, let's just say this is 10 volt. So 10 to 0. So how you are moving? You are moving in this direction. But here the arrow is saying that you need to move in this direction. Are you able to understand this point? You are moving in this direction, but arrow is saying you need to follow the opposite direction. That means this characteristics I will not follow. I will follow this particular characteristics. Okay. So if Vin is moved from plus 10 to 0 volt, then when Vin is equals to 0 volt, then what will be your output? Then my output would be, sir, I will follow this particular characteristics, and he is saying that output will be plus 5 volt. Now if your Vin is moving from minus 10 volt to 0, then which characteristic you will follow? From minus 10 to 0. That means arrow will be in this direction. And now if your Vin is 0 volt, so what will be your V0? V0 will be minus 5 volt. So what do you understand from this characteristics? That if I am moving from a low value to higher value, then I will not change my output until I reach to the upper threshold voltage. And when I am moving from higher voltage to lower voltage, I will not change my output until I reach to the lower threshold voltage. You don't need to mug it up. What you can do is that you can always make these characteristics. You will say that, sir, it is non-inverting semi trigger. At higher value I will get higher output, lower value I will get lower output, in between I will get a square. Okay, not square, it could be anything. This particular characteristic I will be getting in between, right? Since it is non-inverting, I will have a anti-clockwise characteristics. Now I will be able to read this particular characteristics. What this characteristic is saying, that for any value greater than 3 volt, output is 5. For any value less than minus 2 volt, output is minus 5. In between, you need to tell from where to where I am moving. If I am moving from higher voltage to lower voltage, higher to lower, then I will follow this particular characteristics. If I am moving from lower to higher, then I will follow this particular characteristics. There you go. This is the meaning of non-inverting semi trigger. But in the examination, inverting semi trigger was mentioned. So let's understand about inverting semi trigger now. Yeah, and inverting semi trigger. Okay. So what is the meaning of inverting semi trigger? So again, I am saying that my upper threshold voltage is 3 volt and lower threshold voltage is minus 2 volt. What is the name here? Inverting. So what will happen? If my input is high, my output will be low. Let's just say with respect to high output, I am getting plus 5 volt, and with respect to low output, I am getting minus 5 volt. So if your input is greater than 3 volt, then output will be low. That means it will be minus 5. And if your input is less than minus 2 volt, that means if it is lesser, then your output will be higher, which will be plus 5. Is that understandable to you? Minus 2 plus 5, greater than 3, you will get minus 5. In between, what you will get? In between, you will get a square. In between, you will get a square like this. In inverting semi trigger, the rotation will be clockwise. Rotation will be clockwise. Okay, here both of the arrows would be there, here both of the arrows would be there. Sir, how do we get this particular characteristic? If you want to know this particular thing, that sir, how I am getting this characteristics, then you need to watch this video. Okay, even if you have zero idea about semi trigger, then also you will be able to understand. Like a lot of people would study semi trigger, but they don't study it in a good manner. No matter from whichever the God educator you are studying, a lot of legendary educators are there in this field. But if you study from human being, you will realize that there is a different meaning of semi trigger. A way different meaning of semi trigger is there. Please watch this particular video. You will understand the meaning of semi trigger. That how we started. Actually, we started from this particular characteristics. That we needed to make these characteristics, then we joined them, and then we moved to semi trigger. Okay, that is the actual flow of studying semi trigger. But we will put a particular circuitry, we will analyze it that this much higher output doesn't make any sense. So please watch that particular video. Okay, please watch that particular video. You will have a much clear idea about semi trigger. Okay, so yeah, this particular thing we have seen. Yeah, so how would you read this particular characteristics? You would say that, sir, if my input voltage is greater than 3 volt, output will be surely minus 5. If it is less than minus 2 volt, output will be surely plus 5. Now, if my input is moving from a higher potential to lower potential, then my output will be changing at a lower threshold value. And if my output is changing from, sorry, if my input is changing from higher potential to, sorry, lower potential to higher potential, if my input is changing from lower potential to higher potential, then the transition would take place at a upper threshold voltage. So if I am following this particular thing, that means I need to follow this characteristics. And if my input is following this particular thing, then I need to follow this particular characteristics. Is that understandable to you? Let's solve the question now. In the question, what they are saying, read the question. They are saying that inverter is having low output level of 0 volt and a high output level of plus 5 volt. Low output level of 0 volt and high output level of plus 5 volt. 0 volt here and high output level of plus 5 volt. Is that understandable to you? This is what they are saying. So two possible outputs are there, either plus 5 you can get or you can get 0 volt. Two possible outputs are there. Right? What is the upper threshold and lower threshold voltage? These are 2.4 and 1.6. It is not necessary that it has to be negative. It can be positive as well. But upper threshold voltage is 2.4 volt and lower threshold voltage is 1.6 volt. Sir, what kind of Schmitt trigger it is? Inverting Schmitt trigger. CMOS inverter it is, no? So it is your inverting Schmitt trigger. Inverting Schmitt trigger. Can you make the characteristics now? Surely I can make the characteristics. Sir, this is how I will be making my characteristics. I can get, sir, two kind of output, either plus 5 or 0 volt. Either plus 5 or 0 volt. Sir, I am having lower threshold voltage of 1.6 volt and upper threshold voltage of 2.4 volt. Sir, if I make the characteristics, it would look somewhat like this. Sir, in between both of them, sir, I will be getting a square. Between upper threshold and lower threshold, you always get a square. Upper threshold and lower threshold. Upper threshold and lower threshold, you always get a square. Between upper threshold and lower threshold, you always get a square. Now, if input is greater than 2.4 volt, if input is greater than 2.4 volt, let me know what will happen. It is inverting Schmitt trigger. So for greater value, you will get lower output. For greater value, you will get lower output. And for lower value, you will get higher output. Okay. And sir, this is output will be plus 5 volt and this output will be, sir, 0 volt. Sir, this is what? This is inverting Schmitt trigger. That means rotation will be anti-clockwise. Sorry, clockwise. Sorry guys. It is clockwise. For inverting Schmitt trigger, rotation will be clockwise. Okay, and here both clockwise, anti-clockwise, both full follow. But here there is no meaning of rotation. You don't need to make the rotation. You know that if input is less than if input is less than 1.6 volt, job done. If it is greater than 2.4 volt, then also you know. In between, what is the scenario that you need to know. So here also both kind of rotation you can make. Both kind of rotation you can make. Okay. Now what they have done, they have taken this particular circuitry only. What they have done is that they have simply taken this particular circuitry only. And they have connected a feedback. What kind of feedback they have done? They have connected a RC circuit here. Okay, and then this node goes here. This is the circuitry. Say yes or no. 10 kilo ohms, 47 nanofarad. Right? This is the scenario now. Now let's see what will happen. What is the initial voltage across the capacitor? That is 0 volt. So this voltage initially at t equals to 0. What we are doing now is that what we will do now, we will draw the V in waveform as well and we will draw the V out waveform as well. Both of the waveforms we will draw, but I will have to add a page which I am not having as of now. So what I can do is that I can take up this page. पेज तो है ही नहीं यार, कहाँ ड्रॉ की जाए. Where do I place it? So what I am doing is that I am removing this particular page. Okay, removing this. Like you can see, two videos are there. Both of the video you should watch. After watching this particular video, you can watch this video and this video as well. Okay, so these two videos you can watch. So I'm removing this slide, and MOSFET amplifier also you can watch. So I'm removing this slide as well. So I will get 2 extra pages. Yeah. So now what I'm going to do is that I'm going to draw V in versus V naught waveform. Like V in waveform also I will draw, and V naught waveform I will draw with respect to time. V in waveform also I will draw, V naught waveform also I will draw with respect to time, and V naught T with respect to time. Well and good. Okay. So initially at t equals to 0, what is the input? 0 volt. Now if input is 0 volt, then what will be the output? So if your input is 0 volt, output will be plus 5 volt. So initially at t equals to 0, your output is plus 5 volt. So at t equals to 0, your output is plus 5 volt. After that, what will happen? I don't know, but I will be starting from here, and my input is 0. Right? Now just as it has become 5 volt here. Now this is the ideal OpAmp. Everything is ideal, so this current would be 0 only. This current, all this current would be 0. Now what is the scenario here? This is 5 volt. Now what this 5 volt will do? This 5 volt will charge this capacitor now. The scenario is you are having 5 volt here. This is resistance R and this is C. So now this 5 volt will charge this capacitor C. How it will be charging? Let's call this is your input, V in input only. So your V in T would be nothing but 5 into this equation. You need to know how you can write down this particular equation. I think this much is clear to you. How to write down the charging capacitor equation. 5 into 1 minus e to the power minus t by tau volt. What is the value of tau here? RC value is 470 microsecond. Okay. So your V in T is nothing but 5 into 1 minus e to the power minus t by 470 micro. Okay. Now this capacitor will start developing some voltage. That means what is happening now? The input value, this input value is increasing from 0 to some particular value. So what is happening? Your input value is increasing from 0 to some particular value. That means which characteristics you will follow? This characteristics I will follow. So it is increasing from 0 to some particular value. Is that understandable to you? Now what will happen is that when input is 0 volt, output will be plus 5 volt. When input is 1 volt, output will be plus 5 volt. When input is 1.8 volt, output will be plus 5 volt. When input is 2.1 volt, output will be plus 5 volt. But when the input become 2.41 volt, what will be the output? Output will become 0 volt. Is that understandable to you? Sir, initially this was 0 volt, output was plus 5 volt. Now this plus 5 volt has started charging this capacitor. Now the capacitor is getting charged. If the capacitor has reached to 2.4 volt, from 0 to if it has reached to 2.4 volt, then the output will change. This output will change. If this output is changing, then something different would happen with RC circuit. So what you have understood, until your V in T is reaching 2.4 volt, no changes are happening. This will remain 5 volt only. That means this will remain the charging condition only, and you can get the value of T from here. So what will be the value of T you will be getting, that you can see. (2.5 divided by 5 minus 1 plus minus 2.5 divided by y minus 1 plus minus ln into 470 micro. So 307.34 microsecond it would take, although it is not a matter of concern for me, but still if I need to make the waveform, 307.34 microseconds. Again let me check the calculation. 2.4 divided by 5, and then minus 1 goes here, then you take ln and then you multiply with 470. Yeah, so 307.34. So for 307.34 seconds, it will remain at plus 5, then it will become 0. Now till what point it will remain at 0, that we will see, but till how much time? How much was this window? This window was 307.34 seconds. 34 surely microsecond. All these calculations are going into microsecond. And what about the input voltage? Sir, input voltage started with 0 and it has charged to 2.4 volt. It has charged to 2.4 volt. It has charged to 2.4 volt. Till what point? sir, till the same time that is 307.34 seconds. And after that, what will happen, that we will see. So this is your 307.34 seconds. Now after that, what will happen? And this has charged to 2.4 volt. Okay. Now this has become 2.4 volt or just greater than 2.4 volt, or you can say that it has become 2.00001 volt. Then what will happen? Output will become 0 now. This output will become 0 volt now. Now what is the scenario? The scenario is that, sir, this capacitor, which is 47 nanofarad capacitor, sir, this has been already charged to 2.4 volt. This is already having 2.4 volt, right, sir? And now then there is a resistance R. And sir, this node of resistance R is actually grounded now. This is the scenario. Now what will happen? This capacitor will discharge. Right? Now the capacitor will discharge. So how it will discharge? What will happen to this VNT? Output is at 0. What will happen to this VNT? So now the VNT equation would be, from 2.42 it will discharge. Although it will be starting from, sir, 307.34 seconds. So ideally you should write down the equation in this manner, that e to the power minus t minus 307.34 divided by tau. But I am ignoring this particular part. Like, I don't need to care about this particular part, no, 307.34 second. I would just get to know that I am considering this is my t equals to 0 now. Okay. So I am simply writing down that capacitor will discharge now. So capacitor will discharge in this manner. Okay. That means now this value of VNT is decreasing. 2.4 it is. So from 2.4 to somewhat lesser you are going. That means you are moving from 2.4 to some less value. So which characteristics you will follow now? Which characteristic you will follow? This characteristics I will follow now. From 2.4 to I am decreasing. So which characteristics? This characteristics I will follow now. Where the transition would take place? 2.4, let's just say it has become 2.3, output is still 0, output is still 0, output is still 0. If your capacitor voltage has become 1.6 volt, then what will happen? Output will change. This output from 0 to it will go to plus 5 volt. When this 2.4 has become 1.6 volt. So how much time it would take to go from 2.4 to 1.6? So that time I can find out. E to the power minus t by 470 microsecond. So how much time it would take? Sir, it would take 1.6 divided by 2.4 ln into 470. 190.56 microsecond. 190.56. So after this it will take 190.56 microsecond. How much? 190.56 microsecond. After this it will take 190.56. So in 190.56 you need to add up 307.34. Right? So that is becoming 497.90. Okay, so it has become 1.6 volt now. This has become 1.6 volt now, and the output is still at 0 volt only. But after that, output will become plus 5 volt. So this is your 497.90. Now what will happen? Output has again become 5 volt. And this capacitor is initially having 1.6 volt now. So now what is the condition? For the third cycle, the condition is that, sir, output has become plus 5 volt here. Then, sir, there is R, and then, sir, there is capacitor C as well. There is R, and then this capacitor C as well. But now this time the capacitor C is charged to how much voltage? It has charged to 1.6 volt. And this is my V note. Now what will happen? This 5 volt will charge this capacitor. Say yes or no? Yes, sir. It will charge this capacitor. Now from 1.6 to where it will try to go? Sir, it will increase from 1.6 to this time the characteristics would go from 1.6 to it will try to increase. So from 1.6 to it is trying to increase in this manner. So where the transition would take place? At 1.7 output will be plus 5, 1.8 output will be plus 5, 1.9 output will be plus 5, 2.3 output will be plus 5, 2.4 output will change. That means when the input value become 2.4 volt, then it would change. So can you write down the capacitor charging equation? Can you write down the equation of V in T? What is your V in T? This is not V out, sorry. This is not V out. Here I have said V out it. This is not V out actually. This is V in T. The capacitor voltage is V in T here. So this is your V in T. So when your V in T would change, your V in T equation is, it will try to go to 5 volt. if you need to write down the V in T equation, this will be the V in T equation. Ideally, I know that, sir, it will be starting from some this is 497.90 second. So ideally here in this equation, I should put T minus 490 whatever it is, but I don't care about that. I will simply find the time and then I will add it up. So I don't want to make my equation complex. So T by 2, which is 470 microsecond. Now where the transition would take place at 2.4. e to the power minus T by 470 microsecond. So from here you can get the value of T. So 2.6 divided by 3.4 ln into 470, 126.08 microsecond. Okay, again 2.6 divided by 3.4 ln 126.08 microsecond. That means what is happening, if I see this particular characteristics, it is going from 1.6 to again 2.4, and how much window it is taking? It is taking the window of 126.08 microsecond. 126.08 microsecond. So if I need to show this particular time, this time would be 497.90, 497.90. So 623.98, 623.98. Now this is the scenario we have got, and it has remained to, output has remained to 5 volt. After that, what will happen? Output will again fall down to 0. Why is that so? You can follow the characteristics. From 6 to 2.4 we have gone. From 6 to 2.4 we have gone. We were following this particular characteristics. So now the output will again fall down to 0. Now the output will again fall down to 0, and capacitor is already charged to 2.4 volt. This capacitor has charged to 2.4 volt now. Now what is the condition? The output has fallen down to 0. Output has fallen down to 0, and capacitor is charged to 2.4 volt now. Now, have you analyzed this condition? RC circuit, capacitor is charged to 2.4 volt. RC circuit, capacitor is charged to 2.4 volt. Then what will happen? Again charging. Then again at 1.6 volt, it will make the transition. What does that mean? That means this cycle now will keep on going. This cycle now will keep on going. Is that understandable to you? So after this, the cycle will keep on going. What does that mean? That means this particular window will keep on repeating. This is always, I say always one thing, that first cycle is never the steady state cycle. First cycle is that where the circuit is starting. After that, you will get the steady state cycle. So this is the steady state cycle we will keep on getting. Decreasing, increasing, decreasing, increasing. So output will keep on making the transition from 2.4 to, what about output? Output will keep on making the transition from 5 volt to 0 volt, 0 volt to 5 volt, 5 volt to 0 volt with this much of time window. Now what is this time window? This time window is 190.56, 190.56 plus 126.08, 190.56 plus 126.08, that is coming out to be 316.64 microsecond. So this is the time period we are getting. What will be the frequency of oscillation? In the question, what they are asking? Frequency of oscillations they are asking. Frequency of oscillation in hertz. So what you need to do? You need to take the reciprocal and then multiply with 10 to the power 6. 1, 2, 3, 4, 5, 6. So what I am getting? 3158, 3158.16 hertz. So that's the answer. That's the way of solving this particular question. Now someone would say that, sir, will we get this much of time? If you have enough practice, then you will be able to solve it in 3 to 4 minutes. What you would see if I have enough practice? Sir, non-inverting Smith trigger, make the characteristics. Now you know one thing, that sir, I will be starting from 0, output will be plus 5 volt. So first I need to know that these kind of questions would be there in your class notes as well. So you would know that, sir, first cycle will not be the steady state cycle. First this will charge to 2.4, then it will discharge to 1.6, 2.4, 1.6, 2.4, 1.6. This cycle will keep on going. So now my target would become that this is 2.4, so it will discharge first. It will discharge to 1.6. Then after reaching 1.6, here 5 volt would come and it will again charge. So 2 cycles only I will analyze and I will be able to get this time value. Our matter of concern was, what was our matter of concern? This was our matter of concern. No, I will avoid this step. Where I would go? I would directly go to this particular step. That's why it will discharge. This equation I will write down. I will get the value of T. Then in this waveform, I would know that value of T is coming out to be 190.56 microsecond. Then, sir, this particular equation will be my matter of concern. I will get this particular value 126.08. I will simply add them up and get the final answer. It depends on how much practice you are having. And now this was the concept of a vibrator, astable multi-vibrator. Okay, it was the concept of a multi-vibrator, astable multi-vibrator. Okay, so output is changing from 0 to 5 volt, 5 volt to 0 volt, 0 to 5 volt, 5 volt to 0 volt. So it is known as astable multi-vibrator. Okay, 5 to 0, 0 to 5, that means there is no steady state. Your output is continuously changing between 0 to 5 volt. So astable multi-vibrator we have studied. Okay, usually people apply the formula, but IIT's professor, when they are setting up the question paper, what they can do is that I have actually removed that particular slide. There, one question I have framed, no, there was this kind of question was there in the slide where I showed you. Like I have removed that particular slide, but I told you to remember. I told you to watch two videos. One was based on OpAmp, other one was based on some question. So that was also based on astable Smith trigger only, astable multi-vibrator only. So these kind of question, if they frame, then your formulas will not work there. So always remember one thing in analog, remember zero formula. They can always frame some question where formulas will not work. Okay, so take care of this particular thing, that don't depend on the formulas, depend on the analysis. Okay, so we have solved this one, then we need to solve this one as well. It is a simple question, but detailed analysis will be interesting. So in this video I am not going to do the detailed analysis I have already made, but here I will tell you that how to approach this question in the examination hall. So I will do it, but I will take some break. So after taking some break, I will again come back. You can also take some break. Okay, then we will see this particular question. Hi everyone, welcome to PrepFusion. So in this video, we are going to solve a very good question on analog electronics, you can say, or you can say it will require the concept of transient analysis as well. So analog and network both combined are there. Okay. Now the thing is, there is 1 volt of battery. There are two switches, Q and QB switches are there. Then there is this RC circuit, and the capacitor is having a voltage of V0. And that V0 voltage is fed as an input to non-inverting Smith trigger and inverting Smith trigger. And those non-inverting and inverting Smith trigger is giving Q and QB as output. So those Q and QB are running those switches. Are you getting this point? So output of Smith trigger could be either 1 or 0. And what does that mean? If QB is 1 or Q is 1, that means switch is on. If both are 0, that means switch is off. Basically, Q equals to 1 will turn this switch, it will turn this switch on. If Q equals to 0, then it will be off. If QB equals to 1, then it will turn this switch on. If QB equals to 0, then switch will be off. So I hope the question is clear. They have given the threshold voltage of Smith triggers as well, that is 0.25 volt, 0.75 volt as well. And saturation voltage is 1 volt and 0 volt. What does that mean? Their output could be 1 volt or 0 volt. You need to find the frequency of oscillations at Q, QB, or they could have asked at V0 as well. Now in this question, I did not give the characteristics. I have just written the name, non-inverting Smith trigger. So yesterday I took a session on OpAmp in positive feedback. There I told you it is not necessary that they will give you the characteristics. They can directly write down the name as well. In GATE 2021, there was a question in electrical. There they did not give the characteristics. They just told that it is a inverting Smith trigger, and then they gave the threshold voltages. That's it. And they also told the saturation voltages as well. So it is not necessary that characteristics will be given in the examination. So you should know how to make the non-inverting Smith trigger characteristics, how to make the inverting Smith trigger characteristics. So for that you need to watch yesterday's session. But if you know how to make the characteristics, then you can proceed with this particular video. So let's first make the characteristics, because without characteristics we will not be able to solve this question. So for inverting and non-inverting we need to make. So first we are making for non-inverting Smith trigger. So what did I tell you? There will be a dead zone. So first that dead zone we will make. Output could be 1 volt and 0 volt, and thresholds are 0.25 and 0.75. Everything is positive. So this is how the dead zone will look like, right? Here this input voltage, if it is 0.25, then it is 0.75. This I am making for, look here, the input of Smith trigger is V0, right? Input of Smith trigger is V0. So here I am writing V0. And output of non-inverting Smith trigger is QB. So here I am writing QB. Are you getting this point? Right? Then if it is non-inverting Smith trigger, what do you mean by non-inverting Smith trigger? That for higher voltage it will give higher output, and for lower voltage it will give lower output. Right? In that manner. Okay. And what will be the direction of rotation? Since it is non-inverting, that means direction will be anti-clockwise. Direction will be, let me use another color of pen. Direction will be anti-clockwise. Non-inverting will have anti-clockwise direction, because I told you everywhere whenever we take angle we go anti-clockwise. Whenever we talk about nothing that is being inverted, That means if we talk about positive thing, what does that mean? If we are talking about positive, that means anti-clockwise. So this is how I will make the characteristics, and here both sign of arrow will come. Both sign of arrow will come. So this is the characteristics of a non-inverting Smith trigger, and you should know how to read these characteristics. That also I have told. You will work from here to here in this manner, and then you will work from here to here in this manner. Okay. Here both kind of arrows are there. So both kind of arrows we are making. Right. Now let's make the same for inverting Smith trigger as well. So for inverting Smith trigger, this will be the same, but the difference will be, this difference will not be there. Both will be having the threshold voltage of same threshold voltage is there, but the difference will be, since it is inverting Smith trigger. What is the meaning of inverting Smith trigger? That for higher value of voltage you will get lower output, for lower value of voltage you will get higher output. And how will be the rotation look like? It will be clockwise, right? Okay, and here both sign of arrow would be there. Here both sign of arrow would be there. And output, positive output is 1, lower output is 0, positive output is 1. So this is the characteristics. Now what is the initial condition? Initially there is no charge on this capacitor. So this initially this is having 0 volt. Now this 0 volt will be fed here. This 0 volt will be fed here as well. So at 0 volt, if input is 0 volt, that means if V0 is 0 volt, this guy is saying that you should go to, QB should go to 0, and this guy is saying that Q should go to, what is this output? This is your Q. Ambiguity will be there when you are in the dead zone. When you are in the dead zone, at that time ambiguity will be there. But now, if your input is 0 volt, if your V0 is 0 volt, that means if this is 0 volt, then QB is saying that you should go to 0 volt, your output should be 0. Your output should be 0, and Q is saying that I should go to 1 volt. So when at the initial condition, this guy is going to 0 volt and this guy is going to 1 volt. So this guy is going to 1 volt here. Wait a second. What is the issue? Okay. Sorry. I just made it opposite, right? QB is saying to go to 0 volt. QB is saying to go to 0 volt. Yeah, and Q is saying to go to 1 volt. Q is saying to 1 volt. Yeah, okay. Fine, it is fine only. So QB is saying to go to 0 volt. That means it should be open. It should be open. And Q is 1. That means it should be closed. That means this will turn on. Q is 1 means it will be closed. It will turn on. So now 1 volt will be coming here. Basically, this battery will be turning on now. Now this 1 volt will be coming here. Now what this 1 volt will do? Look, this will be made from OpAmp. So this will drive 0 ampere current. These are ideal, so they are driving 0 ampere current. So because of 1 volt, whatever the current will flow, that will flow from the capacitor only, no? So now this 1 volt will charge the capacitor. So capacitor will develop some charge. So that means your V0 is going up. Your V0 is going up. From 0 to a certain value it is going. So if your V0 is going up, that means you are moving in this direction now. You are moving in this direction now. So which characteristics you will follow? This characteristics I will follow now. If my V0 is going up, so this characteristics I will follow. Here I will follow this characteristics, and here I will follow this characteristics. So now what both of the characteristics are saying? Both of the characteristics are saying that the transition will be at 0.75. The transition will be at 0.75. So both of the characteristics are saying that if your V0 is 0.75, at that point there will be transition. So until you reach 0.75 volt, till that point there will be no transition. That means till that point your Q will be 1 and QB will be 0 only. Say yes or no. Right? All good? All fine? Okay. So now the scenes are, your V0 will start developing the voltage. What your V0 can see, what your capacitor can see, that 1 volt is applied. So your capacitor can see 1 volt is applied. So your capacitor will start developing the voltage. It will try to go up to 1 volt. So your capacitor will try to go up to 1 volt. Capacitor will try to go up to 1 volt. And what is tau here? Tau is RC. Tau is RC. 2 nanofarad, 1 kilo ohm. That will be 2 microfarad. Sorry, 2 microsecond. So this will be the same. But there is a transition. There is a transition at when your V0 becomes 0.75 volt. So till the point 0.75 volt we need to analyze, because after that there is a transition. That means after that the circuit condition is changing. After that what will happen? QB will say that I will be 1 and Q will say that sir I will be 0. That means QB will say that now I will be turning on, and Q will say that I will be turning off. So circuit condition will change. So capacitor equation will also change. So until the point we reach 0.75 volt, till that point we need to analyze it. Are you getting this point or not? Here the concept of multivibrators are being used, but don't forget, don't think anything. Multivibrators, what is multivibrator? If you don't know, still you will be able to solve the problem. Right? Even if you don't know what is multivibrator, still you will be able to solve the problem, because this is simple RC circuit, charging, discharging. Multivibrator is nothing but it is a Smith trigger with RC circuit, nothing else. That's why I took this question, so that your concept of multivibrator gets cleared. So what is happening here? Until you reach 0.75 volt, there is no change in the circuit. That means capacitor is getting charged. But after 0.75 volt, there is a change in the circuit. So circuit condition will change. After that, we need to analyze again. So now capacitor is developing the voltage. But till what point it will develop the voltage? Until it reaches to 0.75 volt. Okay. So now till what point, till what time? So this time will be, you can calculate it, ln 4 into 2. 4 ln into 2. So this time is 2.77 seconds. So what do you see? Initially what is happening is that your capacitor is getting charged. This V0 value is getting charged. Your V0 is getting charged. Right? This V0 is getting charged, and it was charged till 0.75 volt. It was charged till 0.75 volt. And in this condition, what was the condition? Your QA was 0, I guess. Sorry, QB was 0 and Q was 1. This is your QB and Q. So in this condition, your QB was 0. So till this point, till this particular point, your QB was 0. Your QB was 0 and Q was 1. Right? Let's see what happens next. Now, just as it goes above 0.75, let's just say it goes to, now the capacitor is charged to 0.75. Okay, let's remove this 0 volt, 0 volt. This I already know it will drive 0 ampere current. Let's remove this off. Now let's remove this off as well. Okay, so now what is the, this 1 volt was there, but now it is charged to, let's just say 0.76 volt. So now at 0.76 volt, what will happen? At 0.76 volt, QB will say that, sir, I will be 1, and Q will say that, sir, I will be 0. That means Q is saying that, sir, I will be 0. That means I will be open now. And QB will say that, sir, I will be closed. So now here 0.5 volt only reached. 0.76 did not reach. After 0.5 only, they started saying that, sir, I will be open and I will be closed. Now what is the equivalent circuit here? This is connected to ground, right? This end of resistor is connected to ground. So this has become simple RC discharging circuit, right? Now from the capacitor, current will flow and it will discharge the capacitor. Capacitor has only one path to flow. This is the only path, because input of OpAmp will drive 0 ampere current. So capacitor will discharge from 1 kilo ohm only. So capacitor is having only one path to discharge. So now it will keep on discharging. That means my V0 is going low. From 0.752, it will try to go to 0. Capacitor will try to discharge completely. So from 0.75 volt to, it will try to go to 0. But will it be able to reach 0? Let's check that out. So what will happen? Now your input is decreasing. Now you are going from 0.75 volt to 0. 0.75 volt to 0. So that means you are moving in this direction. So which characteristics you will follow? This characteristics you will follow. You are moving in this direction, right? You are moving in this direction. Which direction? In this direction you are moving. So this characteristics you will follow now. So in this characteristics, where is the transition? The transition is at 0.25. This characteristics was there, and here this characteristics was there. So where is the transition? The transition is at 0.25. Right? So now your V0 will go down. Your V0 will go down till it reaches to 0.25 voltage. Right? So initially your V0 is, as of now, at 2.77. At 2.77 seconds, your V0 is having 0.75 voltage. Now what will be the equation of V0? V0 will try to, from 0.75 voltage to, it will try to go to 0 voltage. So this will be the equation, discharging equation. It will try to go to 0 voltage, but from where we are starting our circuit? We are starting our circuit from 2.77, no? Yeah, 2.77 seconds. This is in microsecond. This is in microsecond. Since we are starting our circuit from 2.77 seconds, so here I will put 2.77 microsecond. Okay. divided by, although it is not required to put this 2.77 microsecond, you can solve with respect to t as well. In the examination we will solve with respect to t only. So this method I again and again teach you that you should solve with respect to t only. Basically from 0.752 you need to go down to 0.25 volt. So how much window of time you require, based on that you can solve. So what was that time period here? It was 2 microseconds. So now till what point it will go? Till 0.25 it will go. So till 0.25 it will go, e to the power minus, so you can simply solve it, whatever the value you get. So you can solve it 1 by 3 ln 3 ln 2 into ln 3. So 3 ln into 2 plus 2.77. So it will discharge till 4.96 second. So basically here it will discharge till 4.96 second, till 4.96 second, and the voltage it has reached, that is 0.25, that is 0.25. Okay, so what is the value you are getting? 4.96 volt, 4.96, 4.96 microsecond. So now in this window your QB was 1, in this window your QB was 1. In this particular window your QB was 1, but your Q was 0. Okay, now what will happen? Now let's just say your V0 was going down. Now it has went down in a manner that it has reached to 0.24 volt. It has reached to 0.24 volt. Now if it has reached to 0.24 volt, then what this characteristics will say? 0.24 volt. 0.24 volt will be here. So this QB will say that sir I will go to 0, but this Q will say that sir I will go to 1. So Q is saying that sir I will go to 1. That means now the switch will be turned on. So this switch will be turned on and this will be off now. What will happen now? This 1 volt will be coming here, but this capacitor is already charged to 2.5 volt, right? So now the V0 value will go up from 0.2, not 2.5, actually 0.25. So now this V0 value will go up from 0.25 to it is going up. So if it is going up, then that means which direction I need to follow? This direction I need to follow. Which direction I need to follow? This direction I need to follow. Since your V0 value is going up, that means input of Smith trigger is going up. So now I will follow this characteristics, right? Which characteristics I am following? This characteristics I will follow. So in both of the characteristics, where is the transition? The transition is at 0.75. So now your capacitor will say that sir I will charge up to 0.75. No, capacitor will say that sir I want to charge up to 1 volt only. But these characteristics will say that you can charge up to 0.75 only, because after that the circuit condition are changing. After that what will happen? Again QB will be 1 and Q will be 0. That means again again this will be on and this will be off. So are you getting to know that what is happening with the switches? On off, on off, on off. At one time one is on, at the other time other one is on. One is charging the capacitor, other one is discharging the capacitor. So there is kind of oscillations. So that frequency of oscillations they are asking. So now in the next cycle you will be able to understand what is happening. You need to go from 0.25 to 0.75. But you need to go from 0.725 to 1 volt. Capacitor will say that sir I will try to go to 1 volt. I will try to go to 1 volt and my initial condition is 0.25. So what will be the equation? These equation you should be having habit to write down. So capacitor is saying that I will start from 0.25 volt and I am trying to go to 1 volt, right? But in between, where it will try to, at what point it will stop? At 0.25 volt it will stop, because after that the circuit condition will change. Say yes or no? Sorry. It is okay. It is rising. Sorry. Where it will stop? At 0.75 it will stop, because after 0.75 volt, where is the transition? The transition was here, no? At this point the transition was there, because now input is increasing. If input is increasing, that means transition is here. Transition is at this point. Transition at this point. So when you reach 0.75 volt, it will stop. Here what you are going to write? From where you are starting your circuit? You are starting your circuit from 4.96. You are starting your circuit from 4.96 divided by your time period, that is 2 micro. Okay. So now I can solve this equation and I will get the value of t from here. So this I need to equate to 0.75 and then this is how I will solve it. So 3 ln into 2 plus 4.96, 7.157. So t value I am getting is 7.157 seconds. Okay. So basically here what is happening? Now this is getting charged. Till what point it will charge? Till 0.75 volt it will charge. Then again the same circuit condition we will get. Which circuit condition we will get? The same condition that you got here. What will happen? Now what will happen after this point? Till this point what is the scene? That your QB is off and your Q is on. That means capacitor is getting charged. But since you have reached 0.75 volt, after that what will happen? Let's just say next condition is 0.76 volt. So at 0.76 volt, this guy will say that, sir, I will go to 1. QB will say that, sir, I will go to 1. And Q will say that, sir, I will go to 0. So if Q is going to 0, that means this will be off and this will be on. That means capacitor will discharge. So again capacitor will discharge, but it can discharge up to 0.25 volt only, because after that again circuit condition is getting changed. So now you are able to read the characteristics as well. You are able to understand the meaning of characteristics as well. And in that manner, you are able to solve the problem as well. Right? So now you can see that there is constant charging, discharging, charging, discharging. So this will be your steady state cycle. In that manner, charging, discharging, charging, discharging is there. Okay. They are just asking frequency of oscillations, which is pretty easier. So here which window we got? We got the time window to be 7.517. 7.157, no? 157, 157, 7.157. So this is your time period, right? This is your time period. This is not the steady state. This was just the one state. After that, this is the steady state. Actually, what will happen is that now it will not go below 0.25, right? It will not go below 0.25, then till 0.75, then again in this manner, then again in this manner. It will keep on going like this, right? It will keep on following this path. So this window is being repeated. This window is being repeated. This window is being repeated, right? 7.157 minus 2.7 minus 2.77. So that is 4.38. 4.38 microseconds we are getting. So this is the time period, that is 4.38 microsecond. And if they are asking frequency of oscillations, then just you take the reciprocal. So 227.93. 227.93 kilohertz. So this is the frequency of oscillations. So this is the final answer. A very good question it was. Okay, and I hope you enjoyed the analysis. So this is how it will go. So you should know how to draw the characteristics of non-inverting Smith trigger. Again and again I am saying, in the examination it is not necessary that they will give the circuit. It is not necessary that they will give you the characteristics as well. They can just mention the name and they can give the threshold voltages and the saturation voltages. So it should be you who needs to draw the characteristics, and it should be you who needs to understand the graph, that how it goes. So in the last video only where I taught Smith trigger, there I told you how to read these graphs. So this is where we started from. We did not start from Smith trigger. We started from here, that how to read these graphs. Then we went to Smith trigger because our target was to make these graphs using Smith trigger. So that we made. And then there is another concept, that is of astable multivibrators. So that is the same kind of concept. You will use a Smith trigger there and then you will apply RC circuit there. And then the capacitor will charge and discharge, and based on that your output will keep on oscillating. And if your output keeps on oscillating, so it will be a oscillator, and based on that they will ask you the frequency of oscillations. So you can analyze the circuit. Now I hope I have given enough concept. Since this was revision video, these were revision concept. So now I don't think I need to bring another video based on astable multivibrator. So now you can analyze it on your own. And secondly, I am not asking for views, but the last video got a very less response. I don't know why. There I taught amazing concept of Smith trigger, but still that video got a very less response. So I think it is not required. I'm not saying that I need views as of now, because it's you guys, you need to study because your examination is just after 7 to 8 days. So I don't need views. I'm not asking for views. I'm just saying that it feels like that it is not required. So as of now it is not required, then I will bring something different. Like people were asking for oblique incidence, so that I can think of bringing. Okay. So yeah, and if you want to solve these kind of problems, like these kind of very good problems in your, like if you need to solve, like if you want to revise your notes, if you want to revise the questions, and if you want to solve these kind of problems. So this was just one question. There are a lot of questions like this. There are 400 questions here, 400 questions from 5 subjects. Okay, so you can solve these questions. Like every particular question will require 2 to 3 concepts combined, and after these 400 questions, at least 370 questions, or at least around 350 questions, I and Anish sir have personally framed. Okay, either we have framed it or we have got from NPTEL lectures. So these are very good questions. Like people will find it tough, but they are very conceptual, and not a single concept is out of the syllabus, because we ourselves are framing the problems. No, so nothing is out of the syllabus here. Like in this question, will you call it out of the syllabus? No. A lot of people will call it out of the syllabus because they are not able to solve it. But non-inverting split trigger, you know, inverting split trigger, you know, RC circuit charging, you know, switch, you know. So what is out of the syllabus here? Here I am not framing anything that is not even mentioned in the syllabus, like a random formula based question. No, here you will never get any random formula based question. All are conceptual problems here. So try solving it, and you will certainly get your subject on a next level. Okay, the understanding will be on next level, that I can guarantee after solving this particular playlist. Thank you very much. Let's meet in some other session. Yeah. Okay.